Okay, so good morning and welcome everyone. So we are here at the Brussels Institute for Advanced Studies, and this is an event on Europe's vision on responsible AI. So the idea is that we have here a one-day event where we can talk about research, practice, and policy, and we can have everyone network later on. So the goal is to talk about responsible AI and how that affects the society, environment, around everyday lives. So this is an event that is co-organized by us. So my name is Dimitris Zacharidis. I'm a professor of data science and engineering at ULB. And together with Leander, who is out of the picture, and Carl, so you want to join, and Benoit, we have organized this event with the valuable help of the local BrIAS organizers. So Anya, who is sitting behind the scene, and Mertadol also, who is somewhere here as well. So thank you very much for your support. And I would specifically want to thank the program directors of the 2025 program, which is on sustainable robotics, AI, and automation. And I would like to give the floor to Emanuele Garone and Nanove, who are the program co-directors, and they would like to present their work on BrIAS.
Okay, so fast change of computer, hoping that it works on the fly. So welcome everybody at BrIAS, the Brussels Institute for Advanced Studies. If my computer helps me, I would like to give you a short introduction to what is the Brussels Institute for Advanced Studies, fancy names, but for what, and to give you an overview of how this event fits in a much larger program that we are carrying on. So Brussels Institute for Advanced Studies is this place where you are now. This place is composed by this seminar room, by a second room upstairs, the foyer where you already had the nice breakfast, and also a group of apartments, because the idea of the Brussels Institute for Advanced Studies, that was the first Institute for Advanced Studies in Belgium, is an idea that came out from the two former rectors of ULB and VUB, Yvonne Engler and the late Caroline Powells, to whom this room is dedicated, as a place that could be an incubator of idea, a place where people from different backgrounds, academics from different backgrounds could meet. And by meet, we also intend that we have a program for international visitors that we call fellow, that come here, reside here for a minimum of 1 month up to 6 months, to exchange ideas with the local group, to work with the other fellows, and to try to strive with new ideas. So here an example of one of our studio and the room upstairs. So the program started in 2021. At the time, we didn't have yet this nice building. And the first few years, the team, because we have every year a slightly different team. At the beginning, the team was on sustainable food. The teams are always linked somehow to sustainability, since it's one of the objectives of the two universities. Last year, which I co-directed together with my colleague Bram van der Borg from VUB, Karl Mork, and Anne Jacobs from ULB and VUB, was on robotics. And this year the team has been enlarged to also include AI. It's the reason why you are here today, I imagine, and control. So just to give you a fast overview, at the moment, during this season that goes from January to May, we will have a total of 17 senior fellows. We also have one resident artist. As said, the Institute for Advanced Studies is a place where we like to have people from different backgrounds, possibly from very different backgrounds, to cooperate. So we always have, in a collaboration with Home, a resident artist. Last year we had 2, this year we have 1. But this year we are also blessed by the fact that one of our fellow is an expert in AI and art. We have a number of junior fellows that are postdoc of the 2 universities that help. 2 program directors, so you have one in front of you, unfortunately, because I'm boring you, I know. And then various deputy directors. So just to give you an overview, we have 4 main themes this year. That is smart agriculture in continuation with what we did in the past, energy, well-being in cities, and then AI, threats and security. And here we are what we are doing today. So it's very much about AI and trust. So overall, the program is composed of more than 100 seminars. So every Thursdays. So if you're interested around lunchtime, we are having seminars here with our fellows. Usually we have from 2 to 3 seminars. Then we had other larger events like this one. We had 2 scientific conferences. One was in February, the other will be in a few weeks. Various public forums like this one, and we still foresee the organization of one industrial forum. So the goals are different, but the main point is to foster new ideas, and we say possibly crazy ideas, because they're the ones that make science advance, and to foster collaboration between people. So I hope this will be very much in the spirit of today. To try to involve young researchers is the reason why we have junior fellows, and to become a meeting point for the scientific community, and it's the reason we have this kind of events. We also like very much the idea that this can be a place where academia can meet institutions, so very often we have programs where we invite people from the political world, people from the policy world to interact with us, and also with the industry. So I'm almost at the end, I promise. So as said, we have 2 major conferences this year. One up in February was on agriculture, and there will be another one on the 22nd and 23rd of May on battery management systems. So in case someone of you is interested on the subject, you are still in time to register. And we have a series of public forums. 2 were already passed. One was on smart cities and the other on AI and law. There is the forum of today that I'm sure it will be very successful. It is actually the forum with the largest number of registration we had this year, so congratulations to the organizer. And we will have a last forum on the 19th of May, that it will be on a matter more related to defense and security, that is the protection of critical underwater infrastructures, where we will make engineers, military people, people from ethics, people from policy, and from the institution to discuss in the same room about this unfortunately up-to-date subject. So this is everything I wanted to say today. So I wish you a very pleasant and very fruitful day of collaboration, chats, and hoping also enjoyment. And that's it, so thank you.
So I would like to thank again Emmanuel and Anne for the opportunity to have this forum here live, and thank everyone who has helped behind the scenes and all the people that have registered and would like to participate today. I would also like to thank our sponsors. So first and foremost, BrIAS for hosting us here at this lovely building. We have also received funding from FNRS and also from the European Union. And I would also like to help the 3 AI research programs in Belgium that have embraced this public forum and have agreed to participate. So I'm talking about FARI, which is the AI program of the capital region of Brussels. Trusted AI Labs, or TRAIL, which is the program of the Walloon and Brussels regions, and the Flanders AI Research program, or FAIR, for their participation. Regarding the program, so we are just wrapping up the welcome, and we will immediately start with the first session on research. Take a pause for a coffee break, come back for the second session on practice, have lunch, come back for another session, policy, coffee break, another session networking, and finally we invite you to stay here at the foyer of the BrIAS hall to have a small reception. So the idea is that we want to bring together different kinds of people in this event. So we want to hear from researchers and that are pushing the boundaries of responsible AI. That will be the first session. We also want to hear from people that are responsible for implementing AI programs. So we would like to hear from the 3 AI research programs in Belgium, but also from academia and industry. How do they put, how they implement responsible AI? Then we also want to hear about policymakers and how they shape the future of EU and what is the global position of Europe with respect to how to use AI in a responsible manner. And finally, at the last session, we want to get to know each other. So we have invited every researcher and practitioner to join us here and maybe present a short presentation on what is their expertise, but also mostly to talk to each other over the reception. So with this, I would just like to straight move on to the first research session. So it's about research, and I would like to welcome here Jerzy Stefanowski from Poland. He's a full professor at Poznan University of Technology, working at the Institute of Computer Science. And Jerzy will talk about the role of counterfactual explanations, new methods, and open challenges. So let's join me in welcoming Jerzy for his talk.
Thank you.
So you have to stay here. So
Yes, I know it. Works.
Perfect.
So hello to everybody. First of all, I would like to thanks to Dimitris Sacharidis and all the organizers of this meeting for inviting me. It's a great pleasure to be in an interesting room and the institute with quite ambitious program. Because time is a bit limited, I will go very quickly to my presentation. Dimitris already announced the title. I'm from Poznan Universiteit Technology and also with Polish Academy of Sciences. And the plan is approximately like this. I will be looking at you and slightly modifying it. Explaining machine learning models, general highlight, and the specific approach is counterfactuals. And we will start from something simpler, which is MCDA analysis, I hope, and a bit more advanced about plausible counterfactuals, and if time, something for networking reason works. Without spending too much time, if we refer to responsible AI, or here in Brussels, if we use more European Union term, trustworthy AI, explainability is one of the main pillars, I would say. And there are a lot of arguments, but I need a longer lecture to discuss aspect of explainability. So just say a few words. Although we have a big progress in machine learning systems, very good predictive accuracy is not the only criterion. In many applications, you should take care about other issues. And in many domains, you need to know something about reasons of prediction. because people will not trust the system, for instance, in critical systems. I personally share more as a first motivation, which says that good explainability, it's still very young area. So good explainability, I think it's a topic for the talk during the break. Should support us, for instance, in detecting some biases around performance of the system, unfairness, and all other issues, and hope we can use explanation in some action to improve it. Of course, if we refer, for instance, to recommendation of high experts of European Commission, there are also application or regulation perspectives, but probably it's another session. And without spending too much time, there is one definition, if somebody is interested, Fosca Gianotti, Dino Pedresci, and Riccardo Guidotti Pisa, after me. So we should present something interpretable potentially, at least to comprehend way. And the question is what to explain. There are different approaches. Some people explain, and mostly people explain local predictions of the model, so why the particular decision has been made. Some people attempt to explain more globally the model, and we can also distinguish whether the explanation, like in this picture, is only a single instance, or the area around it, local neighborhood, or more global. We'll come back to it later. Nevertheless, I think there are a lot of open questions, for instance, to whom and how we propose this explanation. There is no universal explanation, and probably we need another explanation to a specialist, ML engineers, some other advanced user, let's say experts in the domain are different, and potentially in the future auditors. So no universal solution, many methods. In this talk, I will focus on a particular way of explaining, which we called counterfactual explanations. So coming to the topic, I hope that some of you have learned about it, but if it is a new topic for you, it's a very particular explanation. Let's have a look at this example from Molnar book. So somebody is applying, for instance, for the loan or the product in the bank. His or her application is rejected. And here is something, untypical explanation. We are not answering why this explanation was rejected, for instance, by a specific black box algorithms. We give another explanation saying what would have happened if you change something in your application. So as you see in this picture, the explanation focus attention on particular attributes, see in your application income, number of credits, previous age, or something like this, and what kind of changes you should do that if you come back with modified application, the decision of the system will be preferred one. So accepting. And as you could see, it's something about how to change feature values or description of your example to obtain a more desired prediction of the black box model or generally automatic model. And there are other, let's say, application domains. If you try to sell something, apartments, how to change it to get better offer, and how to get better insurance, recruitment, some medical procedure, and so on and so on. And there is a very nice, in my opinion, Riccardo Guidotti survey, which finally was published in Knowledge Discovery, I think 2024, and you can read much more on it. Having a bit, I would say, not too much mathematics, but some formula. You have a black box, which you can see age. You have an instance. Most of the research are on the basis of tabular data, but you could also imagine some images, text, etc. And you have some changes. Sometimes people call them perturbations. So some action of modifying the description of it. So a counterfactual explanation is usually some allowed changes, let's call them perturbation, which lead to desired stage of the prediction of black box model. Ruth Byrne, who is experimental psychologist from College Dublin, she calls it's a specific psychological cause-effect action, which has some, let's say, more psychological context. But looking at this picture here, you can see the approximation of decision boundary and a wrong for the applicant decision. A counterfactual shows a possible counterfactual generation algorithm, rather. So the algorithm is showing few possible changes. They are going on the opposite side of the decision boundary. Of course, there is a question, if we have so many possible things, how could we work? And there are a lot of methods, by the way. Most of them now are based on the optimization, the heuristic search, and others. You can find, for instance, here, lower in Guidotti talk, some review. And without saying too much, also referring to this psychological or other discussion, counterfactuals, if we think about them, are appreciated, or at least some psychologists claim are appreciated by people because of these reasons. And some of them is that they provide ground to somehow contest the decision of the model and to understand how it could work and allow intervention. So the change. But time is going on, so let's go to some proposal. First of all, if you still remember this picture from one original instance, which is somewhere here, you can obtain, depending on the method, several possible counterfactuals. So which of them? So you must have some properties. And these are from literature, some desiderata to good, what they call good counterfactuals, properties. First of all, you should change the decision, so validity. In many cases, people prefer to optimize the distance between proposed changed example to the original. Could be measured in different ways. So in this picture, for instance, coming from here to green is longer or more distance option than to the red. So the red could be preferred. Psychologists say that we should think about sparsity or minimality of changes of feature. People prefer, if you go to the bank and you receive, for instance, a counterfactual saying change, 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 change. So the smaller is better. Actionability, which means that in some cases it's difficult to change some features. For instance, to change the gender or to be younger. In something it's impossible. And there will be a part of my talk about plausibility. So it's coming to feasibility or realistic understanding. And usually people do not prefer a proposal which is outlier, put in the empty space. So plausibility is a kind of definition that your proposed counterfactual is located in somehow distribution of realistic cases. Some people require to fulfill causality, generation time, and also other properties. So the first proposal of the particular method developed by my colleagues is based on the observation that for the same example, if you use several methods, even similar on the principle, you obtain usually completely different proposals of counterfactuals. You should understand it because people are inventing new algorithm with another optimization or heuristics, etc. The example behind me, I'm not sure whether Anne is seeing it from the, by the way, hello, from the last row. It's the case from German credit data, very famous. The same example. Upper is Codex method, which is a kind of search with the gradient optimization. As you could see, X is the original, X prime is the proposal. Only a few attributes changed. FEMAP is also optimization, but with more advanced neural networks. And as you could see, it changes many attributes. So you obtained counterfactuals with different properties. Of course, we could ask a question, which solution is better? Nevertheless, time is limited, so I prefer to ask another question. Could we exploit diversity of these proposals? There are some methods, even Molnar proposed a kind of evolutionary approach to produce a subset, but here the solution is slightly different. Many years ago, I worked on ensembles of classifiers, so my motivation and my colleagues was, let's make an ensemble of different methods which produce counterfactuals explanations. So you have the input instance, you have several explainers. They produce sometimes a single counterfactual, sometimes many counterfactuals. And you should somehow filter them and reduce the number of properties following the preferences of the user. And what we have proposed is somehow sketched here. We have chosen several, let's say, well appreciated in the literature methods, a few years ago at least. And another criterion was the software library was running, which is a long story because some methods are not running as authors described. So having these two perspectives, we have chosen, as you could see, 9 methods. Some of them were particularly tuned to produce several counterfactuals. Usually they produce one, but fighting with some hyperparameters, you can mate them to produce a subset. Okay, so the first checking was when we obtain, just to give you, on average, something like 60, 70, or sometimes more proposals of counterfactuals for the same instance. Validity check, because not all methods for the same instance are producing required output. A bit strange, but in practice, it's the first criterion to check whether you have validity. Another, if the data have some constraints on the attributes, actionability, for instance, changing the gender, being younger, so monotonic direction, and so on, we were checking whether they are satisfied or not. So again, some examples were rejected because they didn't fill it. Many methods are not taking count in these things. And the third, it's a preference now. So we somehow model a decision maker and some criteria, as you have seen, to these properties and measures. And in this example, we considered 3 criteria. Proximity, which says the closest to the original is the better. Feasibility, analyzing the neighborhood of the proposal. Let's check it. I guess I'm speaking too slow, but it will be good. Thanks. So coming back to the talk, we prefer that it is in the dense area. And second, a very simple approximation of the probability in this area. In the next part will be more sophisticated. So analyzing the neighborhood, whether they are from the same class. And as you could see, for instance, on these 2 criteria, preference is smaller. Some examples of counterfactuals create Pareto front, while others are dominated. So they are worse on each criteria. So we skip all worse solutions. And we should analyze the Pareto front. Part of our paper to convince you that experimentally it could work. We have tested finally 8 or 9 data, but for instance on adult and German, this approach approximates for you approximately per example, testing example, about 80 proposals. Validity, you are reducing it to about 60 something. Actionability, again, you reduce the number of candidates to 60. And building a Pareto front you obtain something which probably could be analyzed by a human, which is 7, 12. And if you would be more automatic way, so you do not want to develop approach which could be an interactive dialogue with the user, how to exploit this Pareto front and to find, according to preference, a smaller subset, the simplest old idea from multi-objective optimization is to have a reference point, could be ideal point, the best possible values of the criteria, and to look on the Pareto front when you have non-dominated solution, so some alternatives depending on the distance and direction the closest solution. So even an automatic way without strong additional preference, you can get one proposal. You should check our paper for more details on it, because time is going on. I have taken a small table, and I would like, I'm not sure it's a small, but as you could see, there are single methods. There is a random selection from this Pareto front and our approach, and if you try to have, let's say, multiple models, multiple criteria analysis with average rank, this proposal is in some sense a good trade-off, because it's the best. Of course, if you focus on a single criterion, some of them could be better. But if you would like to have a trade-off, in my opinion, it gives you a balance. You are still alive, not so bad. So let's move to the second part. Because this was a kind of aggregation of existing approaches, nothing new. So here it will be a proposal of new method. Motivation, plausibility. It means the produced solution, the proposal of counterfactuals, it's better to be trusted by the human if it is located in the area you expect, at least in historical data, there were historical examples of this decision. So in more probabilistic way, I would say it should be located in sufficiently dense region of original data, but in a desired class. Just to give you a quick example, let us imagine we have a very simple linear classifier. On this side is class A, on this side is class B. And the counterfactual will tell you how to move from example of class I to class B. If you look at this picture, not so bad. In both directions, we are changing the classes. But the question is, where are the original data? By the way, it's a joint paper with my colleagues, and you can find last year ICAI proceedings. Okay, let us imagine it is something like moon data set. And danger is, you can say moons or croissant here in Brussels. So one class is, as you see here, and the second is somewhere here. No perfect classifier, because it's rather nonlinear, as you see. But immediately you could notice that some proposals are out of distribution. They are not proposed in the area where the desired class is. So this is what we would like to correct in some sense, because we prefer other direction, other vectors showing the change. So if we think again about these shapes, we can require that we estimate the probability, conditional probability of the class, and some isoquants show us where is the dense area with the correct class labels. So if we start from here, we would like to be here. So if you think about the essence of our approach, probabilistic plausible counterfactual explanation, as we call it in this paper, coming from here, minimizing the proximate, it should be somewhere here. Starting from here, we are somewhere here. So depending on the area, the distance is longer or not, but this is the intuition. Of course, you need a bit more mathematics. So if we go to standard optimization, which is a group, I think the most frequent started from Sandra Wachter, very influential paper. It's something like optimization of the function when you have the distance between original x and counterfactuals, loss function on the change of the class label, and some weighted sum. And you are looking for such counterfactual which somehow minimize it, trying to pay more attention to the changes of the class. It's unconstrained optimization, but you can also define it as a classical constraint for some solvers. And there is a related work, unfortunately. And this is Barbara Hammer with her PhD student Artlet. So they proposed to think about this problem in constrained way, so minimizing the distance and requirement to change the class, and somehow estimate conditional probability, knowing that you are in the required class, and you have this description, and to require that if you have a binary classifier, it should be over a threshold. What they did, they used kernel density estimation with some specific optimization. We do not have time. This is an interesting paper, by the way. Nevertheless, we have thought unconstrained optimization is more flexible to handle additional elements, and this is not working good with more dimensions. For a very large number of dimensions and high dimension, it is not efficient. So our proposal in quick. We are changing the formula to unconstrained way. Again, you have the distance, but here you have two loss functions. This part is responsible for if you have a binary classifier, which we consider, but by the way, we could extend it also to multiple classes. We require that the probability assigning to the required class of this black box is over 0 find plus epsilon. Epsilon could be tuned how sure we should be. And this is another condition here on this estimation of the probability. So again, you have somehow estimate the probability that you are in the class and you indicate x, and it should be over the threshold, a hyperparameter to be tuned. So we have another loss function. In our opinion, you can add also additional elements here. And you should assume that you have a differentiable model, because we will use neural networks and gradient optimization to handle it. And this is the second part, which is a good story how at the conference two teams can cooperate. I was coming from counterfactuals. My colleagues are specialists from generative AI, and they have a hammer, a method which is called normalized flow-based density estimation. This is a highly dimensional approach to estimate probability practically by changing some latent variables, and you use a particular generative neural network to do it. Time is too limited. Here is a reference what kind of flow architecture we have used, which is, by the way, Greek proposal, as we have a lot of colleagues here. Very quickly about the results. In the paper, it's a bigger table, but as you see, it depends somehow what is the black box, simple logistic regression, a neural network, comparison to Artlet. If you try to estimate plausibility, not only with this definition, but something like density and LO-if, which is missed here, the proposal is at least slightly better. We are producing always plausible for the same data. With Artlet, not always. There is always the problem with Artlet to run on more advanced black boxes, for instance, so you do not have results. With the time, depends on the data, but not too bad. And there is a comparison with other methods, which is a bit tricky, because some of them are not prepared for being plausible. So you can see that always you get plausible solution, with the proximity and some other coverage of examples, no differences. But if you try to analyze, for instance, the time, it's definitely quite fast method. And because time is going on, there is a short summary. I'm open for the discussion in the break. So this is a method which should generate, in our opinion, quite good plausible counterfactual, relatively fast, with a good balance on other criteria which are not directly optimized. I missed it. We are not optimizing some of these criteria, but we get good results. And there is nice property that we can analyze very quickly, not only a single instance, but prepare a batch of them. And having the same processing, we can move, for instance, more counterfactuals. What about time?
No time.
No time. So just short announcement, because there is no time. For the networking, we have two ongoing projects. One is about the generalization of this approach on groups of counterfactuals. As you could see, this is a nonlinear differences, one moon, another moon. So alternative is global, only one direction of the change, and group-wise is group of examples, and I know Dimitris and other colleagues working on it. We indicate where to move, and we can generalize our approach on it. And the second announcement is, it's currently the paper accepted at KDD with another colleague. We also work on robust counterfactuals, where we say, we give you a proposal. However, when you are preparing changes of the data, the model can be fine-tuned. So the model can be changed. And the question is whether the proposal is still valid. So we are considering it, whether you could, in a probabilistic way, to have a kind of framework to decide which probability of being still a valid counterfactuals. And of course, there are some open challenges, but I think it's a good for a longer discussion. For instance, handling data evolution is still an open issue. Causal dependencies are usually not handled. More complex data, fighting with the model privacy, going more in non-classification tasks, and including more interactive or human-oriented studies, which, for instance, if you spend some time on my slide, I also discuss how should we have interactive session with the users. And because there was no time, this is my university outside me, old and new part, and thanks for your attention. And of course, I thanks very much to my cooperators, because it is not only me, this is the whole team.
So unfortunately, we are running out of time, so I will just like to leave room maybe for one quick question. Otherwise, you can catch Jerzy during the coffee break.
I'm during the coffee break, so I'm available, but there is a question, I see.
One comment. Sorry. So counterfactual at the origin is a causal concept.
Yes.
And at the end of your presentation.
Exactly causal, there is an interpretation on it.
Yeah, but I think humans understand counterfactuals because of causality.
Yes.
And at the end of your talk, you say, okay, at the end, causality is not considered here. I found that the goal is to increase interpretability of the model. If you introduce counterfactuals in a no-causal manner, I don't think it helps.
I completely agree with you. So this is this interpretation. Nevertheless, originally, yes, I must come back to the microphone. If you analyze particular methods, they are not considering, for instance, a graph of causality. So it is present only in some methods. And this is, I'm completely with you, a postulate. We should better handle it.
Perfect. So let's thank Jerzy, and sorry we don't have enough time. So let's move to the second presentation. So this is by Kostas Stefanidis from Finland. So Kostas is a professor of data science, I think, your title, and your institute is...
Namur University.
Yes, but your Faculty of Information Technology and Communication Sciences.
Yeah, it's so big that even
yeah,
we don't remember it easily.
Okay, so please go ahead.
Yeah,
thank you.
Thank you. Thanks a lot for the invitation. I'm Kostas Stefanidis, professor of data science at the Namur University. I'm also the leader there of the Data Science Research Center. Today we will talk about responsible recommender systems, actually with a special focus on group recommendations where we mostly work. I'm not spending much time on convincing you about AI systems, automated AI systems, and about the fact that they are used widely in our everyday lives for searching information, getting news and knowledge, managing our online social life, entertainment, movies, music, videos, even dating, more and more applications on this domain, more traditional stuff like buying products and so on and so forth. So, to a large extent, AI solutions shape our view of reality, our beliefs, our opinions, to some extent who we are, and these solutions, these systems rely on, let's say, sophisticated solutions trained on huge amounts of data for performing different things: content generation, representation learning, risk estimation, ranking classification, and of course, among many others, recommender systems as well. Recommender systems, we can say that they are everywhere, from suggesting products online, streaming services, travel platforms, and many others. They shape to some extent what users see and do, and it is very important to remember that nowadays it is not only important for individual users. Imagine, for example, a case where we have a family choosing a movie, or some colleagues booking a team event, and so on and so forth. What is the challenge now? This system needs to be not only accurate, but at the same time responsible. In which sense? In the way they treat diverse preferences. So, we are talking about responsible recommender systems. This responsible part is an umbrella term for investigations into legal, ethical, different types of things related to solutions or applications of artificial intelligence whose actions are impact usually the lives of citizens in different ways. Here we can see some basic ethical principles: respect for human autonomy, prevention of harm, fairness, explainability. I assume there are many more that we can propose in the near future. Today we'll spend some time on the aspect of fairness. I think we don't have enough time. I'll just touch upon on the explanation part. We already had a very nice summary in the first talk. So, historically, we have recommenders that typically are optimized for accuracy, or so-called relevance, and so. What does this mean? How well we can predict the user preferences, where, for example, make suggestions for movies, for purchases, and so on. But especially when we have many people on the table, multiple people are involved in the recommendation process, this is not enough because we are not sure if the system is treating fairly all the user. And can we somehow explain the reasoning behind the suggestions of the recommender? To this extent, we can say that we are moving from some more simple prediction operations towards a more responsible design. Group recommendations specifically become more and more common in real-world scenarios. We already mentioned them, like travel planning, team collaborations, family movies nights, and so on. These decisions, this type of decisions require merging different preferences, different tastes of the people within the group, and sometimes, or even quite many times, those different preferences are conflicting. So this makes the aspect of fairness even more critical for our decisions. In the group settings, fairness means that anyone's preferences are considered. This is difficult because in these cases, a common problem is domination. For example, one person's tastes always win, or who may have a minority view that is totally ignored, and so on and so forth. So we would like to balance somehow the satisfaction across the users in the team. But first of all, we need to have a more concrete definition, how to define fair, how to measure fairness, and so on. Moving to the explanations part, it will be always interesting to help users understand and trust the recommendations, but especially in the group settings, now we have a different thing. It's not very clear who the explanation is for. Should we justify it for the whole group? Should we say something differently for each user in the group separately? How to explain the compromise? Several key questions that are quite open to the moment. So, ultimately, responsible group recommenders targets at leading to better group outcomes. The idea is to help users feel that their preferences are included in the result, and this is actually the part of the talk. But let me start first of all with very few things about the recommender systems. What we are doing here, the task is to suggest, retrieve interesting data items based on the user profiles and history. And what does this mean? Of course, depending on the application and the recommender, we may have either explicit user ratings that define the user preferences, or some implicit piece of information, maybe based on views, clicks, and so on. And the very general picture is to estimate, predict a score, a preference score, an interest score, or even a relevance score for a user and an item that reflects the preference of the user for this item. Moving to the fairness aspect in recommenders, in abstract terms, we can say that the recommendation is fair if the values of the protected attribute of the users or even the items do not affect the outcome of the recommendations. A new problem now has to do with fairness in rank aggregation. So what we assume here, that we have a set of ranked outputs, and we need to find a way to aggregate them in order to construct a new ranked consensus output. If you think it a bit, this is exactly the same with what we need as a solution in the group recommendation settings. We have a set of users. For each user the recommender can produce individual results, and at the end of the day, we need to somehow merge, aggregate those results into a single output. So the idea is how to mitigate biases introduced during this aggregation phase. Some traditional examples include travel with friends, or even music to be played in a car with passengers. And the idea is to apply a recommendation method for each user in the group, and then aggregate, produce the results for each user, and then aggregate the results. Several existing solutions appear out there. The most common one can imagine is by taking a sort of average function, but typically we are not sure how enough is this for ensuring fairness in group recommendations. So, as I said already, it is quite common to consider the average function for producing group recommendations, but we need always to remember that the goal is to maximize the group's overall satisfaction with the recommendation list. So we need a better solution other than the average method. And intuitively, what we need to have, we would like to have fairness outputs by minimizing the feeling of dissatisfaction within the group members. So one of the first approaches towards that direction focuses on the problem of assuming a measure of quantifying the satisfaction of a user given a list of recommendations. More or less, what does this mean? How relevant the key recommended items are to the user. Then they need the so-called social welfare, or in simple words, group utility, that based on which we can average the user's utilities. And then for achieving fairness, we would like to somehow balance the utilities of the users in the group. In very simple words, this means that we need to have a list that minimizes the dissatisfaction of any user in the group, and this can be considered as the most fair output. So several ways for computing individual utilities. For example, we can just take the average of the relevance scores of the top K items. In turn, we need to compute the social welfare, that is the utility of the group. Again, a simplistic solution is to take the average of the utilities, while moving to the most interesting part, for counting fairness, we can compare actually the utilities of the users in the group by using examples like the ones in this slide that exploit ideas from the minimum varium functions and so on. So for example, for the variance solution, here we encourage the group members to achieve close utilities between each other, while, for example, for the least misery solution, where we use the minimum function, we emphasize the gap between the least and the highest utilities of the group. The consensus intuition of this group of metrics is to minimize the difference between the individual utilities of the group members. And for locating the best recommendations to show, more or less we need to combine those two things by a simple weighted summation solution, combine the social welfare and the fairness part of the problem. And a greedy way for doing so is to select an item that achieves the highest fairness when it is added to the current solution. In a different method, the traditional ideas from skylines are used. So here we represent data items in space, where each dimension corresponds to a group member, and its coordinate equals to the relevance of the item for the user. So here, as in traditional skylines, we need to define a dominance relation, and as typical do so, an item dominates another item for a group if, for each user, the first item is at least as good as the other, and there exists at least one extra one user for whom the first item ranks better. So the top items not dominated by any other item are called Pareto optimal. We can define, in addition, if we like to have the top K solution, the n-level Pareto optimal items that dominated by at most n-1 other items. Typically, this is quite expensive, so to identify the output, we perform some sort of heuristics approximations, and one way for doing so is to request the top n prime recommendations for a user, assuming that n prime is something bigger than n. Take their union and select the n-level Pareto optimal items from the n prime ones. Next step is to check how to construct also packages for the group. In this line of work, fairness is defined by using the concepts of M proportionality and M envy freeness, which is to some extent quite similar to each other. So for a user and a package, the package we say that is M proportional to the user if there exist at least M items in the package that the user likes. For a group in total, in turn, we say that the M proportionality of the package for the group is defined as the number of users in the group for which the package is M proportional over the group size. Much more complicated in phrases, but if you can see the formula, it's a very simple thing to note. Somewhere similar, we can define also the package to group recommendations. No need to stay here. And to put the things together for maximizing fairness, what we do, we can construct the package in rounds in a greedy way, so we can add to the package the items that satisfy the largest number of non-satisfied users. And in that solution, additional type of constraints can be considered, like for example the category constraint, very useful especially when we care also about the diversity in our outputs. So in that case, when selecting an item from a specific category, we remove the items of this category from the candidate set, and so on. Something similar we can imagine for the distance constraint as well. Next, we can consider the scenario, again, staying on group recommendations, where we have several interactions between the user and the group and the system. So more or less, this is quite commonly known as sequential recommendations. Let's assume here a very simple case. We have a group of 5 friends interacting 5 times with the recommender. And for example, here on the left and the right, we see two ways for computing the aggregation outputs when using the average function and when using the least misery solution, which takes into account the minimum function. In the figure, we count, let's say, the satisfaction of each user from the results, each user in the group. As you can see, some of the users, for example, the yellow bar, user number blah blah 4, it is not very well satisfied, and this not well satisfaction is continued for all the rounds of recommendations, for all the interactions between the system and the user. So what does this mean? The system is unfair to this user, and this unfairness continues for all the 5 iterations. So targeting at making this user happier, let's say, we consider in this solution both satisfaction and disagreements in the group. According to this solution for counting satisfaction, we directly compare the user's satisfaction from the group recommendations and compute the average group satisfaction. And for the disagreements, we count the differences in the satisfaction scores between the most satisfied and the least satisfied user in the group. Again, we have a sort of weighted summation as a solution here, where we combine the scores produced from 2 traditional solutions, the average method and the least misery method, with a dynamic parameter alpha on how to make the weighted summation, which targets to do what? For an extremely, let's say, unsatisfied user in one iteration, these parameters take some sort of high values in order to promote these user preferences in the next round, and so on, so forth. So that's the idea, and here we can see, let's say, the output when using that solution. When applying this method, this yellow user, the yellow bar, the user number 4, who had a very low score of satisfaction in the first iteration, has better score in the next one. And as you imagine, there are many ways for doing the aggregations. Okay, I'm seeing that I'm also out of time. There are many ways for doing the aggregations in the recommender systems for producing group recommendations. So here there is the idea of the squirrel model, which uses reinforcement learning. Taking into account a reward function, the idea is to select for each round the best aggregation method among the available ones, so as to have good satisfaction and small disagreement scores for the users. For reward functions, we can assume a sort of satisfaction, or when combining satisfaction with disagreements, or even works that involve some diversity aspect when producing the results, and so on and so forth. And just with a title, some open topics here when studying fairness for group recommendations. The very well-known multi-sided fairness problem, focusing on having at the same time fair results for both consumer, producers, items, and so on. The next one refers to fairness aspects when you consider limited availability. So this is the case when we cannot imagine that we have a huge number of available items, so we can distribute them in a fair way to all the users, but a very specific amount of available items, so we need to pay special attention on how to distribute them, or how to combine also diversity aspects when considering sequential group recommendations. I'm not trying to convince you about explanations. We heard more before. Probably I do not have actually much time to say many things here. Maybe just in a sentence to explain what can be a counterfactual explanation when considering the group recommendation scenario. So for example here, as usual, we assume a similar group of 3 users. And first of all, we produce the recommendations for these 3 users in the group. Then, those 3 individual suggestions is an input to the group recommender, and according to them, we have the final output, the results for the group, right? So, what's the idea here? With red, we have the target item, the item of interest, more or less. What's the case? What's the explanation? We ask why I10 in the result, and the counterfactual explanation should be something like the following. If you had not interacted with item 2, then item 10 would not have been recommended. So more or less the idea is to double check the user preferences so as to see what the user like, reconsider this when reproducing the recommendations so as to be able to provide the group counterfactual explanation for the group. This is a very big question. Many items can be combined. Imagine first of all that the set of counterfactual cannot be only a single item like in this simple example, but can be many. So we need to take care about the size of the explanation, how many, imagine how many items we need to combine so as to provide the explanation, and so on and so forth. So this is a really big topic. What we are doing very abstractly in our case, try to somehow find a way to prune the space that we need to check so as to provide the counterfactual explanations. And for doing so, we define, we express some sort of utilities related to the data items so as to be able to sort the items and try to checking what to remove in a particular order. Stopping here. Thanks a lot.
Thank you. Thank you, Kostas. So again, pressed by time, maybe one question. Otherwise, you can ask him at the break.
Perfect.
Even better. Thank you, Costa.
Thank you.
So we proceed to the next speaker. This time from Germany, we have Irini Ducci. So she's a professor at the University of Bundeswehr in Munich, in Germany. and she's a professor for open source intelligence at the Department of Computer Sciences. So we are very happy to hear Irine's presentation. So this works?
Yes.
In case you...
I'm not sure. Okay.
I'll let you plug it in if you want to do that.
I think I'll use my laptop, right? I should not move around too much, right?
Right.
Okay, so... Nothing happened. Okay, I thought it's plug and play.
It should...
It should be plug and play. I tried it
Right.
before, right?
Give it a sec. So we see the other screen.
Yes.
So
So this is the right
Yep.
computer. Okay, okay. So, hello everyone. It's a great pleasure to be here. Thank you, Dimitris. Thank you, everyone, for the invitation. And yes, so in my talk, I want to focus on fairness or discrimination. I use the terms interchangeably. And I want to focus on the multidimensional discrimination case, so discrimination in the presence of more than one protected attributes. And I think we are already convinced that discrimination and fairness is a very important problem in AI systems, because these systems are used also in high-stake applications, like, for instance, in education, healthcare, and so on and so forth. And we have already a lot of incidents which show that these systems can reproduce or amplify existing inequalities or even create new ones. So this is a very important problem, because they can cause real harm, either allocative or representational harm. We have many examples. So fairness is a very important principle, one of the core principles of responsible AI, and already embedded in many global frameworks, including the AI Act. And when we talk about fairness in the context of AI systems, so algorithmic fairness, typically we refer to systems which ensure good performance or comparable performance across the different subgroups, which are defined on the basis of different protected attributes, for instance, gender, race, age, religion, sexual orientation, and so on and so forth. And depending on how we define this model performance, right? So again, we are looking for equal model performance across different subgroups, across different groups. Depending on how we define this model performance, we have different operational definition of fairness. For instance, if we focus on the positive prediction rate, then we talk about statistical parity. If we focus on true positive rates, then we talk about equal opportunity. If we focus on true positive and false positive rates, we talk about equalized odds and so on and so forth. So there are many different notions of fairness, and there is an agreement. Should come a bit closer. Okay. Here? Okay. So there are many different definitions of fairness in the AI domain, and there is an understanding that there is no single definition of fairness. So you have to kind of tolerate all these definitions, because depending on the context, they make sense. And there is a dedicated domain, the so-called fairness-aware machine learning domain, which studies all these problems of bias and discrimination. So how can we define fairness? How can we mitigate unfairness? How can we account for unfairness and discrimination using, for instance, explainability, and so on and so forth. And all of these works, or the majority of these works, to be more precise, actually focus on the single-dimensional discrimination case, what I call here monodiscrimination, so discrimination in the presence of a single protected attribute. But as we know, human identities are multidimensional, so we have many different identity dimensions, for instance, gender, race, occupation, age, religion, sexual orientation, and so on and so forth. And many of these dimensions are actually protected. So this means that individuals belong simultaneously to many different identity groups, and discrimination can be the result of more than one identity, right? So it can be the combined effect of many different identity dimensions. This is not a new concept, so it was mentioned, first mentioned, for instance, intersectionality in 1989, referring to the marginalization of Black women in law and policy, or multidimensionality in 1997, referring to this complex interplay between different identity dimensions and how this impacts the distribution of power. So these are not new concepts, but they are pretty new in the context of fairness-aware machine learning. So in the context of fairness-aware machine learning, multi-discrimination is an umbrella term. So this is discrimination in the presence of more than one protected attributes, for instance, age, race, gender, and so on and so forth. And there are different flavors of multi-discrimination. There are 3 different instances: cumulative or additive discrimination, intersectional discrimination, and sequential discrimination. In all of these cases, more than one protected attributes are involved because we are in the multidimensional discrimination case. So in cumulative discrimination, the main idea is that we have different grounds of discrimination, for instance, gender and race, but we can observe the impact of this discrimination with respect to each and every dimension. So we can conceptually separate these impacts, and these impacts or these disadvantages add up when we observe them together. On the contrary, in intersectional discrimination, again, we have many different grounds of discrimination, but they cannot be separated. So we can observe them only when we look at the intersection of all these different dimensions. And in sequential discrimination, the idea is that we have several incidents of discrimination in a sequence of events, and these incidents might be on the same ground of discrimination, so only gender, or on different grounds of discrimination over the different sequences. And here I have a small example to clarify these notions. So what you see here on the left is the impact of height requirement, which might be important, for instance, in a security sector job, based on 2 dimensions, nationality and sex. So both are considered binary here for simplification. And we see that with respect to nationality, there are differences between German and Japanese people. German are typically higher than Japanese people. We see also that with respect to sex, there are differences between males and females. Males are typically higher than females. And these individual, let's say, disadvantages based on single dimensions, they add up when we observe the Japanese female, right? So the combination of these disadvantages is observed also and adds up for the Japanese female group. A similar example for intersectional discrimination. So here the example is how the headscarf ban at the workplace, so this was a case in Germany, how this impacts different population subgroups. And here again, we use 2 identity dimensions, gender and religion. Again, for simplification, both of them are binary. And we see how these measures, so banning the headscarves, affects the different population segments. We see that there is no impact with respect to each dimension in isolation, so religion or gender in isolation are not affected by this ban, but what is affected is actually the Muslim women, right? So here we have this joint combination, so the intersectional effect. And for the sequential case, so here is an example from hiring. Typically, hiring process is a multi-step process. So in the first step, for instance, the different CVs are reviewed by some text analysis software. There is an assessment center where different psychometric tests are taken, and there is the final interview phase. And discrimination can occur in each and every step. For instance, in the first step, maybe there is a gender bias, as we know, for instance, from word embedding. In the second step, maybe there is some bias with respect to disabled people, and in the third step, maybe there is some bias with respect to age, right? So we see different grounds of discrimination, gender, disabled people, and age observed over a sequence of incidents, right? So multi-discrimination seems to be the reality, right? Because, as I said, humans are multidimensional. So the question now is, how can we mitigate multi-discrimination? And of course, because there is a rich literature in the mono-discrimination domain, so as I said before, the domain of fairness-aware machine learning is dominated by methods for bias detection, mitigation, accountability for single protected attributes. So the question is whether we can really exploit these methods and leverage them also for multi-discrimination. So the straightforward extension here would be really to optimize, so using these mono-discrimination methods from the fairness-aware learning domain to optimize for each and every dimension in isolation. This is a nice idea, right? So it would be nice if this works, but unfortunately, it's not sufficient. And there are 2 at least two problems which make this straightforward extension not sufficient. The first one is what I call here conflicting fairness objectives. So there are a lot of studies which show that if you optimize for a single identity attribute, let's say gender, then you might harm other identity attributes, for instance, race or age, right? So you have these conflicting, let's say, fairness objectives. And the second one is what is called fairness gerrymandering. So you might try to be fair with respect to each and every dimension in isolation, but this does not ensure that you are fair in the intersection of these dimensions, right? So maybe you are fair with respect to race, with respect to gender, but you are not fair for the subgroups created by the intersection. So what it needs to be done is actually to balance these different, conflicting sometimes fairness objectives due to the many dimensions, and of course also to focus on the intersectional subgroups in order to avoid this gerrymandering effect. This is also not very easy, so there are a lot of challenges. So let me go through these different challenges, or some of these challenges. So the first challenge is a statistical challenge, right? So we have what we call a data scarcity problem. So as the number of identity dimensions increases, we have more and more subgroups that are created, and some of these subgroups become very small, or even they disappear, right? So you don't have any instances from these subgroups. And what you see here on the right is an example from the adult data set. Jurek mentioned that already. So here we see three subgroups, three protected attributes, gender, race, and age. All of them simplified as binary attributes to keep it simple. So we have 8 subgroups. And you can see that we have different aspects of data scarcity. We have actually 2 aspects of data scarcity. We have population imbalance. Some groups are very small in comparison to others. For instance, this black young female group is 1% of the population, whereas the white old male group, as an example, is 50% of the population. And also, because this is a supervised learning, a classification data set, we have extreme imbalance for the minority subgroups. So the imbalance ratio, positive versus negative class, for this tiny subgroup is 1 to 61 versus 1 to 2 and 1 to 3 for the overall population, right? So we have extreme population imbalances for some of the subgroups, and we have also extreme imbalances with respect to the class. And this scarcity is very problematic for machine learning because it makes these subgroups invisible to the machine learning models. So different aspects of invisibility. So for instance, we cannot really assess reliable the fairness measures. We cannot train the model, so the training is unstable, and also whatever interventions we make, they are not very reliable because they rely on very small samples, right? So data scarcity is a very important problem. This is one example of a data set, but it's a problem for many different data sets. You can go through the references if you are interested. Another problem is how we define these intersectional subgroups. How deep should we go? How many identity dimensions can we combine? So who should be protected also, right? And this raises a lot of challenges. I mean, as a computer scientist, I focus more on the computational and statistical challenges. So we have a lot of subgroups as we add more and more identity dimensions. And as I said before, we have also this extreme scarcity, either population imbalance or class imbalance. And the typical approach in this case is what I call here oversimplification. So to reduce the computational complexity, what is typically done is that we consider these identity dimensions as binary. So for instance, male, female, white, non-white, and so on and so forth. This, of course, reduces the number of subgroups, right? So we have less values for each dimension. And another oversimplification idea is to merge these small categories into larger ones, right? This helps not only with the computational aspects, but it helps also with the data scarcity, right? So all the small subgroups are merged into a bigger one. For instance, Black, Asian, Latino, Arab, etc. Communities are all mapped into the non-white community. So this is the typical process, and this is, of course, very problematic because this oversimplification means that we erase really human experiences from the data set, right? So when we model gender as binary, then non-binary people are not represented, and when we map all the Black, Asian, Latino, Arab, etc. into the non-white group, then the diversity within this group is lost, right? So we kind of, again, erase experiences. cases. So this is a challenge, how we define these subgroups. Another challenge is how we measure fairness, right? So there are different definitions of fairness for the mono-discrimination case. I mentioned statistical parity, equal opportunity, equalized odds, and so on and so forth. And typically, they rely on comparing one value to another. So as I said, these attributes are typically considered binary, so comparing male performance to female performance, white to non-white performance, and so on and so forth. So when we have now many protected attributes, so multidimensional cases, then we have many more subgroups to compare, right? And of course, as I mentioned before, we have this computational aspect, so a computational challenge and data scarcity challenge. But perhaps the most important challenge here is really that there is no clear baseline. So to whom should we compare when we evaluate fairness, right? There is no obvious reference group. So even in our example before, if I want to check how the model performs for the young black women, for instance, should I compare to the old white men? Should I compare to all other subgroups? Should I compare to the whole population? So many different options and many different ideas or measures proposed in the literature. For instance, there are measures which compare against a global population, or there are measures which which focus on the most vulnerable subgroup in the population. And there is a lot of criticism for each and every approach, right? So there is no solution, let's say, that somehow satisfies all the requirements. But this is also a very important problem, right? So how we measure fairness, and in particular, how we define this reference group for the comparison. And even if we consider the global population, and we have these imbalances in the population, for instance, it's clear that the global population is affected by the imbalances, right? So who contributes to the global population? So a lot of, let's say, different and complex decisions to be made. So let me summarize these many different complexities. So I hope I kind of convinced you that this is a complex problem, and there are many aspects of this complexity. So one aspect is that what I called before conflicting fairness objectives. So if you optimize for one objective, let's say gender, you might harm another objective, let's say race, right? So you cannot optimize in isolation. We need to focus on the subgroups because we have this gerrymandering, fairness gerrymandering problem. Subgroups come with their own challenges and needs, for instance, imbalance, which I explained before in terms of cardinality, but maybe this is not the right notion, right? There are other notions of, let's say, understanding how sufficiently a subgroup is represented in the data. And of course, we know this already from the mono-discrimination case, the impossibility of fairness, that there are many different fairness definitions and they are not compatible with each other, right? So you cannot optimize all of them simultaneously, only for some very trivial cases, okay? So this is known. And also, I mean, even looking at the AI Act, fairness is one requirement, but it's not the only requirement, right? So you want systems that are fair, they have good performance in the traditional way, so predictive performance, for instance, they are robust to adversarial manipulations, they are privacy aware, right? So you have many different desiderata, and again, for all these objectives, there are conflicts, right? So you cannot, for instance, optimize easily fairness and privacy. Sometimes these objectives are competing with each other. And because of this, I think, or we think, that multi-objective optimization could be a good solution, and I'm very happy because multi-objective optimization was mentioned by both Jerzy, right? So when he described the Pareto front of the counterfactual explanations, and by Kostas when he described the many ways of aggregating the solutions, right? So we believe that this multi-objective optimization might be a good solution to this problem, which involves many different objectives, many competing objectives, right? So you cannot easily squeeze or collapse them into a single objective because they are not compatible with each other. And as we know from multi-objective optimization, the result of this optimization is not a single solution, it's a set of solutions, so the so-called Pareto front, which are all solutions with the best achievable trade-offs, so you cannot improve any further. further without hurting some of the dimensions. And of course, there is a lot of discussion now, what can we do with all these solutions? I mean, at the end of the day, you want to deploy just one model, right? So how you choose from this Pareto front. And there are different ideas also in this direction. So I want to show you a small example with just 3 objectives. These are also a bit of aggregated objectives. So in this case, the focus is on multi-fairness, so many protected attributes, class imbalance, and we have 3 objectives. So the first one is about overall accuracy, so the default, let's say, way of evaluating predictive performance. The second one is on the balanced performance. Because of the imbalance, we want to have good performance across the different classes. And the third one is on multi-fairness, so we have a way to combine, let's say, these different fairness objectives. And what you see here is the Pareto front, so the solutions actually for 3 data sets, so adult on the left, bank and credit was mentioned also before. And you see here the solution space. I hope you can see. It's a bit tiny. And you can see also the Pareto front. So there are a lot of solutions which offer this best trade-off. So these are the dots, for instance, here. And of course, depending now on the application, and if you have some extra knowledge about preferences over these objectives, so if you have a user preference vector, then you can select based on these user preferences, which of these solutions you can choose among these equally good solutions. And we have developed actually a library, so it's a developing process, right? So we are improving it, which covers all these different multi-aspects of fairness, from multi-attributes, so many protected attributes, to multi-objective, many objectives, to multi-definitions, so many different fairness definitions. And you can play around with it, and we would be happy to receive some feedback if you like. And this is part of a project focusing on multi-discrimination, so the Mammoth project. So I hope I'm okay in terms of time. Typically, I'm very late, so I tried my best today. So let me wrap up. I mean, there was not much time, so I think what I tried to show in my presentation is this a complex space, right? So we are navigating a very complex space with many different identities, protected attributes, with many different fairness definitions, with many different objectives. This space is very complex, not only because of these many objectives, but also because these objectives are not compatible, right? So sometimes they conflict with each other. Actually, we don't always have a good understanding when there are conflicts and how to resolve also these conflicts. But what is important when designing such systems that are take into account this fairness is, of course, to make informed decisions. For instance, what to protect, right? So what are the protected attributes? How deep should we go with these multidimensional groups? What to optimize, so what we are optimizing for, how to intervene. We have a lot of ways to mitigate bias, pre-processing, in-processing, post-processing, and many of these approaches are actually heuristic approaches, so again, they come with problems. And we have the statistical reality or the reality of the data challenges, right? So I mentioned one aspect of this reality, the data scarcity, but there are also other issues, for instance, overlapping classes. Jurek had a lot of work on overlapping classes for class imbalance learning, and so on and so forth, right? So it's really important to understand this complex space, and I think because the space is so complex and you cannot really easily find a solution that rules them all, it's better to have a set of solutions, or so to understand the solution space and select a solution from this space. So yes, I would also like to thank our sponsors, let's say, right? So the different projects. So we had several projects. We have several projects on bias and discrimination from the European Union, funded by the European Union, the Volkswagen Foundation, the Niedersachsen. So I was two affiliations before. I was affiliated with the Leibniz University of Hanover. And also other projects. So Stellar is a project which does not focus on fairness and discrimination, but actually bias, I think it's not only related to fairness and discrimination. Nowadays we use the term bias as a synonym to discrimination, but I mean we know from AI and machine learning that bias is a very important aspect that enables induction, right? So we need some sort of biases. So the question is actually what biases we need, and actually how to use these biases in order to steer the model in the right direction. For instance, inductive biases and so on and so forth. And perhaps a short advertisement, so I didn't cover it in this talk, but we have, I think, an interesting paper for Fact 25, which is about fairness, of course, right, for single discrimination, so mono-discrimination fairness. And the main idea here is that if you make more informed decisions for the interventions, and here the informed decisions for the interventions are related to socioeconomic information. So if you have some information about the socioeconomical status, and if you also include the effort of the individual, then you can make more informed interventions instead of, let's say, just favoring let's say, women as a whole, right? So I use women just as an example. So yes, so thank you, and I'm looking forward to questions or discussion in the break. Thank you.
Thank you, Irini. So, again, sorry, maybe one question, if there is one. Otherwise, let's continue. Yeah.
Yeah, thanks for the beautiful talk. Yeah, so thanks for the beautiful talk. So you did mention something about data scarcity,
Yes.
Which is a problem. But so if we use resampling techniques, for instance, and also in the face of generative AI, can we somehow address this problem?
Yes. Should I repeat the question or? No? Okay. So that's a good question, right? And it refers really to the mitigation. How can we mitigate bias? And in this particular case, how can we mitigate bias in the presence of this data scarcity? And what you said is different augmentation techniques, right? So from resampling, for instance, from the oversampling the majority, the minority, or undersampling the minority, or weighted sampling, or generative AI, so creating more data out of the data. These are good ideas, and they have been tested, so applied in the literature. So there are a lot of works. We also have some work on how can we augment, let's say, these invisible or small groups. I think the main problem with these solutions, or there are some problems with these solutions. One of the problems is that if you apply generative AI, for instance, right? So the idea of generative AI is that you learn from data. If your data is scarce, right, so there is no representation, let's say, of non-binary people, then with the generative approach, you will not learn too much about, you will not learn to generate non-binary people, right, because it was not part of the data. I'm not saying should not be tried, I'm just saying that there are limitations and we should know these limitations. But I would definitely try all these different approaches because there is no clear understanding about which approach works under which conditions. And this is kind of another problem in the domain, that we have a lot of methods and we don't have a good understanding about the performance space, right? So, and especially which methods to use under which data challenges. So even this imbalance of the data in the initial fairness-aware learning works was not considered. So people were optimizing for fairness, let's say statistical parity and accuracy. But we know that if you have imbalance in the data, then accuracy is not a good indicator, right? So you should optimize, let's say, for balanced accuracy, right? So I would say yes, we should try everything and see what works. And as a community, I think to have a better, or to gain a better understanding of this complexity and the solution space and the tools that we have. Yes.
There's a follow-up question.
Follow-up question, yes.
A couple of years ago, I dabbled with regression problems, like you showed in your presentation. So is it more of a feature engineering problem? Because yeah. So sometimes I have the feeling that when you do a proper feature engineering, which most of the time a lot of people don't,
yes,
in my experience, can it in some way address this data? Yes. This bias or fairness in our model?
Yes.
And
so,
continuing on that, how does this whole thing extend to the domain of LLMs and natural languages and computer vision?
Yes. So I think what you said is very important. I think nowadays the tendency is that we do these end-to-end approaches, right? Data in, models out, and we don't really want to understand, or we don't have the patience, I don't know. I think somehow this understanding of the data and of the problem is not very important nowadays. But I think it's very important because, I mean, you build models for a particular problem. So understanding the model, the problem, and the data is very important. And feature engineering, or a combined way, I mean, we have nowadays also very powerful feature learning methods, right? Maybe a combined approach, or using explainability on the learned features to understand what exactly has been learned, if there are any, let's say, biases, hide it in the features that you have learned. This is a good idea. And to the other aspect that you said about the LLMs, I think what you mentioned is really, I mean, what I said is mainly focusing on tabular data, right? And we had the same, Jurek mentioned the same before, right? So most of the work on fairness is on tabular data. There are, of course, works with other modalities. We also have some works with multimodal data, for instance, and then the problem becomes much more complex. So for text, also a lot of work on text, and multimodal data, because you have the modalities might affect the models in different ways. So there is maybe a dominating modality. So you should be able to understand that one of the modalities, let's say text, dominates a decision. Is this something that you are okay with? Yes, no, right? But this is important. And most of the fairness aware learning approach is focused on supervised learning tasks, not generative, so predictive tasks, not generative tasks. And one of the reasons, I think, is because we have all these fairness definitions for so it's easier, I would say, right? Because you have an easy way or some way to measure the fairness and discrimination, whereas for the generative task, it's a bit harder. I mean, how you compare, there are ways. So I think the modality is also very important, and to the task. We saw also an example with Kostas, right? So Kostas focused on recommenders, right? So dealing with fairness and recommenders is a bit different than dealing with fairness, let's say, in classification, or different in regression. So I didn't cover regression. So the task is also important. So everything is important.
Great. So we don't have any more time. So
Thanks.
Thank you, Irina, again. And I would like to invite Willem Zoutdema from the University of Amsterdam to come to the floor. He's an associate professor of natural language processing, explainable AI, and cognitive modeling at the Institute of Logic, Language, and Computation. So thank you. You have the floor. I forgot to mention he's also a senior BrIAS fellow here this year.
Yes, great. So thanks very much for the invitation and the introduction. I'll be quick. I'm indeed professor of natural language processing, and the field that has been completely revolutionized, unrecognizable, I would say, by the emergence of large language models. And so for the last 10 years, I've been also very much focusing on trying to understand what is happening on the inside of those language models. And that's become incredibly societally relevant, as we all know, in the last couple of years. So just to give you one example, a few weeks ago, I checked my LinkedIn page and I saw this little announcement from Brian Potts, a person I don't know personally. But he announced like the release of their new product. So this is an American startup. They built an AI judge. It oversees our new private court system, and it goes live today. We call it arbitrus. For litigants, you no longer need to wait for years to get your dispute resolved. Sure, you could go to a state or federal court, spend a lot of money, or wait 1 or 5 years to get results, or you can sign up to our system. Now, if you know how this sort of these large language models that power their system works, there's so many questions that immediately pop up, like, how are you going to do this responsibly, right? How are you even going to ensure that the output of your system is going to be legally correct, right? How are you going to ensure that there's not all kinds of sort of hidden biases in that large language model that is powering your thing, that might sort of like reach different decisions for women, for men, or for people of color than for white people, or for Americans than for non-Americans? How are you going to sort of then actually provide a justification to which is sort of the essence of a court procedure to sort of the users of these systems? How are you going to ensure that the justifications that if you provide them are actually faithful to the underlying processes of the LLM that was used, right? That actually is a very, very difficult problem. How are you going to, if you discover that this thing is not doing exactly what it should be, that it is making errors, how are you going to fix them? Where are your points of interacting with your system? And how are you going to provide sort of the users that signed up to your system and sort of actually let legal disputes be resolved by your system? How are you going to give them access to recourse, right? How can they actually complain about it? Now, all of these issues, I would argue, require explainability. We need to know what is happening on the inside of that big black box system that is powering these things. And that is a problem because we don't have the tools available to provide that faithful explanations for what's happening. Of course we have, and this morning we already had a lot of examples of sort of XAI techniques that have been developed. It's been a very active field. We have a lot of techniques available. So we have things like LIME and integrated gradients and SHAP and grad SHAP and deep SHAP and deep lift. And there's an enormous variety of sort of attribution techniques, explainability techniques that have been proposed, and often were very beautiful theoretical motivations that explain how important parts of the input were for arriving at a particular output. But the problem is we have all these methods, but there are serious doubts about how reliable they are, how faithful, how valid they are. So some of the doubts already appeared sort of like a couple of years ago. So here's an interesting application where we actually see these XAI techniques applied to image classification, and we see an image of a little finch. So these examples due to Lacarayu. And this finch is being classified correctly by the model, and now we want to know, like, where did it base its decisions on, right? There have been examples where the classification was based on the name of the photographer that was in the image, right? That was not a very good classifier, but we want to know, like, what is it based on? And so we can actually use, I think it's integrated gradients that was used for this example. We can actually sort of see which pixels were crucial for that decision. And that makes a lot of sense, right? So it's actually, we see that it is really looking at the finch to reach its classification. So finally some good news. Except for you can repeat this on an untrained network, apply the exact same XAI technique, right? And basically obtain the exact same image, right? Which shows then this untrained network is not able to classify finches from elephants or something like that. Right? So this shows that sort of the baseline criteria are often not met for many of the like from a couple of XAI techniques from a couple of years ago applied to the AI models from a couple of years ago. But it has gotten much worse. So here are some quantitative data from a colleague of mine in Amsterdam on transformer language models, where they've actually tried out a whole bunch of different XAI techniques that are popular in the literature to explain the decisions, the predictions of an LLM. So here we see Lime, integrated gradients, deep lift, grad shap, deep shap. And then here on the columns, you see the correlations between the explanations that these methods generate, right? And what we see here is that the only place where you see actual high correlations is on the diagonal, which is at least the methods agree with themselves, but they massively disagree with each other, right? So we have different explanation techniques that don't agree on what is important in the sentence to reach a particular prediction. And note that this has become much worse with the rise of transformer-based language models, because the graph looks like this for the LSTM, the previous language model technology from, say, that got supplanted in 2017, 2018 by these transformers. Now, there are some advances in very low-level explanations. So some of you might know about the enormous popularity now of mechanistic interpretability to sort of arrive at. But generally, they give us extremely low-level explanations, right? And they have the problem that they are not very useful for end users, right? They are not comprehensible in that sense, right? So, and this leads us to what I've called for this talk the explanation conundrum, right? So, if you take one thing from this talk as a bridge to sort of what we will discuss maybe in the afternoon, AI systems are used more and more in high-stakes applications, and explanations for how they arrive at their output are ever more important. It's really, really important. However, the techniques that we have available radically disagree on what explanations they generate, right? And so we don't know which of the many explanations on the explainers on the market we should actually use. We have to know which one is correct. And then we run into another problem, which we call the faithfulness problem, which is that we don't even really know how to measure the correctness of explanations in cases that matter, right? Okay, so that's a lot of bad news. I apologize for this, all these problems existed before, but they've only become bigger with the emergence of sort of generative AI techniques. Explaining the decisions of generative AI models is really very, very, very difficult, and we are not there yet, and which casts doubts on a lot of sort of real-world applications of these techniques, where actual real people's real lives are being affected. Right. Okay, so I already I got to sort of the most important thing. I wanted to sort of like get this message across. There's a conundrum. We need explanations, but calling something an explanation does not mean it actually is an explanation. So explanations that we need to be faithful and comprehensible for them to do their work. And generating faithful and comprehensible explanations is often very, very hard and sometimes maybe even impossible. Right. Okay. Now, I don't want to leave you with only bad news, because this is actually an extremely active field. Like we are, as XAI researchers, working really, really, really hard to sort of like find a way out of this conundrum. And there is actually progress made. So if any of you here actually has lots of funding available, that would be very welcome, because there's lots of research is needed in here, and we actually are making progress. And now I have a bit of a conundrum. I would love to actually talk about the technical details of the methods that we, for instance, in my group in Amsterdam, we've been developing. But in order to do this, I need you to know a little bit more about how these LLMs really work on the inside. So some of you might actually be experts on this. Some of you might actually not know all the details. So in the next part, if the chair allows me, because we are running desperately behind on schedule, I just wanted to go into sort of like look into a little bit more detail in how these LLMs actually work. And do that with the use of some of my favorite explainability tools. So that they actually, I think I have a little bit of a different story than the story that you might have heard from others on like how these methods work. So let's get to that. Let's take a brief tour then of how LLMs work on the inside. And the example I've used, I've made a YouTube video that's become quite popular with this example, so I'll reuse that example here. It's when I actually type in, and I've done this for you myself. You type in the questions to an LLM, a well-trained LLM. What is Charles Darwin's most famous book? Right, and then you would hope that this is such a famous name that the method will actually come up with an answer. So what happens when you actually do this? Well, the first thing that happens is that the sentence is actually being chopped up into sort of parts that we call tokens, right? So what is Charles Darwin's? So that this would be the actual tokens that the LLMI use. So you see that Darwin's, for instance, it's chopped up into two tokens. Sometimes you actually see that the tokens are breaking up words as well. Okay, then the next step is that each word is actually mapped to a series of numbers that we call embeddings. And in the typical LLM, there's hundreds. For some reason, 768 is a number that is used a lot for these embeddings. And I'm going to use this sort of little symbols for that row of numbers. And with these embeddings, then, that actually enter into the transformer architecture, the actual calculations are happening. Okay, now, so one thing to imagine how an LLM works is that for every of these tokens, like a whole stack of processing units is created, and that can be run in parallel very efficiently on GPUs, the graphical processing units. So. So here we have our sentence, we have our input embeddings, and then for every token, sort of like a whole stack of processing units is being created. And so this gives you a first glimpse of why explaining what they do is so difficult, because it's just a lot, right? So in the typical model, we have sort of GPT 3.5, the last from OpenAI, where we know the details. We have 96 different layers and 96 different heads per layer. So we already have in the order of 10,000 processing units per word, right? And then every word, every processing unit has actually millions of numbers that regulate how it operates, that we call parameters. And that's how we arrive at billions, hundreds of billions of parameters for these models. So, so processing in each of these units happens in parallel. There's many nonlinearities that make the explanations difficult. We can inspect all the numbers, but that doesn't mean that we actually understand what is happening. And we only know how to optimize this using sort of the backpropagation algorithm. But what we can do, and this is something that is more recent progress in explainability, is we can actually look at every processing unit and look what at that stage in processing the favorite prediction for the next word would be, right? So it's predicting probability distribution. So we only show you one prediction, the most probable prediction from there. And that gives us a graph like this, which is actually extremely interesting to process. So we see here what is Charles Darwin's most famous book at the bottom, and then for every word we see this stack of layers, and at every layer we can look at like what is at that stage the preferred prediction. And we see at what we see that the first prediction is, right? So we see that almost immediately the LLMs guess after seeing the word what, that the next word will be is, and as we move further from the bottom up to the top, this projection is not changing much, right? So we see what is, what are, what is, what are, what is, what are, what, so that, and so at every of these layers we are making already predictions. And okay, if we look at another column, let's look at the column that received Charles. So when we see Charles, we see at all of these different layers of that big stack, we see that it's predicting initially a comma, then something word for some reason, and then only at the very end, we see Charles Mansion, I think the Mans is there, and we see Charles Dickens, right? Okay, so you see that the LLM has initially not much Q, but at the later layers, it actually settles on predicting Dickens, right? And that makes a lot of sense. That might be the most famous Charles in the training set. Okay. All the other columns are worth a look as well, and they're crucial, but their predictions are not really used because I have actually already typed the entire sentence, right? So it's making these predictions while processing what I put in, but it's not doing anything with it. But when the LLM is actually asked to take over to answer my question, that's a really interesting moment where to look at like what it then starts to predict, right? So after receiving the word wrote, Darwin wrote, the LLM in the first couple of computation steps predicts the typical words that may follow wrote in English. Right? So you see it predicts in, it, that, in. So short-term, so short context predictions. But in later steps in the computation, it has figured out that given the question that was asked, the appropriate answer must start with the. And we see sort of towards the end that it starts predicting the. Okay, so it actually got something wrong. It calls the book The Origin of Species rather than On the Origin of Species, but we'll forgive the LLM for that little mistake. Right. So how does the LLM at its 21st layer actually know it needs to predict the? Well, at that stage, it should have understood the query well enough so that it knows that the appropriate answer should be the name of the book that is Charles Darwin's most famous, right? So somehow it must have processed that Charles Darwin is an author, that it must somehow have stored that there are books that might be actually Charles Darwin's, right? And so how do they actually do this, right? Now, we can't tell you exactly how they do it because, as I told you, it's just too complex. There's too many units, too many nonlinearities, too many parameters. But, so we can't tell you exactly how they arrive at it, but we do know how all the basic components work. And these basic components are called attention heads and multi-layer perceptrons. And they are basically in that sort of big stack. Every processing unit has, again, sort of components in it, right? And we know that some of these components get specialized in aspects of English grammar, right? Such that the S, right, the genitive S, Charles Darwin's. So we know that somehow that processes that it somehow has to be a book written by Charles Darwin. And other components store factual information, right? And so what we know that we will arrive at is that there are 10,000s of these 10,000s of components. They're communicating with each other, and they're communicating through this mechanism that we call multi-head attention. And basically, you can think of that as that some of these components are sending out a message. I have a book on offer, right? Some are sending out the message. I need I have an author name on offer, Charles Darwin, and yet others are saying like, I need a book that matches Charles Darwin, right? And so we're starting to sort of to puzzle out how in that big network of processing units, all of that information is being exchanged. All right. I see that I'm now also at 20 minutes, so I'm wrapping up. So can we make use of, now that we understand that how these models work in outline, right? So they have all these processing units that are communicating with each other with that, sending out queries and sending out keys, what you have on offer, and sending out values, sort of when keys and keys match. Can we now actually sort of like make use of that understanding of how these transformers work to arrive at a new generation of XAI methods that are at least a bit more faithful and a bit more reliable than that previous generation of XAI methods? And the answer is yes. And so we've made one proposal in 2020, which is called attention rollout. And So it's very, very, very gratifying to see that there's now thousands of follow-ups of that work. And basically it was a very simple idea. It was basically saying, given that all of those processing units are looking at processing units in the previous layer, and they are looking at processing units in the previous layer, and they are looking at views, maybe we can track how information is flowing through that enormous network. And so we came up with some recursive equations that quantify how much each is getting from each of the other units, and that leads to an attribution method that actually works quite well. So colleagues from Israel turned this into a method for vision that is very nicely visualized, and we see that if there's an input of a dog and a cat, you see that indeed rollout finds that these are the cat and the dog are the most important versions. Then they built on our work and did something really powerful, and they actually arrive at something that can, depending on what the correct label is, it can actually tell you exactly where the dog is and where the cat is in that image, and give you really very faithful, relative to the competition, explanations for what's happening here. A completely different method, just to advertise that before I finish up, is value zeroing. That's something that we published 2 years ago, and that is based on this idea, again, of an understanding of how transformers work, and sort of like seeing like, hey, that attention network that is changing while I'm making little interventions to my model. If I just keep the attention network intact when I do my calculations, maybe I can get much more stable results out of that. So if you're interested, there's a lot of information on these methods online. So to conclude, transformers underlie much of the current successes with large language models, and they owe their success to many of the same factors that make them very difficult to interpret. Classic XAI techniques don't perform well on transformers, and that's really bad news. But recent transformer-specific interpretability techniques, starting from 2020 onwards, are starting to make sort of like giving us a way out of that conundrum, including some of our own. However, keep the warning in mind that shoehorning explanations into this very simple framework, like this word is important for that output, right, is vastly underestimating the complexities that are happening in these models, and we might actually need we might need more sophisticated approaches to explainability. Thank you.
So, any questions before the break?
Okay. So my question is, do you think that explainability is going to be something that we solve, or it's always going to be a race where models become more advanced, and then explainability has also to continue doing research to catch up? So right now they are ahead in a way, right? Models are more complex and we cannot explain them. And the moment we try to make the techniques to explain them, then they're going to become more complex, and we will never reach this actual solution.
Yeah, yeah. So I think we will never reach a complete understanding, and that's because we are limited by what our brains can handle, right? And that's a fundamental limit. And these models are not limited in that way. They can become more and more complex, and we know how to train them. We just don't know how trained models actually really work. But that said, I do think there's also a false narrative coming out of some of the big tech lobby, which is that we have to choose between explainability and performance. And so I think it's also false to give up entirely on explainability just because you want a sort of certain level of performance, because there's a lot more explainability to be achieved with highly performant models than we currently can, just because the research field is lagging behind.
Yeah.
Okay. All right, so let's go for a few more questions. So I will just have the opportunity for others to ask questions.
Hello. Is it on? Yeah. I think so. Hello. I just wanted to ask about, does cognitive modeling play a role for you, for your research, in explainability? And if so, how?
It's played a massive role because basically cognitive science and cognitive neuroscience have decades of experience of trying to explain black boxes, right? And in their black box, their favorite black box is the human brain. And so a lot of the techniques that we have developed in the XAI field are just rehashing, in a sense, what neuroscientists have already been, or cognitive scientists have already been doing for decades. And that includes, for instance, a method called probing, or we called it diagnostic classification when we first proposed it, but it was directly borrowed from the cognitive modeling field.
Got it. Okay. Thank you.
Yeah.
Okay, so for the interest of time, let's stop here and let's continue the discussion over the break. We will have a break. Let's thank Willem once again. So we will start 15 minutes late. So there is 15-20 minutes for coffee now.
Okay, welcome back, everyone. First of all, a practical announcement. If you have any cups left here, please don't forget to return them after the session, otherwise we will have a shortage of cups. So welcome to the second session. In the first session we heard all about the latest exciting research on responsible AI, while in this session the idea is to have a look like what does it now mean in practice. And maybe also how can we convince researchers not doing active research in responsible AI that it is also important for them. And in fact, this is a historical session because for the first time, at least to the best of my knowledge, we have the directors of the 3 Belgian AI programs sharing a stage here in this session. So we will have the 3 directors of the program introduce the program and describe what responsible AI means in their context. And then we will have 2 researchers from industry also talking about responsible AI in practice. So our first speaker is Tom Leenaert. As you can see, he has many affiliations. He is professor at the computer science department in ULB. He's a part-time professor at the AI lab of VUB. He is now one of the academic directors of FARI, also connected to the Center for Human Compatible AI in Berkeley, and also maybe not director anymore, but still involved in IB Squared, the Bioinformatics Institute. Tom, the floor is yours.
Thank you for this introduction. Can everybody hear me? Okay, perfect. Too fast. So it's first time I have to actually act as an academic director for FARI to give a presentation about the institute. And so I've been breaking my brains a bit about, okay, what am I going to talk about here to you? And essentially it should not be that difficult because, like I put here, FARI is an answer to a question. It's an answer to the question of responsible AI. So essentially what I want to state here is that FARI was developed actually for that reason, for actually building responsible or using in a responsible manner AI systems. So it makes it actually the raison d'etre of FARI. And of course, this has a little bit of history, which dates back to, I think, just before, during the COVID periods. Where people are actually recognizing here in Brussels and probably everywhere else that there's a lot of data-driven AI and machine learning is having an impact on our society, both in the public and the private sector, and that many stakeholders were more or less, I'm going to put it mildly, strong-armed to start to work with AI and use AI in whatever application that is relevant, but also every application that is not relevant. And they were doing this simply because they were doing this by actually stimulating the fear of missing out with most people. And so the problem, of course, if you start to play on people's fears, there might be problems, there might be bad practices, and actually you want to avoid these kind of things. And from my perspective, FARI is actually trying to resolve this problem. And to put it in a new acronym, I want people to actually go from FOMO to YOPI, which simply means the joy of participating in doing responsible AI research. Why here in Brussels? For many people here in Brussels, it's not a stupid question, or it's a logical question. It's okay, we have more than 40 years of AI, ML, and robotics research going on in both universities. But what I find much more important is that we are not only looking at it from a technical perspective. The AI and ML research here in Brussels has always been very interdisciplinary and has always tried to explore frontiers. And this is why I think it's a good thing that these people are getting involved. But then you can say, okay, why not simply do this in your labs? Why build a new entity? And I think this is very nice because, again, both the French-speaking and Flemish-speaking community here in Brussels, ULB and VUB, showed a strong willingness to cooperate on this topic. And I think this is very important. And what's also very important, and I would like to thank my colleagues from the other faculties for that, we have a strong collaborative teams from both social, economic, and legal sciences who are willing to invest in this story and actually collaborate with the technical people on this topic. And this makes it actually a very interesting organization. So what you have here is actually 3 groups of people: legal, socio-economical, ecological. Let's unite our forces and actually build an institute where we can, on the one hand, do research, on the other hand, also provide services and insights to the wider public. Now, today this session is about responsible AI, and like I said, this is one of the main reasons why we have FARI. Maybe just to put the dots on the i's, is also say, okay, what is actually responsible AI? I'm going to refer here to a colleague of mine, Virginia Dignum, who is currently in Sweden located. I could have put other books there, but I picked this one as it is also very well known. And what one of the statements she also makes about responsible AI is that it's the people have to recognize that these are not magical entities. These are AI systems that are artifacts that are built by people. People give purpose to these systems, so they make choices on how the systems would work and who can actually use these systems. One classical example they always give, at some point people decide to invent scissors, and they made scissors for right-handed people. So every left-handed person has a problem because they're not able to use scissors in a proper way. Making that kind of design choice actually influences who has access to this kind of technology, who can actually cut paper, who cannot cut paper, and so forth. The same is true for systems like AI. Systems, they are artifacts that are provided to people who actually either have the access, can have access. They're designed in such a way that they contain certain kind of information. In many cases, these Western European documents, for instance. So a lot of choices are made to actually drive these novel developments. AI ethics is, again, a large, broad term, provides us with a way to actually evaluate trade-offs. So ethics is never meant to provide a solution. Ethics is actually to allow you to discuss trade-offs between choices and actually trying to think about certain aspects. So about security, privacy, and fairness, and AI ethics provides us this way to actually think about AI systems in that context. What should be clear, I liked a lot what I saw this morning of the presentations, but these are arguments for technological solutions of problems. In many cases, there are no technological solutions for particular kind of problems. So we need to also be aware that it's not enough to just try to invent novel technology to solve that problem. Sorry. I was somehow losing. Yeah. And so Virginia, in many of her talks, always stresses these elements. She said, okay, responsible AI is lawful, is ethical, is reliable, is beneficial, is verifiable. And then it explains what she means by that. But again, I guess for this session, most important of her talks is, okay, how do you operationalize these kind of things now actually in the real world? And this is also essentially what FARI is aiming for, right? On the one hand, you need to think about how can you regulate these kind of things. Are you just going to let them always throwing this new stuff in the wild without any verification of the quality, of the results, of the performance of the results, without taking into account that there might be a lot of mistakes being made? You need to think about development of standards. This can be at an international scale, but also inside public administration or inside the company. Specifically, they can actually see what they want in terms of quality criteria. And for this, you would need kind of advisory boards, organizational structure that actually help out in doing these kind of things. And you want to make sure that you actually create a playground or a sandbox wherein people can actually test their ideas and evaluate, both from the business side, is my tool already ready to actually being sold to some kind of administration, or for the administration themselves, how will these tools affect our decision making, and so on. And of course, one of the last ones that's also very important is creating awareness and participation. So you want to inform the public, you want to inform the administrations on what they can expect, what they should not expect of these new kind of technologies. And like I said, this is exactly the raison d'être of FARI, and that's also why you have these three pillars defined in this context. So on the left, you have the research innovation, in the middle, you have education and learning, and on the right, you have building community of practice. All these three pillars came together in this new institute to actually solve these problems, and this was all very nicely managed in the last 4 to 5 years, I think, 4 or 5 years, by an excellent team, Karen, Hans, and Carl, who actually attracted a lot of resource to actually make these things happen. Just to give you a few examples, on the left you see again the research. We started pilot projects with public administrations to actually see how we can help in solving their problems. We had a number of PhD students that actually got a seeding grant that allowed them to start thinking about their PhD research and then writing a proposal for a funding agency to actually get funding for these kind of things. We had citizen science projects and so forth. In the middle for the training, FARI at its start actually started to tell people, look, if you want to understand what AI is, like the nice talk by Willem just on how to explain how does this system actually work, come and talk to us and we will see what we can provide. And gradually they have built up a pool of courses, of explanations, on even guided tours through Brussels, showing how data is gathered about you in Brussels itself. And actually there's a postgraduate course that I think is organized by the VUB side, also focusing on this kind of topic. And for community building, we already had like 3 FARI conferences from 2022 to 2024, all about the topic of AI for the common good. And I don't have a photo of everybody. Maybe I should ask Carl next time to give me a photo. But this is a recent photo of all the team members actually involved in this story. And I'm looking at the time, still a lot of time. I'm probably talking too fast again, as usual. So just as already a highlight, so we're going to have this conference again. So this is going to be in the 17th and 18th of November, right before the BNI conference in Namur. So we have first societal perspective on AI here in Brussels, and then you can all move to Namur to have all the technology of AI in the BNI and BNI conferences. And this focus this year will be about intelligent agents and how it is to live with intelligent agents. And this allows me to at least introduce a small bit of what I'm doing myself in this topic, because I'm also very much involved in intelligent agent research. And so essentially, when people use this kind of agent systems, they expect them to behave social in some manner, right? They expect them not to violate certain things on how we act in the world. And a number of nice books going from decision science, from social sciences to evolutionary sciences, to the AI books, and even to moral sciences on the right that you can actually look at. But essentially what we want is that these systems are social in the sense that they are incorporate the fact that they're not working in isolation, they're working in a social ecosystem. We also want them to act according to social expectations and fairness notions that we have, because essentially a human being is a fairness-seeking animal, right? We're not totally altruist, we're not totally selfish, but we're always looking for fairness. And then we have our own conception of what fairness actually is. We should not stimulate individual and collective biases using these kind of systems. And of course, it is also very important, you don't want to reduce or remove the agency or the sense of agency that you have. Like this morning, I was driving here with my car, and I have a new Toyota Corolla, and they have now this automatic system that they're driving with the lines. And if I want to go to the right, the wheel is forcing against my maneuver to actually stop me from going to the right. So do I really want that? I'm not so sure. This is a simple example, but I mean, you can go further than that. And one of the things that actually Forbes put on the pedestal not so long ago, it was saying the next big thing is you knowing how to delegate actions to AI systems. Okay? And so these are the skills that all these managers and people managing teams will have to learn to decide this is going to a human, this is going to an AI system. But this is rife of problems. Rao, for instance, in one of his presentations, said clearly, okay, allowing LLMs or any kind of agentic AI to make it, to invoke by itself, to plan its actions, some kind of external services, this is going to be rife with safety concerns. So clearly, if you want to do this properly, effective delegation is not just saying, here's a task and deal with it. It's also about that you have to trust the system, there needs to be some accountability, and of course, there needs to be an ethical alignment. And then just to give you a very small example of my own shop. So we had a project with Elias Fernandez Dominguez on understanding, okay, what is the effect of delegating your action to an AI system when it has to make decisions? I'm not going to explain in detail the example, just a decision-making problem that people or AI systems have to do. If people make these decisions by themselves in groups, we reach around 65% of success. So now if you say to these people, look, you pick your agent, here's a set of agents that you can choose from, pick your agent, is going to play the action for you. What you see is that suddenly you have a boost in performance close to 90% on this particular kind of task. If you then say, okay, let's mix people and agents together again, suddenly this drops back to human level performance. Okay? So this clearly shows, this is interesting to show that, okay, this is a benefit of delegating actions to an AI system. And why did this work? Because people could not rethink their decisions. They just decided from the start, this is how I'm going to behave, and based on that decision, everything worked fine, up to 90%. If they are playing the game themselves, at every step of the game, they were like saying, but wait, this guy did something I was not expecting, so I'm going to respond to that, no longer thinking about how they thought before they should do the game. And so this is why these AI agents act as commitment devices. This is all very nice. I'm looking at Leander, no stop yet, still 3 minutes, very good. So this is all very nice, and this seems to be improving. But then if you go and look, okay, the people who played that game, they actually were paid at the end of the game based on their performance, right? And if you had people playing this game by themselves, you have here on the left the gray bar that on average they all have more or less the same kind of payoff or money they go home with. But if they then, if you let then the agent play the game for you, you see a bigger variation in the gains. So you see a more inequality between people in the gains that they actually have. So this brings me again back to responsible AI, because like I mentioned, you need to think about the effects that you're having, about trade-offs, and essentially here is a nice example to see, okay, what do you prefer, more group success or people having less money for the thing that they actually were doing in the game, and more inequality. So I want Yopi and not FOMO in that sense. So to conclude, I think this is all related to FARI, and FARI has the ambition to resolve this kind of problems and to think about this kind of problems. And not only the project that I showed you from my side is relevant here, there are many other projects being done by people in the context of urban mobility, for instance, or in the context of sustainable robotics and things like that, that actually think about this kind of trade-offs and trying to find good solutions in the context of AI, robotics, and data. And thank you very much for your attention.
Thank you, Tom. We have time for a couple of questions.
Hi. Can you hear me?
Yes.
Oh, thank you. Thank you for the nice presentation. I have a question about the trade-offs, resolving trade-offs. Is resolving the right approach, or I mean, should we leave the resolution to the AI? Because of course they can resolve somehow all these trade-offs, or is this something that humans?
So I didn't put AI there, right? I just said resolving trade-offs. So it could be people, it could be humans, could be AI, it could be people and AI. But essentially, on the one hand, you have to recognize that there are trade-offs, and the fact that technologists like myself are pushed to think about this trade-off is already an important aspect. But then the question becomes, and like you saw this morning, people start thinking, okay, can we resolve this technologically, yes or no? Right? And then the people are going to try to see if they can find suggestions to either quantify these things and then actually have really a measure of understanding the problem, or if it's not possible, then you need to do this based on discussions with social scientists and all this kind of people.
Thank you.
Somebody else has a question? Okay.
Hi, I'm Marianne. Thank you for the presentation. I was wondering, you mentioned FARI does a lot with community building, with legal stuff. Do you do a lot with the European Commission, for example, with the general purpose AI code of practice that's being developed at the moment? Are you bringing in your experts?
Me, myself, no.
Sorry, you as in FARI, or people from FARI?
There are people from FARI working on the legal side. For instance, my academic co-lead from the ULB side, Grigory Levkovic, he's in the legal faculty of the ULB. And for instance, he was very much involved in explaining to public administrations, to companies, to people, what this AI Act actually means. But I'm not sure if he's directly involved in the development of the AI protocol itself. But for instance, I know people from Alice Alicante, like Nura Oliver, who is very much involved in actually define these kind of things and taking into account the same things as we are doing here. So, and we're having discussions with them, yeah.
Can I ask a follow-up question? If you're doing research on responsible AI and safe AI, why aren't you being part of this code of practice?
Because I have a limited number of hours in the day.
Well, you are a big team. You could have.
So I would be totally willing to do this if somebody took over my courses and all my other responsibilities. I can do that, but this is not my primary job, right? So this is all very fine if people can spend their full time on this topic, and that's also why I think it should be people probably coming from the legal faculty, but having a training in AI, for instance, actually should be more involved in these kind of things. Yeah, it's a matter of choices, I mean, and a matter of possibilities, and the universities don't allow us to make those choices, to put it like that.
Okay, let's thank Tom again.
Thank you for your attention.
So our next speaker is Pierre Geurts. He is a professor at the University of Liège, and he is the current director of TRAIL, short for Trusted AI Labs, which is the AI program of the Walloon region here in Belgium. The floor is yours.
Okay. Can you hear me? Yes, okay. So thank you for the invitation to present Trail. So the goal of this presentation is twofold. I would like to present what is Trail for those of you who don't know what Trail is, and then talk about what activities we have in relation with responsible AI. So unlike, oh, I pushed the cable. So I will not touch anything.
Maybe you can disconnect it and reconnect it.
Yeah, maybe. Thank you. It's a brand new connector. That's a good idea too. I have also a second one, actually.
This is one from Mac itself. No, but
no,
it's not,
I need a USB-C one. Let's try again with this one. Yeah. Okay. Sorry for this. So let's start. So we are we. So Trail is the Belgium French-speaking research and business community in AI. So it represents a community of about 250 researchers. And we like to say that it's nearly 1 out of 2 AI researchers in the French-speaking Belgium. So on board of Trail at the origin, since the origin, there are the 5 French-speaking universities of Belgium. So Brussels, Liège, Mons, Namur, and Louvain-la-Neuve. And 4 research centers active in the field, in the digital sectors, and we have activities in AI. It means CETIX, NIRO, Multitel, and CIRIS. So it's about, and we also include the network of university technology transfer officers, which is called Libre. And we have also on board public, federal, and regional organizations such as Digital Wallonia and AI for Belgium. And we are supervised by an international panel of experts, and we have also established partnerships with different companies, about for 35 at the moment. Our mission, the mission of Trail, is actually also a kind of built-in responsible AI. So our goal is to develop a trusted approach to artificial intelligence so that it may be a major transformation opportunity for our societies and the sustainable well-being of citizens. And Trail has actually been selected by the Walloon government as one of the 19 initiatives that will inspire the innovation and industrial policies for the period of 22 to 27. So responsible AI through governance. So the researcher who actually joining Trail has to sign the researcher charter, which has built in the charter the fact that they should work on the development of a trusted AI approach, accessible to the greatest number and benefiting to the entire socio-economic fabric of Wallonia and Brussels. And they also commit to following the regulation in place at the European level in terms of trustworthy AI. And actually the governance of the Trail is such that there is a scientific and ethics committee, and the role of this committee is to ensure that all actions that are taken by Trail complies with these regulation in a sense. And also if a partnership with an enterprise, he's made aware that the researchers have to follow these guidelines as well. So the goal of Trail is to have 3 kind of impacts. An impact in research. We would like to develop excellent research, of course, but we also would like to have a socio-economic impact, and also to have an international influence. And to achieve this, we built on 5 pillars. The first one is the Trail Institute, which is focused on the research and development. So we have defined, we'll come back to that in a moment, 4 plus 1 research teams, priority research teams, and with 50 funded theses in Trail that adds to the of course to the PhD students already in the different groups that are part of Trail, and organize a doctoral school also to ensure the training of these doctoral students. The second pillar is the Trail Factory, which is a platform that allows us to showcase the research done by the researcher. So it's a software platform where you can submit what we call bricks, technological bricks. And then we have Trail for Impact, which is responsible of the technology transfer and the contact with the industry. And to achieve that, we organize what we call the Grand Challenges. I will come to that in a moment as well. And then for the internationalization, we have what we call Trail for EU, which try to foster collaboration at the international level, also to start European project. And as part of that, we're also organizing an international summer workshops every year that I will talk about also in a moment. And then we have Trail for Talent, which is responsible for training. And to achieve that, we have organize hands-on workshops that are dedicated more for the industry, that help us to adopt new technological development that are done by the Trail Institute, but also by other actors in AI, of course. So the way we achieved responsible AI is mostly through the research team. So all of these research teams have actually been thought of at the beginning to ensure that we reach some trusted AI approaches. And so these research teams are the following. So we have first human-AI interactions, which focus on dealing with the interaction between human and AI, and then the different topics that are in this research team are, for example, human in the loop, where we would like to use human to annotate data so that it can AI algorithm can be trained, and then the opposite, AI in the loop, where we use AI to help human perform some tasks. And this team also include explainable AI, which has been talked about a lot in the previous talks. Just to mention a few projects that are going on in these different teams. So in this team, for example, at ULB, they are studying the impact of imperfect annotations in digital pathology. So how much the fact that the data on which you train the model is imperfect affect the performance of machine learning model, which is, of course, very important if you want to gain trust in the prediction of these model. So the second team is Trusted AI. Trusted AI includes, for example, federated learning, where we would like to ensure that you would like to train a model, but you would like to ensure that the data remains private. We have trustworthiness and certification, where we would like the model to be certified in some situation. You have robust AI that studies the stabilities of these models to change of parameters and so on. So one example of work in this domain is at UC Louvain, where they study the accountability of security of possible automatically generated news in a press website and so on. Then we have model-driven AI, which is about incorporating, not only doing AI from data, but incorporating any prior information you might have about a problem. So it's related to responsible AI in the sense that it allows to make AI more reliable, because you incorporate constraints coming from the physical world into the model, and it also allows the model to be more resource efficient, because you need less data to train a model-driven AI model. And just to mention one work at the University of Liege, we're studying the spiking, how to train spiking neural networks that are neural networks that require less resource to be used at inference time, and potentially are very useful if you want to reach a more resource efficient AI. And then the last research topic is embedded AI, which is concerned about putting AI model into embedded system. And in this team, we also focus on pruning model. And just to mention one achievement, there is a very nice library called Flanders AI, was developed by Nathan Rubens, who actually happens to be here in the audience. We have also a project at Université of Mons about AI for debunk, where they use multimodal approaches to detect fake news on the internet. So these are mostly technical work packages, but actually a couple of years ago we noticed that because of the advance of machine learning, it was also important to focus on legal and ethical questions, and this is the purpose of this whole event actually. So we included since this year a new research team specifically dedicated to the legal and ethical implication of AI. And the goal of this work package is threefold. We would like to raise awareness among researchers and businesses about the societal, ethical, and legal issues of AI. We would like also to use this work package to guide and inform the other work package so that researchers that are working more on the technical side are aware and can use this awareness to modify potentially their technological development. And we would like also through this work package to support more cross-disciplinary research, more rooted in the law or humanities and social faculties instead of just the applied science and engineering department that we were targeting so far. So I just mentioned 3 research teams that have been started in this work package very recently. So this is about research, and then I said that we want also to have a socio-economic impact, and so one way to achieve that is through what we call the grand challenge. So the idea of this challenge is that we, instead of defining theoretical fundamental research questions, we also define more applied research questions, and we call them grand challenge. These research questions are actually usually designed by by the research centers, who are more at the interface between the university and the industrial world. And then the idea is that the researcher involved in trial participate to this grand challenge in parallel to their usual work. And since these grand challenges have been designed so that they have a more direct impact on the industry, that's how we connect the two worlds of the industry and the research. Just to give you two ideas of grand challenge that are related somehow to responsible AI. There is one grand challenge about full spectrum privacy preserving AI, where with the CETIC they try to design systems, federated learning systems that allows to train a model, for example, using data from different hospitals without sharing the data between the hospitals. So the idea is that it's something that kind of architecture that can be useful in any application in the industry, and by building a brick like that, it can be reused and applied in other fields. And then there is also another grand challenge on trustworthy AI for critical systems, which is led by Multitel, where actually they use LLM. It's related to one of the talk of this morning. They use the LLM to explain the prediction of recommender systems. This is one part of the grand challenge, and the other part is also try to explain or measure or assess the uncertainty of LLM, of the prediction of LLM, which is of course very important in practice, and it's also related to one of the talk of this morning. We also in Trail are very active in promoting responsible AI through the organization of several events. I just enumerate here a few events that we have organized in the past couple of years were related to that. And actually, the last 2 Trail annual events were focused on that. So the one in 2023 was about trustworthy AI and how it is implemented in critical sectors such as medicine, for example. And last year, the event was about inclusion, parsimony, and plurality, the future of AI in Namur. And then we have also we will participate to the AI for Good Global Summit in Geneva in a couple of months, and we also plan to adhere to the European Trustworthy AI Foundation, which is led by the Conference AI.ai program in the future. So these are just some actions that we have made in this direction. Just to end this, we also organize with Trail what we call Trail Summer Workshops. So it's an annual 2-week workshop that we always organize abroad and close to an active AI ecosystem. So we have been in Paris, Lisbon, Nantes, and Berlin in the past, and in 2025, in September, we will be in London. So the idea of this workshop is that the participants of the workshop design projects that are focused questions that can be addressed in 2 weeks in teams. And then while the projects are selected by the scientific and ethical committee, and then there is a call for participation, and everybody can work on these topics. So it's open to everybody. So if you want to participate, you can contact us about that, and for example, propose a project in responsible AI if this is too interesting to us. So that ends my presentation. Thank you for your attention.
Thank you, Pierre. Questions?
Thanks for the presentation. On one of the slides, you did mention something about spike computation.
Spiking neural networks, yes.
Yes, what's that about?
So a spiking neural network, I'm not an expert on that, but spiking neural networks, the idea is that you have, instead of sending a signal, you can send spikes in the signals that are only active a very short amount of time. And so that's one way to, I mean, that's a system that can remain idle, but without consuming a lot of energy. And you can try to do the same kind of computation that you do with traditional neural network with these neural networks, but you can do it with much less energy. The problem is that you cannot train them as easily because you cannot use the techniques like gradient descent and so on, so you have to be a bit clever about the way you train them.
But with RNN, you also cannot do like parallel processing, so you have to, it takes more computational time, right?
Oh yeah, that's, you probably have the same, so you to run these kind of neural networks, I don't think you can really, no, I'm not really an expert on that, but I don't think you can use the same kind of GPU that you would use for, and you might have the same kind of problem, but it's really about having the system remain idle, and then only when there is a spike in the signal, then it reacts. It's related also, I don't know if you know about event-based cameras and stuff like that.
So this is more for time series kind of...
Yes, there is really a sequential and temporal nature, but you can also, for people working in this are using this kind of neural networks also for MNIST data sets, so you can use them for regular problem as well.
Okay. Thank you.
Anyone else?
Thanks for the talk. So your sketch of what you're establishing, sort of in a collaboration between the universities and companies, it reminds me a lot of initiatives that are happening also in the Netherlands, where you have also the National AI Coalition, and they have this concept of ELSA labs, where they bring technical and legal knowledge together. And so my question is actually, and also focus a lot on responsible AI. So my question really is, like, do you feel like that every region in the world should basically have this kind of network and become world leaders in responsible AI, or should different regions focus on different, trying to become specialized in different topics? That's not
that's a tough question, but from the point of view of research, my answer would be that indeed we can have people specialize into different subfields, but when it comes to have a socio-economic impact locally, I think that we have to master every topic so that we can answer to any question. I mean, companies in Belgium have the same kind of questions as other companies, and the broadness of the questions is the same, whatever the place. So I think that we should have some duplication of the expertise everywhere. and it's easier to, it's easier for us to talk with company in Wallonia than for company in Wallonia to talk with people in the US, in Finland, and so on. So, but in terms of research, I agree that everybody should. Everybody needs to have its own niche or subdomains on which to work.
So, I think that makes a lot of sense. But I thought that was a really interesting aspect of what you're producing, is that you're visiting the other countries, other ecosystems.
That's something that we are quite happy and proud of.
What is your experience with that? Is that do you learn best practices from these other ecosystems?
You mean best practices in terms of responsible AI, or in general?
How to organize yourself?
Yes, we learn a lot from that. Usually we go there with. So first the doctoral students are going there, and then as professor, we go there as well, and then we organize meetings with the ecosystems, local ecosystems, and we have meetings and trying to start European project together. And that's very profitable, and we learn a lot about the way these ecosystems are run. So I encourage you to do that if you have the same kind of systems. It's a lot of work to set up these workshops, but it's well worth it.
Thanks.
You're welcome.
Okay, let's thank Pierre again.
Thank you.
Next. So our next speaker is Sabine Demey. So she is working at IMEC. She has been director of the Flanders AI Research program since 2020. And she will talk about FAIR's perspective on responsible AI.
Okay, good morning, already almost noon. Thanks for having me here on this event, and it's really indeed great that we are here with so many people from the different regions in Belgium. I will talk to you about the operationalization of responsible AI in the Flanders AI Research program. So how are we looking at responsible AI? How are we using it? But first of all, what is the Flanders AI Research program? It's part of the Flanders AI plan. That's a government-funded plan, funded by the Flemish government. It started in 2019, and the overall goal is a successful adoption of AI in Flanders. What do you need for that? Several aspects, as you see here, different pillars. You need research, so we have the Flanders AI Research program. I will talk more in detail about the program. But of course, you need to get the AI implemented at companies and organizations. That's the second pillar. And then in the third pillar, you see there the topics and skills and training. And that's both for PhD students, but also for professionals. Lifelong learning is very important. We have the Flanders AI Academy for that. Ethical and legal aspects are very important. So we also have the special knowledge center, data and society, covering these topics. And the involvement of citizens, public outreach is done, for instance, by AMAI projects. On the Flanders AI Research program, we are, in fact, one program bringing together a critical mass of researchers in Flanders. That's us at our latest research day in October. Well, that's us, the researchers in the research program together, that about 300 people, together with 200 people from companies and organizations, because the interaction with them is very important. In the program, we are with 11 consortium partners. You see them at the bottom. All Flemish universities are there, and also 6 research centers. And indeed, IMEC is the coordinating partner of this program. You see some other figures there, 40 research groups, 90 professors. We have funding for 100 PhD students and 40 other researchers, 40 FTE other researchers, postdocs at universities, researchers in the research centers. But the number I'm most proud of, people involved in the program know that, is the number 1, because we have one program book in which we all collaborate together on research challenges, and also very special for this program on use cases. Actually, the screens you see there are from all of our 27 use cases we work on. These use cases come from four main domains: health sector, industry sector, and then what you call the twin transition society, and then energy transition, but also care for our planet. There's a lot to talk about that, but that's not really the topic of today. So if you want to know more about that, contact me later, and I'm happy to pass you to the different people working on that, or give you more information. I would like to explain more how the responsible AI and trustworthy AI topic is important in this program. Because you have seen the main goal is successful adoption of AI. The question is, what has a link with responsible AI? And the question is, I also get, if the goal is also to have responsible AI in industry and so on, why is responsible AI so prominent? The explanation I give, and because I think if you really want to have a successful adoption of AI, if you really want people to use AI, it's really crucial that they trust AI. The moment that people start losing trust in AI, they're not going to use it. You're not going to have the effect that you aim for, be it in economy, in healthcare, and so on. Letting people trust AI is a very complicated problem. Issue, because what is trust? Trust is a very intangible thing. But one of the things that we certainly need if you want people to trust AI is trustworthy AI. And so we have this as a central theme in the program. And also, sometimes people say it's trustworthy AI, it's responsible AI. What's the difference? I mainly use responsible AI to say that we need to be responsible in the way we use AI and in the way we develop AI. And trustworthy AI is somehow a part of that. So how are we now tackling the problem of the thing of responsible AI in the research program? And it's really integrated in various levels. First of all, in fact, you have no choice. We need to be regulatory compliant. And that's something in the program that is taken care of by all the partners. They have their rules for compliance, ethical committees, and so on. So they really take care of that. I'm not going to go into more detail on that. I will talk more about the other topics. So the other topics are how do we reflect on the ethical aspects and how do we make sure that we adhere to them? How is the responsible AI reflected in the way we have chosen our themes and use cases? What is the research we do in technologies that are needed for responsible AI? And then how do we disseminate and collaborate in Flanders and Europe on this topic? So on the topic on how do we adhere to the ethical principles and how do we reflect on it? First of all, and it's subdivided in 4 topics. One of the things we have been doing at the start of the program is to create awareness of this for all researchers of the program. Because it's not always obvious for starting PhD students that responsible AI is a thing. It's something that they have to take care of. And so how did we approach it? Well, you have the definitions, the ethics guidelines for trustworthy AI by European Commission. And you see there the 7 aspects. I'm also not going into detail on that, but we have these topics. And we can, of course, throw that at our researchers, at our PhD students and say, this is, it's technical robustness for sure, and privacy and data governance, take care of that. What we do in the session, we try to make it a bit more tangible. And for instance, and again, it's a lot of information, and it's not that we have to go into it in detail, but it's mainly to show how we approached it. For instance, when I talk about privacy, we made it more concrete. If you're doing research and you're using AI also in use cases, do you respect data privacy? And then we had also use cases. We had also examples on what this practically means. Do you take into account the quality and the integrity of data? So we translated all of these, let's say, theoretic things into, let's say, more the practical aspects for that all researchers and students should take care of. Also, transparency. What does it mean? For instance, are you notifying the users that their data is used? That's one of the aspects in transparency. So that's one of the aspects, and also stressing that this is something that you have to continuously do during the life cycle of the project, not as an afterthought. And that's why it's also very important to start reflecting on that when you start your research. Although, and if you, for instance, look into the AI Act, the research is excluded in theory, but it doesn't make sense to only talk about irresponsible AI in your system if you haven't included the first steps. So that's why we are stressing to researchers that we have to include it from the start. Another thing that we did last year is a responsible AI self-assessment of the use cases. What did we do for that? Well, there is an questionnaire, and Virginia Dignum, you referred to her, also had made an abbreviated shortlist with 15 questions. We noticed that it was not perfectly suitable for our use because it was mainly focused on a system that comes on the market. How should it satisfy the rules? But yeah, it really was also reflecting back to these criteria, and in the end we found that it was better to use that than to create our own. Because if you start to create your own, there's also the discussion on is our thing then better than something that has already been discussed with a lot of people and be approved. So although it was not ideal, and we had to rephrase a bit the questions to make it adapted to research, we use this. So we did this for our use cases. What did we learn from it? So on individual basis for the use cases, it really triggered a good reflection by the researchers, because already by asking the question, they started reflecting and started to think, we should do something. So they started taking action. On a consolidated level, and so we made also this spider chart. It didn't really learn us a lot. We saw some trends, but it was less clear on which actions we should take in general. But we're going to following it up later this year or next year, and we'll see if there is evolution. So this is the way in which we are. One of the things we are looking into a responsible AI and using it concretely. We also did, as an example, we did a future thinking workshop a month ago with PhD students, academic staff, other researchers. And without having imposed it top-down, the topic that popped up bottom-up was a lot on responsible AI, trustworthy AI. So that is really a topic that appeared, in fact, in all tables where they were discussing this. So it really shows that this is something that is, really a living theme with the researchers. On the topic of having a charter in the program, it's under consideration. On the one hand, it looks like nice to have something like, okay, in FAIR we are talking about this, or we are taking responsible AI seriously. On the other hand, we have those 11 consortium partners, they all have their charters, their mechanisms and so on. And it felt like it was a bit on top and yet another document that people might need to sign off very quickly. So we decided at this moment, it looks like the things that are in place with the partners are enough to cover that we are responsible in the research of AI. We are also, take a responsible choice of the use cases that we do. So we choose use cases that have our meaningful impact on people, on society, economy, the planet. And we also, in our research, focus on trustworthy AI. And I also mentioned especially the resource-efficient AI, and I noticed that Trail also mentioned this. This is a theory, you could say it is included in trustworthy AI, but it's just such an important topic, and we really have specific research on that we highlighted. So how are we efficient with all the resources that we have, be it energy, being data, be it people, when we develop AI. Next slide, I'm going to show all the work packages that we have, and we don't have to go into detail on that, but it's mainly the picture to remember. So we have the research challenges, and we have responsible AI, separate work packages in these challenges, but also the verticals, responsible AI. You see it in each and every work package. So it means that when it comes to explainable AI, this can happen in one of the topics. We also causality is also, and explainability, fairness. They are both separate work packages, but also in the different work packages. What are we doing there? Well, it's maybe easy to say, yeah, your system needs to be bias-free and fair and transparent, but how do you do that? If you actually have an AI system, it's not so easy to show when it is transparent, explainable, fair, and also not how to improve it. And that's actually what we are doing in the research program. Last topic, we feel also that we need to disseminate on responsible AI, what are we doing, and to collaborate. And how we're doing this, for instance, Flanders, our last year's Flanders AI Forum, where we had about 800 participants, mainly from industry. Responsible AI was a key theme. We had our plenary talks about that. Recently, we also had a citizen panel looking into our use cases, giving their perspective on that. And of course, we have different sessions all through the year. On collaboration in Europe, because it was already touched in the questions, it's also important. I was involved at European level, being co-author of the guidelines on the responsible use of generative AI for research, which we are also applying, of course, in the program. And I've been participating, but that's through the cabinets and the political level, on consulting on the AI Act texts. That's responsible AI, let's say, through the different levels of the research program. And probably time for some questions, Leonor.
Thank you, Sabine. Questions for Sabine.
Thank you very much for the presentation. I'd like to know if there is any potential collaboration between FARI and TRIL, since you talked about connection on a European level. What about within the 2 or 3 different communities in Belgium?
Yeah. Well, in fact, Europe, I meant outside Flanders. Of course, we are since the start in contact with RAIL and FARI. We know each other well. And that's also why we joined in events like this. For instance, in our research day 2 years ago, we had also a speaker from the University of Namur talking about responsible AI in our research day. When it comes to really joint research, that happens less, I would say, within the regions than it is indeed with partners in Europe, and that funding is the main reason, because bluntly said, it's easier to have to step in a European funded project, because there are no mechanisms to have a Belgian funded project with participants, well, almost not in. So that's why we have those collaborations a lot also in Europe. But we are happy to exchange, and there are even people like Thomas is part of both.
Everything. Yeah,
of everything. So, and also Anne is also. Anne was also here, I think. Is also part of multiple programs. So through the people, we are also collaborating.
More questions?
A bit related to that. So thank you for the talk. It's also a question about all the initiatives, which seem pretty close to each other because they all focus on responsible AI. But somehow a bit different, so I feel the focus might be a bit different, which I think it's nice, because then you have all these different views. I was wondering if this idea of responsible AI, I mean, there is no global, I think, perception of responsible AI. For instance, in terms of fairness, the context matters, right? So I was wondering whether the context matters also in Belgium, so whether you have different, I don't know, expectations or different ideas about what is responsible, or there is an agreement in terms of what is responsible and how it should be made operational, but it's really the funding question.
I've been looking indeed in definitions of responsible AI, trustworthy AI, and there are different definitions, but in fact they all boil down to the same. They are a bit reshuffled and reorganized, but in a way all the different aspects are there. I see responsible AI versus trustworthy AI more as trustworthy AI you can take for instance the definition of the European Commission. The responsible AI is maybe a bit more intangible, but it's that we need to take the responsibility to develop and use AI in a responsible way for the best of ourselves to create a sustainable future and so on. It may be intangible, but I think you see when the use is irresponsible or when you're doing something irresponsible. And I don't know if you really need that sharp definition on what exactly it is. I think by doing what we are doing now and taking care of that, it's already a lot. If you look at the 7 requirements of trustworthy AI, none of the systems that have is really close to what it is. So if you already start improving that or getting that right, I think we'll do a big deal already.
Because I think you don't have all these requirements for all systems, right? So for some you need explainability, for others perhaps you don't need, or fairness, right? So I was wondering also if you have some applications, representative applications, because you mentioned the use cases. So if you have some...
Yeah, so some of the use cases you could say they are less relevant. Nor I would not say they are not relevant. They are relevant there, but sometimes you don't need a lot of extra things because... but if you look at explainability, but also privacy, transparency, also some of the applications that at first sight industrial, where people might say it's not that relevant, it is relevant. At least you should reflect whether it is relevant to your use case, and then your conclusion can be, okay, we are doing everything that is needed, is sufficient. But you need to reflect on everything.
Sorry, we don't have time for questions now, but Sabine will be back this afternoon in the panel, so we'll definitely hear more from her there. Yeah. And if you have questions,
and during lunch, you can also talk.
Yeah, thank you, Sabine. So our next speaker is Ambrish Rawat. He's a researcher at IBM Research Ireland, and he will share with us his presentation on securing generative AI.
Nope. All right. Yeah, hi. Thanks for the invitation. So I work in the AI security and safety team within IBM Research, and I'll touch upon some of the things we do in industry side to look at responsible deployment. We've, of course, pivoted to Gen AI as well, so most of the focus will be on generative AI. But to start the conversation, I think securing Gen AI has existed previously, securing AI has existed previously, and in order to contextualize it for generative AI, it's important to understand what's the old and what's the new. So a lot of conventional threats still exist in the Gen AI space. There is social engineering, there is phishing attacks through Gen AI systems. Some have taken new form. For example, when it comes to phishing attacks, you can actually automate them and do them at scale using AI systems. And then the third, more important one is this idea of emergent threats. Because AI technologies come with new capabilities, there are a lot of new emergent threats. And that landscape is what is evolving constantly with new models and new technologies coming in from different corporates. So my focus is going to be on some of these emergent threats. And because of these emergent threats, all the organizations need to reconfigure their outlook towards risks within their software systems, within their business pipelines, along with how you have governance established so that there are no fallouts. So what are the new and amplified risks, right? So last year, the IBM Ethics Board had released a technical report or a white paper on what new and emergent attacks exist on the model side. There was a lot of focus on foundation models. Models was the first software entity that came out. And now that has shifted to AI agents. And when I talk of agents, you're talking about AI systems deployed within AI is embedded within a system, and they have some autonomy and access to tools and external resources to perform tasks. So you might have heard of a lot of these words already. Few that are very security-focused risks are jailbreaks and prompt injections. Then there is access to external resources within AI systems, which opens door for more attacks. Because they have access to tools now, you can have unauthorized use. You can have an agent working, and I think I'll give better examples afterwards, actually. Then another new dimension is hallucination. And hallucination is when they confabulate stuff, when they come up with things that are unexpected. And this becomes important in the agent world because they might be deployed with access to tools, and you might be able to invoke those tools with parameters that they were not designed for. So let's take some few examples, right, and just try to contextualize some definitions around these. So jailbreaks are typically referred to, when we talk of jailbreaks, we refer to these prompts which have some sort of manipulation embedded in them so that they can bypass the inherent safeguards that exist in the system. Typical inherent safeguards are either baked into the model itself. You might have seen lots of these examples on Twitter or X. Then the second more common and probably more relevant in terms of security is injection attacks. An injection talks about if you're deploying a system with some purpose or intent, you might be able to craft a prompt that overrides that instruction and makes it perform tasks outside the scope. Right? So direct prompt injection is one. You don't expect an AI system with some confidential information in its system prompt embedded in an application where you can override the instruction and ask it to reveal that confidential information. And that's feasible because of the way these LLMs behave. Then there is indirect injections, which is when you may have a system connected to some blogging website, say for some products, and suddenly one product gets favored whenever somebody asks this chatbot. And the reason being, in one of the reviews, there is an indirect injection attack which always favors this product. Right? So that sort of scenario exists. And I think finally, more interesting one these days for agents is excessive agency. So imagine you have a Python interpreter connected to your agentic AI system, and suddenly an attacker can escape the classical boundaries and ask to execute commands on the underlying machine. It can ask for environment variables. It can do a reverse shell attack. All those scenarios are feasible now. These are something that existed in the software industry previously, but they are sort of evolving with this AI landscape. Let's take a few examples of just to show how the spectrum is, right? So consider a simple bot, which is tasked to perform some summarization task. So that's the original system instruction for the LLM. Now you've seen some classical examples of how to build a bomb, etc. Right? These are examples which are just unsafe requests, and that because of our human perception, we think of them as unsafe. Right? Then moving more towards the adversarial scenario involves manipulating these basic unsafe questions to something which is malicious in nature. So you can ask the model to ignore all its instructions. You can ask the model, you can give a story or a hypothetical scenario to the model, and that results in the desired malicious output. And I think finally you can actually craft these highly optimized strings which may not mean much to human, like the one on those bunch of symbols followed with a confirmation message of sure, here's a way. But if you give that prompt to a model, this is just an illustrative example, but something similar, the model will do a malicious action. In this case, the malicious action being asking it to do insurance fraud, which is not something you expect from an insurance application. These things have evolved, and I think things on the very right are very research focused and also things people are constantly discovering. Sometimes you train a model in English and you'd expect that it will behave same across all other languages. And it often happens that if you ask some question in Zulu or some other base 64 or some other encoding, it suddenly responds because it's not trained with that language. You may even have more dynamic attacks where you actually engage with the model in a conversation in a multi-turn setting, or you actually use another AI to craft these attacks. So a lot of different complex attacks exist. The first thing we've been doing in order to scope this is to figure out when you try and scope the risk, right? The good thing about this is it's ripe for research. There are lots of open questions. So the first thing we began was taxonomize this and look at all the different attack techniques that exist. So in order to jailbreak or do prompt injection, there are 5 basic categories that we've observed so far, and a lot of subcategories. And this is an ever expanding list, right? Because people do discover these new attacks. I won't get into details, but the details are there in paper. But the idea being that, yeah, the first task is scope the problem. Second, more important aspect when it comes to Gen AI is a lot of focus has previously been on model-centric security. And when I talk of model-centric security, people talk of input-output behavior. They observe, they put something on ChatGPT, they observe an output, and then it's considered unsafe. But that's actually not the real threat, right? The real threat is when you deploy it in a pipeline and it has access to other resources, and an actual action happens. Text in, text out is interesting for a bit, but a text in and change in the environment is something more critical. And that's where you need to secure your systems. You can't deploy them without having the right checks. So you begin with the classical threat model analysis. You look at the attack surface for a model. You look at the attack surface for an application. An application has an architecture to it, has external resources to it, has a memory component. So you have to look at inspecting all of these different components. Your attack goal is not just a safety policy violation, but it is beyond that. It goes to some of the classical well-cited ones are these OWASP top 10 risks or MITRE Atlas, and they look at different risks within an application. The vulnerability also changes. So jailbreak and injections are not the vulnerability, right? These are the threats. The actual vulnerability of a model is it selectively decides what instruction it should follow and what it shouldn't. This selective agency of picking one instruction over the other, that's the key vulnerability. And that expands to a new level when you think of system, because now you have a system where there is a control plane to it, where you give instructions for how the model should interact with tools, and there's a data plane to it, in where you provide the data to get resultant out, like the required outputs from these tools. So to give an example, there could be a control plane to call a Python interpreter, but then the actual Python code will be the data plane. However, in case of LLMs, all of this data plane and control plane resides in the same long prompt. And there is no fixed boundary between where the control plane shifts to a data plane. That's the key vulnerability that people have observed with respect to Gen AI. Right, so how do we approach this from a red teaming perspective? Right? There are three important sides to it, and there's often overlap in these. So first thing, as I mentioned, was look at what are the threats. Now this is an open-ended exercise, and when we red team a model or when we red team an AI application, it's completely manual, or often manual. There's some automated tools to help, but it's very open-ended. Open-ended is the key focus. And it has to be context dependent. You can analyze some of these models, the general purpose models, which are chatbots like OpenAI, et cetera, for general purpose risks, but more importantly, you have to look at context relevant risks, because there the small models are deployed in a particular application. When you're doing the red teaming exercise, use everything that you have at your disposal, be creative, and find the key vulnerabilities. Another important aspect, which is often missing in a red teaming exercise, is you need to perform some sort of severity analysis. Often, since it's a research phase right now, when people do red teaming exercises, they often report a number. A number doesn't always tell the complete story. And I think any scientist would agree, right, that when you see a metric, you need to look at the details of the metric. That's often hidden when you talk of red teaming exercise. Next step, when you have done this manual or open-ended red teaming, is to find how many of those things are automatable. And that's the thing you can put in your CI/CD pipeline, in your deployment process, in your governance process, because that's an assessment piece. An assessment piece is driven by these automatable components. They're threat model driven. They need to have wide range of security attacks explored. They often result in some benchmarks, and that's a common paradigm within the Gen AI world to rank yourself with respect to these benchmarks. And I think I mentioned this previously, don't do assessment just for model. I think we focus on application-oriented red teaming now. And finally, make sure they're context aware. Once you've done these automatable assessments, you get some results. The next step, of course, is how do you safeguard them? And safeguarding in LLM is also multifaceted. It's always in security, I think we go for defense in depth. So you have multi-layered security controls. You begin by improving the model. That's the first thing. And that's typically done by post-training. So you might have heard of SFT or RLHF. These are common techniques people use to post-train. So you make sure that they have certain behaviors that are consistent with what some AI commitments prescribe. Then finally, you make sure that the way you invoke them is secure. So if there is a system prompt, you try and improve the security of that system prompt. And then you build guardrails around them. That's the key bit, right? So if you deploy a model, don't deploy a bare model. It's typically advised that you build some guardrails around when you're deploying them. Finally, I think once you have developed these safeguards, it's very important that you red team the safeguard as well, because typically in a red teaming exercise, you need to do this iterative fashion. You build a mitigation, red team the mitigation to find further flaws, and keep improving. It's a never-ending process. And to that effect, we've done some research and tooling, right? So from an industry standpoint, we've been doing research to come up with tooling to help with this space. The first thing I'll highlight is what we've recently open sourced is this Risk Atlas Nexus. This is a tool which helps you navigate through this different taxonomy and risk resources that exist out there. So you can specify a risk that are intent in natural language, and then figure out what are the different prescribed risk definitions, say by the NIST. In this case, I think the example is the NIST AI framework, or by the EU AI Act, or by other risk atlases. Pick the required taxonomy, pick which language model you want to use to get the study going, and then you get the required risks listed. It's an open source tool, it's a Hugging Face space, you can go check it out. Finally, from a product standpoint, we often have clients coming in who want to deploy their, or want to leverage AI to improve their enterprise applications. In order to do that, they have to go through a governance and compliance process. And to that effect, we have a product called Watson X Governance from IBM. And within that, we have been pushing towards these automatable tools that I mentioned, one being this model risk evaluation engine. So if somebody's onboarding a new model, if a company wants to decide whether I want to use the Llama models or OpenAI models or IBM's models, whichever, you need to go through a risk analysis exercise, and model risk evaluation engine is a Python SDK helps you do that. Finally, when you're deploying the model, a prompt engineer or a similar role within an organization needs to do the required security checks. And they can do that with another Python SDK that can run the different adversarial scenarios for them, score them, and they can include some mitigations that are advised based on the automated analysis, and make sure that those things are green before it's deployed. Finally, within the LLM space, IBM has been releasing their own set of models, and that's what at least my team's researchers goes through, which is, our models are called Granite. These are small language models, and when I say small, they're about small because they can fit in like 1 to 2 GPUs as opposed to requiring a cluster. So there's still a few billion parameters. We released them under Apache 2.0 license and complete open source. So they are open weight models. As I mentioned, they're cost effective. They are designed for scalability. I think the key bit for this audience is they undergo a rigorous exercise of cluster analysis or safety analysis, and also along with that, we have a responsible use guide, which tells how to actually deploy these models in practice. A key exercise that we do as part of this analysis is we make sure that they are secure or safe along some benchmarks. And in this benchmark, I think it was found that Granite performs pretty well compared to its analogous models from other organizations. And it scores pretty high on this particular data set. I think moving on to what I mentioned previously about guardrails, that's one of the core things from my team. Granite Guardian is a guardrail that we've developed. So even these guardrails now are AI driven. So you build these guardrails around an LLM for this input-output interaction. So before an input is fed into an AI endpoint or a closed weight model, it can be filtered with the Granite Guardian. Similarly, the output can be filtered before it's sent back to the user. And these are also some things we have released open source. They come in all different variants from 2 billion size to 8 billion. And we're working towards even smaller size because you actually want to deploy them on edge devices and that's the key research problem there, to make sure that these are, like the inference can be scaled on like low resource settings. They're novel in the sense that they don't cover just the classical social risks that are often highlighted for LLMs, but more application-oriented risks like hallucination in case of RAG. So when you're using RAG, just to give a brief overview, RAG is a system where you have a set of documents linked to your AI application. So you first retrieve information from those documents, put that in your context to help the model give better answers. In that case, you might have a classical set of risks of whether your response from a system is relevant to the document or not, whether the information retrieved from the summarization is relevant to the document or not, or query or not. So these risks are covered. To give an example of how this behaves, a simple filtering exercise. You have an initial prompt, goes through this model. The model predicts a label along with the confidence estimates. Nowadays, I think customers have also started asking for verbalized confidence, so we also try and verbalize this. We're working towards making it more useful with like even reasoning models. And once it's detected, you can put some thresholds to detect whether this should pass on to the AI endpoint or not. On the output side, it works similarly. Hallucination, as I mentioned, is a key one. So for example, in this case, you may have given a context where some annual interest rate was specified for 20 years, but then when it performed the tool call, it needs to convert this into this tool call format, where it may come up with its own number, 25 instead of 20. So this is like a hallucination that happens when you deploy them for function calls. So we have trained it to make sure that it can detect these function calls. So as I mentioned, these are different risks it can detect. Some of these are general harm risks, be it multi-turn or single turn. These are RAG-based risks, and then the function calling one. It performs pretty good on benchmarks, and I think I forgot to highlight in the previous one. We recently found out that on a public benchmark, it came from some European project recently, that it actually topped the charts. I won't get into details. The first one is a harm one, second is hallucination, and third is the function calling hallucination, but it performs pretty competitively on all of them. I think finally I'll mention some of the latest research in this, and these are experimental things we've been looking at. Now, this model that I talked about is an external model that sits, it's trained with SFT and sits outside your endpoint. However, you can leverage your model's own capabilities as well. And I think it was highlighted in some previous talk that these models work through these attention layers where you have key value and query matrices. You can reuse them. So I think if anybody in the audience knows of the LoRa adapters, these are these low-rank adapters that make efficient inference or PEF methods for fine-tuning. You can do the same with what we have called activated LoRa, but the difference is now you reuse the cache, so this is much faster inference compared to LoRa adapters. So you can repurpose that for even detection, and in this case, we've released it for jailbreak detection. With that, I think I'll conclude the talk, and hopefully still have 1 minute. Perfect. Then I'll do a final advertisement. We are hiring pre-docs. So we work very closely with the Trinity Research, Trinity University in Dublin. And we're actually based there in the same campus. And we're looking for pre-docs. If anybody's interested in, can come talk to me.
Thank you. Questions?
Thank you so much for the talk. In slides 7 and 8, you made an interesting point about separating model system risks to system level risks. And then I was wondering, what do you do when the company creating the model is not the company creating the system? So company A creates a model, sells it to company B, and then company B embeds it in a system. What do you do then to make sure that you're taking all the necessary precautions and safety research and stuff like that?
I mean, that doesn't change the scenario for analysis. Analysis still remains the same. I guess what you're leaning towards is how do you make sure who's accountable?
Not really. I mean, technically, yes, from a legal perspective, but I'm more interested in, like, if I get a model, if I buy it in a box, I guess I can't really do that much research on it because I don't have all of the information. So do you then need to make sure the model is, like, are you able to completely protect the model so that no matter what, I just need to do system level protection or, yeah, stuff like that?
So that varies, right? So there are some models which are open weight models. So they are released as files, right? So you can inspect them. But some are, of course, endpoints like ChatGPT or Claude, etc. So in there, we, from a platform perspective, we support that, okay, you can have, as a customer, you can go and have access to any of these models. But we will provide you external safeguards on top of that to make sure that if you don't find that safe enough, we'll provide you extra safeguards. That's how we approach it.
Okay, thank you.
One quick question still, yeah.
Yeah, I think she already asked my question, but on slide 13, that's I saw.
Next one?
Slide 13, yes.
Sorry, which one?
13. Yeah.
13?
Yes. So I'm just trying to understand this architecture. So you have your prompt coming in, goes into your SLM, right?
Yeah. So
what comes out?
So, oh yeah, so that was this, right? So there's usually a label, and at least a label and a confidence, along with few other things. But these are the key ones, a label and a confidence.
So it gives you a response, so the response is not fed to the LLM?
Yes. It gives you a binary label, right, that you can, and with the score that you can threshold on, and decide whether you want to actually forward that the prompt to an endpoint or not.
Okay.
That would be the guardrail there.
Okay, but then also at the end, you also have the same thing. What's the point of it?
You have to do both input and output. So, and typically in security, it doesn't make sense to just have one guardrail. It doesn't guarantee you, right? It gives you some performance numbers, but it doesn't never guarantee. So you build multi-layered guardrails. So you make sure you have something in input and output, just to make it a bit more defense in depth. That's the only idea.
Thank you.
Okay, Thank you, Ambrish. So, and our final speaker of this session is Panagiotis Germanakos. He is a researcher at SAP in Germany, and he will talk about trust in AI from a human-computer interaction perspective.
Okay, hello. Thank you, Dimitri, for the invitation and the organization team. I think it's a very nice blend of talks approaching responsible AI and trust, fairness. I think all these terms have been nicely established. I would like now to embrace a different stance to the problem, and it's actually the king that uses all the systems, that uses AI, it's the user. So I would like just to embrace this angle and just imagine the end users that they're executing daily tasks. Even yourselves, when you just grab your phone and you want to interact with the applications, even via immersive reality, maybe environments or augmented reality environments, no matter the touch point, at the end of the day, what we'll try to see is, in the first part of the talk, is how this technological evolution and generative AI, more or less, has affected human-computer interaction, and how this relationship of the user with any system needs to be reestablished. And from then on, I will just present a alternative way, a publication just around an academic graphic novel with deep dive textual chapters that released in March in collaboration also with Dimitris and the ULB, just to show how working industry with academia can provide explanations to the users, because users might not be, usually are not experts, okay? So those that they might interact with AI environments, but however, they would need to have an understanding of what's happening in this hidden world of algorithms, of networks. So again, from the user perspective, just in less than 100 years, we've seen that from using the computer or the system, if you want, just for simple actions that might be augmenting, let's say, to daily activities, or as it used to be back in the research lab in the university some years ago, when we were receiving a question, why do you use AI? So an anecdotal response was that it was our last hope to get answers for problems that we don't have, okay? And all of a sudden we see that today we're talking about interfaces and systems that they might imitate human-like behavior. And therefore, from a traditional, if I may say that, AI perspective, where it would facilitate, let's say, more transactional human-computer interaction or user experience for the user. So if you see that, do that. So the user would have more or less full control, no matter what were the capabilities of the system, of course. We moved on to a conversational perspective, where the user more or less asks what he wants to do, and then he gets an answer. So from open, save as, edit a file, if you would, let's say, had a drop-down menu in a very common sort of application, like Word files, for example. Now I'm moving forward to commands like rewrite, summarize, answer this, and the user, without knowing what happened in the back, all of a sudden gets an answer. So it is a new paradigm shift in reality, is what that it brings, generative AI, that the users in reality tell the computer what they want. And imagine if we were talking about agents now, agentic AI, which is not, it's let's say, a new strongly attention point even in the industry in the last year, whereby you're talking about components that they might have the autonomy, they might have specific schedule for executing actions, they take decisions, and they behave even in situations as humans, and they return answers. So at the end of the day, I think we all agree that we're talking about human experience. This is, in the end, what would, let's say, allow any AI system to fly or not. It's about the engagement of the user. It's about the motivation to take specific actions using, let's say, an interface. And from then on, what would be an end-to-end experience that it would have. Therefore, AI or generative AI, it's not anymore a parallel dimension. It is an embedded reality to daily life. And this is, I know that we talked a lot about it, but from the user perspective, this is huge. It's huge how the rationale, how the expectation, how the mental models are changing in order for the user to interact with a specific system. In designing such systems, and by saying design, I'm not only referring to the visual, let's say, screens or the visual perspective or the aesthetics of an interface, but rather to the whole interaction paradigm that might start, let's say, from a decision that an algorithm might make or a path that might take until it gets to the user and then it gets an answer to continue. So all this interaction, which in reality, it gets even more fluent nowadays. We see that it's not anymore a tool that it is being integrated at the very end during the development phase. It is a tool that, as at the very beginning we consider the user requirements or a specific problem or an innovation space to explore, at the same time, it's another dimension that we should, let's say, understand and seek, and what are the potential and the capabilities that specific AI technologies can give us. And of course, AI is integrated into broader ecosystems, and in my opinion, what we're living now is just, let's say, the earlier days of what is coming for the quantum AI perspective, that apart from the technical challenges that there are on the hardware level, I mean, already quantum AI algorithms are already in place, of course. But again, for the user, this would mean that more or less the outcomes would be based on probabilities. They were not specific, let's say, or deterministic answers, but they are probabilities that the user needs to be trained to decide upon for the next action. So human-computer interaction is an interdisciplinary field for those that they are not, let's say, familiar with. And it is influenced by computer science, by psychology, by sociology, by humanities in general, and lately, of course, more still from legal and ethical aspects, and try to give this kind of answers. Okay, so to understand the communication between the user and the system, and to understand to what extent the outcomes are satisfying, if you want inclusive, if you want responsible, in order for the user to stay engaged. So in this, just to position it a bit, to shed a bit light on the context where HCI and designing for the human experience more or less rely on, it's between the people, the data, the context, which is of course super important, and the technology per se. Just for the sake of time, I will just go a bit faster for that. Here I try to present some highlights of comparison of how HI used to be and how it's being transformed. So in principle, I'm quite certain that we're all familiar about usability. Okay, we're checking the usability of the system, and usability, it's okay. There are many models and the way that you can approach it, but in principle, you want to see if users interact in the system the way that you would expect that they will interact. So if the mental models that they create for specific actions that they take are actually aligning with the majority of the users that you're building a system for. Now we're talking that we need to revamp, let's say, the processes in order to be able to accommodate the new mental models and to keep having this cognitive clarity that success interactions flows, let's say, would follow. We need to educate users of how the algorithmic rationale works, depending on the situation always. Always it's depending on the intent and the context that we have at hand, or even adaptation and personalization, which is always been, let's say, in the center of attention and always trying to understand users and either based on specific behavior patterns or building user models, inclusive user models or models that they might investigate specific cognitive human factors. But most of the times what happens at the background. Now, this personalization needs to be visible. The user needs to know where, let's say, information comes from and why is it relevant and personal, let's say, to them. Then the user it's not a passive, let's say, consumer of information, but shapes up information in the flow. So every single action might trigger a different path for an algorithm to work and to bring a result back. And then I would like to imagine it as a long-term relationship between the two, that they both learn as they go ahead and in order to achieve, let's say, an optimum result. So continuous feedback, error prevention or error handling, it's something that it is being considered early enough. And of course, we saw a bit what that means on an algorithmic level, but the question is, how does it look like on an interface level? What is the information? What is the message that's being communicated? We talked earlier in the morning about a number of counterfacts and explanations. Which out of these 7 would work for expert users? Which ones for non-expert users? For users that in a specific role or in a different role? So you see that's a huge variation. It's a very complex problem to approach. One of the influences that current times and this dynamicity has is to the core of how do we create these the systems, okay, that they might embed also AI at the core. So instead of having this sequential approach where we're exploring a space, we're discovering some challenges, some wishes of the users before we go ahead and we apply some design guidelines to create the prototypes and to develop, we are moving on to a multidimensional approach that time and context is super relevant. So you have the data at hand, you have the AI capability potential, let's say, as one or as a parallel dimension, then you have the UX principles, let's say, at the core. At the second, just a glimpse of how these designs are being created. Traditionally, we have a designer, a UX expert that would take, let's say, the user requirements, all the analysis that followed earlier, and then would use specialized tools like Figma, for example, to create a specific number of design options. Now, what we're talking about is that the designer would need to tune the computational logic that exists, so to tune the parameters, the weights, let's say, that in the end would be able to generate multiples, hundreds of designs, and in a world that let's say continuous measurement is the key, and by various channels, would be able to understand which ones would survive in the end. Okay, so in a data-driven world. So just to give you an example of how would we design, let's say, for trust, and because as we also mentioned earlier in the previous presentations, if a user loses trust with the system, the question is how you can reestablish it, if ever you will reestablish it. And therefore, 3 highlight levels of detail, let's say, that we could let's say, consider towards this trustworthy AI design would be the transparency, the progressive disclosure, and the explainability that we could have. And just to give you an example, so in the step one, you would have simply to let users know that AI is being used. Okay, so this is super important. It's not a traditional system, therefore. And having, therefore, a number of companies that they want to ship specific products following a specific channel, either air freight or truck to regional national markets with specific cost attached to it always on specific date. Then we ask from the AI to suggest, let's say, and see if what we have decided as a path to follow is the correct one or not. And we see for the first one, for example, that considering weather conditions, time efficiency, budget, suggests that instead of the fresh pick market to follow the air freight, let's say, approach to local markets, they would use the truck to local markets, right? So it suggests an alternative path in a specific way. This is just awareness. From then on, the user might want to dive even more deeper, okay? So we need to disclose a bit more information how this decision actually has been given to them. And the way that we can see that is that if we deep dive to the decision, we can see, of course, the confidence of the recommendations, which model has been used, the data, and even if we want to see more, we can see also the data set that it has been utilized in order to bring up this decision. And finally, if we want to show how relevant is this information to the user, okay, so why this recommendation has been given to them, we see that there is, so the weather conditions are not, let's say, ideal, and therefore, with a specific confidence, the system decides that due to the probability that there are going to be, let's say, a hurricane at a specific point in time, that it will be within the delivery, let's say, time frame of the goods, the system offers a different alternative path to the user for them to follow. So this is how, therefore, what we were discussing earlier this morning could be shown to the user as an example always, okay? So the context, the intent, the complexity of the application might offer different, let's say, design interaction principles, but all those are defined to the detail, to the pixel detail. And there are many, of course, guidelines. In SAP, you have the sub-FARI guidelines as one of set of guidelines, where all the space of an explanation, for example, is being defined to the detail in order to apply later on the visual language and deliver it to the user. So, and let me now jump quickly to, I know that I see hungry faces, so let me lighten up a bit the situation. And so some years ago, we developed with Dimitris and colleagues from SAP, we wanted to develop the digital me concept. And that was an agent-based solution that was running a decentralized network and was imitating human behaviors, more particularly personality traits, and then was returning best fit recommendations. Actually, what you can see here is a specific, let's say, pattern of how user travel, how an agent, travels into the network in order to be able to identify, let's say, friends and build a neighborhood in order to ask for a specific recommendations. And the big question there is, all this happened at the back end. So how this actually reaches to the user? When Danos talks to the user, how disruptive it can be, how much information it reveals, and it has been applied into various applications. One of it is it's a work app, which is an application that facilitates the career orientation development of Generation Z, imitating, let's say, a socially inspired app. And we used TikTok interaction paradigms and community building also practices, and then an agent, so the Danos agent talks to the user based on collective knowledge, and the user profile of the user returns personalized results. And all this is good and fascinating, okay? But throughout this journey, always receiving questions about, okay, that's nice, but what happens? How does the algorithm creates the scheduling, the agent creates the scheduling to go to the network. How does it travel to the various layers of the network? How does it make, what does friendship mean? What does neighborhood mean, okay, for recommendations? And especially for non-expert users, this is not an easy answer. And that's why we decided to create a publication that we would use the power of the visual language and the storytelling to shed some light to this invisible world. So this is a long journey. That was a 3 years plus journey. Okay, we don't have time to go into detail for that. But just to give you a glimpse, for example, of how could we draw an algorithm. Okay, so in order to draw an algorithm, so just a simple algorithm as a neighborhood recommendation algorithm to answer a question, where should I celebrate my birthday? We needed to go through a whole different process. And this is the power of interdisciplinarity, because for this work we had designers, we had artists, we have AI experts, we had human-computer interaction experts, computer science experts, security and network experts. And then at the beginning we needed to create the characters. You know very well, for those especially that are closer to graphic novels, anyway we are in a comic, let's say, sort of city with strong the feeling of comic reading in Brussels. So we needed to understand what the character would be. How do we design an agent? Should they look like a human being or not? Or what the facial expression will be? How would it differ from the other characters? So all this is a journey that it took many sort of iterations. Then how do we reflect a network? What is a private network? What is a public network? What are specific, let's say, secret spaces that nobody would have access in order to maintain privacy and exchange information? So all this is, again, some challenges that, coupled with some storytelling, is super important, as you know, how you will write your story, how you're going to express what you want to express, the language that you use, the tone. We were referring to non-experts. And in the end, okay, this is the final result. I don't want to spoil it for you. Okay, the book is out if you're interested to read. But this is more or less how an agent acts in the background and to find the friends and pick in the end what were similar friends in order to consider them for making a specific rating for some items. Then, by that time, we had around 30 pages, and we were very lucky to collaborate with Springer. Allow me to say co-innovate in this project, because also for Springer it was the first time that they were going into much depth and publishing a more or less illustrated edition of a book. So we decided to extend a bit the scope and try to see what would be the highlight touch points in this human AI journey. Therefore, we touched upon 12 different points, specialized scientific topics that they relate to ethics, to personalization, to privacy, to networks, that all at some point make some meaning in our story, of course, until the agent gives this answer to Ada, which is the protagonist, about which restaurant should go for her birthday. And the book, therefore, has 3 dimensions. The first one is the algorithmic dimension, where it works. The second is the discussion that we had for the various touch points that you saw earlier, the scientific touch points. We used validate, of course, scientific research, but in a simple language to make the point and transfer the message. For example, why user profiling is important, why you should reveal your data or not, what is the risk, etc. And then it was the ADA that it was talking more or less to the agent to get forward with her request. So this book, therefore, can be consumed either from the first part, which is academic graphic novel, and then at the end of each deep dive visual story, someone could go and get more insights from experts, or could be consumed as standalone chapters. The general paradigm that we followed, we just wrote down the research, the description that we had, and then we had to translate it into dialogues. Then to apply the visual setting, then we had the paper and pencil drawing, the digitization of it, and then in the end, the coloring and the dialogue. So that was more or less. And just I want to highlight a bit something that troubled us a lot. So what is the visual setting? Right? So where all this takes place at the end of the day, okay? So because you only have text, you can imagine what can be, as a background. But when you have a graphic novel, so where is this place? Is it take place in Brussels? Is it in Germany? So where? And we decided that depending on which characters they were talking in these break stories, to try to combine our memories, where we first came, let's say, accustomed with the terms, and then our brilliant designer, Devasri, would combine our memories to create these new, let's say, visual settings as experiences. So those experiences, they blend different experience from our past. All right, so last thing, and important, we had to be inclusive. It was the times that the regulations, EU regulation changed, so every single image should have a alt text description, alt text 3 in this case. It was also the first time that Springer goes into that depth. And we had to describe every single sort of panel and page of what it's being reflected. And in the end, we have an outcome that you can find also available, and happy also to receive your feedback and discuss further. Before I close, I know that yes, we have the lunch. I just wanted to highlight this to stress emphasis on this collaboration between industry and academia, to present, let's say, explainable and trust in a different way of what happens in the invisible worlds of algorithms to non-experts, for example, and to try and use this interdisciplinarity and the visual perspective, let's say, of it, in order to make our technology, our algorithms more relevant. Yeah, that's it, I think. Thank you.
Thank you, Panagiotis. Okay, I think we're all hungry, but maybe one question, if there is a burning question. Okay.
Don't ask me about the price, okay? So,
yeah, that's what I want to ask. I'm just Springer charging for the book.
I don't know, Springer, how much does it? Is it? Ah, very good. You see, real-time response. This is. You hardcover 120. Yeah, but there is.
But that's weird formatting, so I don't know if you can get the comic book on its own.
On its own, you can download the chapter and you can have it as a PDF, but as a hard copy, it's close to 700 pages. You get the deep dives as well. Yeah.
Okay, good. We have lunch now, so thank you, Panagiotis.
Good afternoon, everyone. You can all hear me. Can the people online wave at me to say they can hear me? Okay, I guess they waved. Good afternoon, everyone, and welcome to the third session of today, Shaping Responsible AI, Europe's Global Position on Responsible AI. I'm Rob Heijman. I work on a day-to-day basis on responsible AI as a coordinator of the Flemish Knowledge Center Data and Society, part of the Flemish AI program. But that's all you're going to hear from me today, because I'm going to be moderating this panel, and we'll start off with Milena Malaga. She has about 20 minutes to tell us about a European strategy on AI, and then we'll talk with the other panelists who all get about 5 minutes. Go ahead.
Thank you a lot. I suppose everybody can hear me. Good afternoon. Thank you a lot for the invitation, and thank you for having me here. I'm Milena Mahawa. I'm a legal and policy officer in the European AI office. And today I would like briefly to touch upon the European AI strategy. But maybe before I would start, let me briefly introduce you to the European AI office. Our mission is to support and serve the European AI ecosystem in many ways. We would support with fostering the excellence in the AI to make European AI competitive, but at the same time we are implementing the AI Act to help the European community to comply so we can have a trustworthy AI. European AI office consists of 5 units. Let me briefly run through them. The first one, Excellence in AI and Robotics, which supports and funds the AI research and innovation, including the AI factories. A2 unit, AI Regulation and Compliance, which I am part of, is responsible for the legal implementation of the AI Act and enforcement in the EU. A3, AI Safety, it's a newly established unit. It consists purely from the technical experts, which are recruited from outside of the EU institutions. It focuses on the technological aspects of the AI safety, and will probably collaborate very closely with the future scientific panel. And we also cooperate with other AI safety institutes worldwide. A4, AI Innovation and Policy Coordination, which coordinates the implementation of the AI-related policies, and A5, AI for Societal Good, which would design and implement the international engagement of the AI Office in the AI for Good. But enough of this introduction. Let's get back to the topic I was asked to present. I believe we can all agree that we are undergoing a very decisive moment for the future of the AI technology. AI is not a distant concept anymore, but it's embedded in our healthcare, in our financial markets, in critical infrastructure and daily life. And European Union has made a clear and deliberate choice. We will not be a passive observer in this technological revolution, but nor we will also allow the innovation to unfold without the clear ethical and democratic guardrails. Europe is determined to shape the future of the AI in a way that reflects our values. But let me tell you, it's not an easy task, given the current global AI landscape. Around the world, the race to deploy AI technologies is accelerating, and not always with the same commitment to responsibility and transparency. We are facing a lot of external pressure. Some global players see Europe's responsible approach to AI as a constraint. Just last week, following the adoption of the fines on Apple and Meta for violating antitrust rules, some voices from the other side of the ocean urged Europe to reconsider its approach, to delay, to cut, or even to abandon development of one of our deliverables, which is the General-Purpose AI Code of Practice. That would require the stricter standards on transparency, risk mitigation, and respect for intellectual property in the field of AI. Against this background, it becomes even more important for the Europe to stay the course and to continue shaping the future where innovation and responsibility go hand in hand. At the AI Action Summit, Paris, this year, our president expressed, "The time has come for us to formulate a vision of where we want AI to take us, as a society and as a humanity. And then we need to act and accelerate Europe in getting there." If I had to describe the European AI strategy in one sentence, I would say, it's about the AI that is safe, but at the same time competitive. Why safe? Because Europe has consistently adopted a human-centric and rights-driven approach. Europe's approach is rooted in our own political philosophy, the belief that technology must serve the people and not the way around. And why competitive? Because we observe the global race for AI. AI is no longer just a competitive advantage. It's a necessity to be competitive and to close the innovation gap. We believe that EU has a unique set of strengths that position us for a leadership in AI. We have a top talent and we have a world-class public supercomputers. So how to make AI safe? By building the trust in the citizens. And how to do this? We propose to bring trust through the regulation. This is why the AI Act was adopted, a first binding worldwide horizontal regulation on AI. It sets a one single regulatory framework across all 27 member states. It adopts, as you may know, a risk-based approach. So certain AI systems are high risk because they pose particular risks to fundamental rights, to health, or to safety. And these high-risk AI systems, they will be subject to specific requirements, as well as the certification processes. But let me underline, around 85% of all AI systems remain unregulated under the AI Act, because no important risk was identified. So I talked about how to make AI safe, and now how to make AI competitive. Earlier this month, the European Commission launched the AI Continent Action Plan. The goal is to accelerate the innovation capabilities and the application of the AI across the EU. How to do it? We propose 5 pillars. Under the first pillar, we want to build a large-scale AI data and computing infrastructure. We'll establish a network of AI factories, which will support the EU AI startups, industry, and researchers in developing AI models and applications. 13 factories, AI factories, has already been established in Finland, Italy, Spain, Luxembourg, Sweden, Germany, Greece, France, Slovenia, Poland, Austria, Bulgaria, and Netherlands. What's more, we will help to set up the AI gigafactories, facilities which will be equipped with approximately 100,000 state-of-the-art AI chips, 4 times more than the current AI factories. AI gigafactories will be established through a public-private partnership. And in this regard, our president announced the launch of the Invest AI facility with a view to mobilizing around 20 billion euro investment in the AI infrastructure, targeting up to 5 AI gigafactories across the Union. In the framework of such a public-private partnership, EU and member states would contribute direct grants in line with the state aid rules, while private entities would be responsible for financing the remaining amount, with the possibility of de-risking the investment through the Invest AI facility. And let me be very straightforward. These facilities are essential for Europe to compete globally and maintain its strategic autonomy in scientific progress and critical industrial sectors. That was the first pillar, quite a lot about it. Second pillar, we want to increase the access to large and high quality data. We will publish a proposal for the data union strategy and data labs, which will bring together data volumes from different AI factories. Under a third pillar, we want to foster the AI adoption in strategic EU sectors. And why? Because according to Eurostat, in 2024, only 13.5% of EU enterprises with 10 or more employees used AI technologies in their daily business. So our strategy, the Apply AI strategy, will focus on 12 strategic sectors, including pharmaceuticals, energy, environment, telecom, mobility, defense, cybersecurity, science, and public sector. The first talks with the stakeholders has already taken place. Our goal is for each strategic sector to identify policy areas and concrete deliverables that we would like to achieve by the end of the Commission's mandate. Next pillar, fourth pillar, we want to strengthen the AI skills and talent because our competitive strength lies in people. We want to enlarge the EU's pool of AI specialists through the international and European recruitment of AI experts and researchers. And last but not least, fifth pillar, we want to explain and, where possible, also simplify the regulatory landscape. The priority for us is to ensure that AI Act is workable and rules are clear and easy to apply. For example, this month, we launched a consultation where we asked the stakeholders to explain the challenges in the AI Act implementation and how the Commission and Member States can support stakeholders better. The results may actually feed into the package on simplification of digital files, which would be planned for the end of this year. Apart from the consultation, we are launching also AI Service Desk. This desk will be a central information hub on the AI Act. This will go beyond a mere provision of the informations on the website. We would like to allow stakeholders to ask for help and to receive tailor-made answers in return. Additionally, we would also provide very easy explanations on the AI Act. For example, some decision trees to guide the stakeholders in the assessment if an AI system is in the scope of the AI Act because of being a high risk, or also easy to navigate repository of good practices. The desk should be operational from the 2nd of August this year when the rules on the general purpose AI models start to apply. So all these actions that I just explained, they do form the European AI strategy. And this strategy is rooted in a clear vision. We are pushing for the AI excellence, but having in mind that it will be embraced only when people trust AI. And none of these efforts would be possible without the strong foundation of the research in Europe. And this brings me to the final point. I would like to very deeply extend my gratitude to the European research community for your effort, your tireless effort, to advance our understanding of the positive aspects and negative aspects of the AI. I strongly believe that your work is crucial for the success of the European AI strategy. And I thank you for your work, and I thank you for your attention today.
Thank you, Milena. If you want to go and have a seat, you're more than welcome. In the meantime, I invite Yves Moreau, who is going to talk about a challenging balance I think we need to find now that the EU is also looking more into investments towards dual use or defense purposes in the Horizon program. It will wait just a second. Ah, it's already there. I'm not waiting any seconds, and I give the word to Yves.
Yeah. All right. So indeed, I want to raise urgent concerns on a matter that I think will affect all of us. Well, it's already affecting all of us, in fact. It's the matter of dual-use research and military research in the Horizon program. And I'm very strongly fearing that we are about to feed into an AI arms race. So many of you will have seen the Slaughterbot video that was organized by Stuart Russell, famous computer scientist in the US. It's 2017. It's about this swarm of drones that go around and kill people. This was maybe science fiction in 2017. This is pretty much the reality today. So this is from the Ukrainian battlefield, or at least the line behind. These are Ukrainian engineers using off-the-shelf components, basically stuff that you can buy for a couple $1,000 over the internet, to build a drone that can track, here's somebody on a motorcycle, okay? Swarms of drones, it's all happening right now, either on the battlefield in Ukraine, on Gaza, it's really happening. Now, a question for all scientists is, what do you want your contribution and the contribution of your colleagues to be in these kind of developments? And Horizon Europe is a major piece of R&D in Europe. It's 13 billion euros per year, and it's very clear. It's written on the web page. It has an exclusive focus on civil application. It's baked in. But the reality, unfortunately, is more complicated. So, of course, for AI, the question of dual use is maybe even more complicated than for other fields. You can argue that, well, everything is dual use. You can always use AI in any possible way. I'd like to bring a concept from my own area, biotechnology. That's a concept of dual use research of concern. That's where you have good reason to believe that the research that you're looking at may, in the near future, contribute to significant risk or significant harm. Okay, so I think that's a very concrete definition of, okay, why do we need to worry? Because yes, everything is dual use, nothing is dual use, but some dual use really matters. And I'm going to give a very concrete example. This is an EU project that actually has a partner still today at UC Louvain, called the Multispin AI project. It's on spintronics, so a new electronics-like technology to develop a low-power, fast coprocessor for applications at the edge. Well, you translate that, for me, it was, okay, what about drones? What kind of drones? Can be also self-driving cars, but it can also be drones. Okay, and when you read the website of the project, there's even a nice section about the ethics of the project and how, for example, we're going to reduce carbon emissions. And then you realize that actually, this was raised by students at UC Louvain, that one of the partners, a startup company, just graduating from a boot camp program of the Ministry of Defense in Israel. Later, I figured out that actually the core partner at UC Louvain had been in a European Defence Fund project on the same technology, so that the partners cannot say, well, we didn't know what the technology could be used for. I think it was pretty clear that the partners had knowledge of the kind of application the technology could be used for. I was very surprised when UC Louvain said that, well, this project went through ethical review and there was no concern raised. I mean, I can understand that you make a balance and decide that on balance you would choose to approve the project. I cannot understand that you would say there was no ethical issue. So I wrote to the commission that didn't want to answer, and then I went through freedom of information and obtained documents, lots of that completely censored, but enough information to figure out that, well, yes, there is a process. This ethics review process at the EU Commission is ethics washing. It is useless. Okay? And when it stands in the way, they change the rules. So, for example, the matter of exclusive focus on civilian application has been moved out of the ethical review. Okay? So now, yeah, the reviewers review what they're supposed to review, but they don't have to review the stuff that matters anymore. And we're about to go even much further. The exclusive focus, it's proposed by the Commission that we just get rid of it, and that we embrace dual use as inevitable by exploiting dual use both ways. So tomorrow you have to worry about whether you want to contribute dual use research, drone research that can be used to drive weapons, whether your colleagues down the hallway will do the same, and whether you want that to happen at our university. I'll stand my own personal position, which is that universities are not the right place to do this kind of research. I come from a Flemish university with a very strong tradition of pacifist setting following World War I. And because of that, I think that this is how we should keep things. We should keep this exclusive focus on civilian application, and universities and networks of universities should push back against this. Thank you very much for your attention.
Thank you, Yves, for this very clear call to action. I think we're all very aligned here. I already know, because Sabine de Meij is going to say, that we also require responsible AI if we want to create value. Sabine, go ahead.
Thank you. I will keep my slides or presentation or intro to the panel short, because most of you were here also this morning when I was talking about responsible AI, trustworthy AI in the Flanders AI Research program. But just for the people who jumped in, Flanders AI Research program is part of the Flanders AI plan, a Flemish funded program with the aim of successful adoption of AI with different components, supporting research implementation, also skills training, ethical and legal aspects. And in the research program, and while I'm repeating it here, because it could be a blueprint also how at the European scale we can work and should work together, bring together critical mass of researchers from different universities, from different research centers to work on one program book. We do it in Flanders. Europe is a bit a larger scale, but who knows? And we can also do it like that. And we also work with verticals applications in different in different fields, a bit similar to the let's say the verticals that are now promoted also in the Apply AI and the Gen AI for Europe policy plan. The question on how does that the successful adoption of AI linked to responsible AI, the question of innovation and regulation and trustworthy AI, aren't they in conflict? Certainly not, and that's what the stake I take, because, and it is very much in line with the first speaker, so it is our responsibility to use AI to create value, to create a sustainable future, and that's at economic scale. It's not only at environmental scale. That's what I mainly want to mention. It's not only about sustainability when it comes to energy consumption also, but our sustainable future, our future is also only sustainable if also our economy is sustainable. So we have to also invest in that, but also societal, looking at improving our health. And by the way, these are in fact the 3 domains that you see in the sustainable development goals. So it's our responsibility to use AI to create value, and very similar to what was mentioned in the first talk, this is also only possible, that value creation and the successful adoption of AI, if people trust AI. If people do not trust AI, they're not going to use it, we're not going to create any value there. But trust, as I mentioned this morning, is a very subtle thing. It's a very, you can't grasp it, you can't define when people trust you, but at least you need trustworthy AI and, of course, the responsible AI of the responsible use and development of AI. You can define trustworthy AI, and that's also what the European Commission has done with ethics guidelines. Also, other topics at European policy related to that, and there's a guidelines, I was co-authoring that, on the responsible use of generative AI in research, which we are also following. The other topic I wanted to mention was also already mentioned by the first speaker, the continent plan, which is in fact a very nice initiative from the European Commission, bringing together some initiatives that were already talked about for some time, but they are now, let's say, very well structured in this AI action plan. And I also think there, and we are engaged into that, and also the responsible AI topic is there, both from the innovation part as also the rules part, and as we probably will discuss further in the panel, I do not think that these are in contradiction, because my point is, if you look at these things, tell me which one would you kick out? Is there anything that you want an AI system not to have? And let's have the rest of the discussion during the panel. Thank you.
Thank you. Okay, so we already have a lot of questions to think about. What direction do we want to go into with regards to dual use? Should we kick out any requirements for trustworthy AI? I hope not, but we'll see about that. Now we have another question. Will the European Digital Omnibus run over responsible AI? Another fundamental question by Gregory Levkovich. Gregory, the floor is yours.
Thank you very much. Thank you for having me, and thank you also to Milena to have set the floor for this discussion regarding the European strategy. And what I would like to bring in the discussion is a feeling, I mean with some arguments, of course, but a feeling that we don't really have a European strategy. We are more having something that is more stochastic, in the sense that the strategy is changing so much that we don't know where to go anymore. So we know that the European Union and the Commission is thinking about having a digital omnibus that will try to simplify GDPR, try to simplify maybe the AI Act, or at least have a kind of check whether the rules are too complex, etc. And it was very clear in the original strategy that we have two very important aspects: trustworthy AI, and on the other hand, we'll need to have an AI ecosystem that is competitive. That was also your presentation, but you can see that no, there is something that is complex and is engraved in the approach of the Commission, is that on the one hand you say we want to address the safety issue through regulation, that's the safety aspect of the strategy, and on the other hand you have we need to be competitive, and inside this part of the strategy they say we need to have lower or simplified rules that we want to implement. That means that we have completely integrated in the approach that innovation and growth are to a certain extent antinomical. So I would like just to remember you some of the evolution of the last month, basically. If you look at the AI continent strategy and you just try to search, of course it's just statistics, but how many times you have fundamental rights inside this document? You have 2 mentions. Then if you look at the previous strategy that were there, we had the Communication AI for Europe, 2018, 14 mentions of fundamental rights. White Paper on AI, 2020, 25 mention of fundamental rights. So fundamental rights looks like the part that we want to put a little bit under the carpet, changing the focus from protecting fundamental rights to safety. And safety is less than protection against violation of fundamental rights. So this is for the AI continent. So before that, we had the AI liability directive that was abandoned in February 2025. So of course, there is no responsible AI without liability, but we decided to not go forward for this one. Then there is the code of practice for general purpose AI, and the last version that was published in March was really criticized, including by the co-legislator, the member of the parliament, and the Ministry of Spain that was in the negotiation, saying that basically they were abandoning fundamental rights and KPI inside this document. Continue a little bit. In March 2025, it was this idea that the Commission was looking at the different technical standards that we are waiting for, because technical standards plays a very important role in the implementation of the Act. And it seems that there is still a lot of aspect to fix, and also that we have not enough experts that are involved. Of course, most of them are not paid. That's maybe an explanation for that. But the thing is that the original strategy to say, okay, we will have the Act in order to protect not only health and safety, that is something we do for any kind of product, but health, safety, and fundamental rights, this dimension is fading away. And my concern here is more that we are going from trustworthy AI, including these three aspects, so safety, of course, health, protection of health, but also protection of fundamental rights, to something that is more and more just only AI safety, that is not always integrating fundamental rights. And then if you look at what they are discussing in London, maybe not even AI safety, but maybe only AI security. So this is my concern about the AI strategy. So, and I really, I hope that finally the digital omnibus will not go in that direction, because I think if we want to create a path for the European Union and for the protection of the values of the European Union, we should continuously consider fundamental rights as the core values of the European Union. Thank you very much.
I can hardly follow because we're going much quicker than my timer allows, which is great as panel moderator. Benoit Frenet is next. Implementing the AI Act, is it a mission impossible? We went from optimistic, I think, to slowly more critical, starting with Yves. But stay with us, okay? We'll turn it around.
Okay, perfect. Hi everyone. So I take just a few minutes, slightly in line with the previous speech, to talk about two challenges ahead of, well, implementing the AI Act. So first, maybe let's go back to the definition. So if you look at Article 3 in the AI Act, we define a general purpose AI model as something that will significantly generalize, that will perform a wide range of distinct tasks, and that will be integrated in a variety of downstream systems or applications. Now we also talk about high impact capabilities for systems that match or exceed the capabilities of the most advanced general purpose AI models. And this is where we meet the last speaker. We also talk about systemic risk. So what is a systemic risk? A systemic risk is specific to high impact capability, to general purpose AI model with high impact capabilities that will have a significant impact on the Union and foreseeable negative effect on public health, safety, public security, fundamental rights, or the society as a whole. Now, let's say you are developing a company and you may ask, okay, how do I know that I face systemic risk? There is an answer, of course, in the AI Act, Article 51, that says, okay, there are two possibilities. There is a systemic risk if, doesn't work on the screen, sorry. If, you have some high impact capabilities based on indicators and benchmark, or based on a decision by the Commission. So we'll go back to that. But the thing is that there is also another rule and many people have been talking about it, which says that an AI system is presumed to have high impact capabilities, hence systematic risk, if the amount of computational power used to train the system was over, well, let's say somewhat arbitrary number there, so 10 to the power 25 flops. Okay. But if you go back to the criteria that will be used by the Commission, they are much more expensive. So we can use the amount of computation, so C, but also number of parameters, size of the data set, modalities. You can use benchmark, but you can also take care about how many people will be impacted by the model. So there is some kind of discrepancy between definition 2 here, that is only based on the amount of computational power, and the kind of criteria that the Commission may actually use in practice, which is somehow good news also. A second challenge, I believe, is that we'll need to educate people with respect to IA. For example, if you look at Article 4, it says that providers and developers of AI systems will need to train the staff, to give them IA literacy. I mean, as a university, we need to comply with that. We will use AI systems for education, for HR, for whatever, meaning that we need to train people. And to be honest, we don't really know. I don't know in other universities, but in my university, it will be challenging to train everyone with respect to IA. So one of the solutions that we have in my university, for example, is that we will give a course on IA to all the students. So all students in third year, whatever their background is, they will get AI training, meaning that in a few years, if we hire someone for our university, we know for sure that is somehow trained in IA. Another problem is with respect to the enforcement of the AI Act. There are several pathways, depending on how you see it. So you can see high-risk systems with respect to the domains, to the sensitive domains they apply to, or with respect to the sectorial regulation. If we go by the domain, we'll have in each state 2 new entities that will be there to enforce the AI Act. And if we go by sectorial regulation, we will actually rely on the already existing entities, and there are 12 of them in each state. We have 27 states. Do the math. We will need to educate people in hundreds of entities. And I mean, they will be expert in law aspects, but also technical aspects. So it will be really, really challenging. And I strongly believe that actually AI research has a major role to play with that respect by helping people. So we need to design systems that are trustworthy, that offer guarantees, that are adapted to non-expert users. I mean, you cannot expect a lawyer to be a real expert in IA from a technical point of view. That's not his job. That's normal. And they should also be easy to audit. So transparent, but we should offer ways for non-experts to check that our system is performing correctly. Okay. Thank you.
Thank you very much. Then we go to our last speaker, who is going to talk about the benefits of having a CERN-like program for AI in Europe, as opposed to, what was the other?
The Manhattan Project.
The Manhattan Project, of course. So we're already balancing a little bit back, looking at the way we should go to Peter Libre. The word is with you.
Thank you. Yes, so I will be talking about, So I will be talking about that we need a CERN and not a Manhattan Project. And if I'm talking about that, what I do mean is in the context of artificial general intelligence. And of course, it's a big word, so let's also define it properly. Is it flickering?
It's a bit jittery. Try to relieve the
Yes. Okay, yes. Thank you. So basically what I mean with that is automating human capabilities, intellectual capabilities. There is some debate on the exact definition. There are many definitions out there, but you can consider that on an average human being or the upper bound of human intelligence, for example. And this idea is, of course, not new. It's at the Dartmouth workshop, where the field of AI was actually started. This idea was already proposed. There was already the idea to build a machine to simulate any feature of intelligence. So this is not new. And before I start, I want to put this disclaimer. This talk is not about any predictions on AGI, because first of all, there are many people that are willing to do that, so you don't need me for that. And I think there is also many reasons to think that this might be the case, but there are also many reasons to think that this will not immediately happen. What I will discuss is concentration of control in corporate hands, which I think is concerning. The political dynamics that are shaping this potential advanced AI techniques, and the danger of treating these developments as a zero-sum game between geopolitical nations. And when will we get AGI? I promise you that I will not make any predictions, but I will show you some predictions of others. For example, Shane Legg, who co-founded DeepMind in 2010, he thinks that AGI is likely to emerge by 2028. He makes this likely with a probability of 0.5, so there is some contextualization there, but still. And of course, we also know Sam Altman, the CEO of OpenAI. And he thinks that we will get there also soon, 2030, 31. Depends a bit on which kind of interview he's giving, the statements he's making. And he's making the prediction here with huge error bars. That is, of course, also quite convenient when making predictions, but this is interesting to see. And you might say, yes, this is all interesting, but these are these are clearly AI scientists or related to AI science, but on the other hand, they're also related to big companies. And these companies have an advantage of hyping up AGI and these technologies that go behind it. So we might be concerned, or we might just take this with a grain of salt when we interpret this kind of statements. On the other hand, we also have people like Geoffrey Hinton, who recently got his medal. And these are people that indeed co-founded the field of deep learning, co-invented these technologies that underlie this. And he, for example, predicts or estimates that this will happen in 20 years. More recently, also, Demis Hassabis from DeepMind also recently obtained a Nobel Prize for his research, for his impressive research in AI, and he also anticipates that this could happen quite soon. Again, I'm not saying that we should believe or just trust anything that a Nobel Prize winner says, but if these people say something, I will at least listen to what they say. So, are we aiming for AGI? The same as I said before, don't trust me on that, but just look at the websites of these big AI companies. The website of OpenAI is stating this. So they're aiming for that directly. They're also putting safe there, but it remains to be seen how this is even concilable. Another thing is Google DeepMind. They want to build AI for humanity. Here they're not saying immediately AGI, but if you read a bit further on the sub-paragraph, there is also the statement of AGI. So again, a direct statement that this is their aim. Same thing for Meta. More recently, they're also aiming for this. So this indicates that there is indeed this concentration of control in these big AI companies, which is, to me, quite concerning. Again, not making any predictions here, but the fact that these are putting this on their websites is something that should concern us all, in my opinion. Is there a potential impact of AGI? Well, there is the good. We should be able to tackle complex problems. We should be able to advance automation, perhaps even complete. That's what some people are saying. We could enhance human capabilities. That's, of course, a good thing. But there is also bad things, like social disruptions, misalignment with humanity's goals, which is concerning. And the ugly, then, there is this existential risk that we should also consider. I think that many AI researchers at least acknowledge that this risk is at least to be considered. And then we can ask ourselves the question, if these risks are so severe, is this something that we want to pursue? And many of the good things are also happening, for example, in the FAIR program, but in a trustworthy way. So the direction in which we steer AI research will be very important in the years to come. And therefore, I think it's very important to have safety before capabilities. Invest in safety, invest in trustworthiness. But this is not something that is, for example, happening in the US at this time, where President Trump and his administration presented a big investment in the Stargate project. And moreover, it's not necessarily guaranteed that these big investments will allow them to keep their forefront in this race. If we see new models that are supposedly built with a less more limited budget are also achieving high performance and high capabilities. And this is exactly why I say we need a CERN and not a Manhattan Project, no arms race. We want to avoid an arms race. This is the Peace Summit in Moscow. It was July 1991. And this really started this demilitarization. And of course, this was a good thing. And I think we should indeed think of AI in a similar way, move towards global treaties, consider this at the UN level, and make a distinction between AI and these very advanced types of AI, because in my opinion, these are very different things. Thank you.
Right, then I would like to first thank all the panel members and also invite them back to the front for our interactive part. I also want to thank them because this is a panel where you don't need a moderator. You're doing so well in time management and having very punchy presentations within time that this is a great panel to preside. So please take a seat and be ready for my questions. I'll start with a maximum of 3 questions, and then we can move on towards questions from the audience. But let's first recap while everyone prepares. We had a nice overview of what the AI strategy, the EU AI strategy is, of course. We then looked at, let's say, the limitations of how trustworthy AI is operationalized within Horizon 2020 programs and the work we can do there. Then we got even a bit more critical and said, well, we should also worry about policy documents referring to fundamental rights because the number it is mentioned is diminishing. It's only 2, so that means the next iteration will have to go to 1 or 1.5 fundamentals or something like that, if you want to count it. Yeah, and then we went to how can we actually define systemic risk, and that this isn't that clear yet. And we had Peter now ending with, why is everyone so focused on creating the end of the world or something super dangerous? Shouldn't we start working on something more trustworthy and interesting for society? Good. I prepared some questions. Let's go there. I'm going to skip the first one, and I want to start with the second one because it's a main theme. I had 3 questions in mind. And the question is how to align Europe's commitment to responsible AI with the current push towards defense-related research. Eve, I'm really interested in what you think. It's not only the Horizon program, we also get other programs now and a lot of opportunities for people within AI. So I'm really curious what you think.
All right. So first of all, is it working? Yeah. I want to
talk about military sovereignty, so that's one dimension. What do people in Europe, both citizens and governments, think that we should deploy in terms of military capabilities? Personally, if you ask me, we should have weapons. We should not totally rely on weapons coming from the United States for defense, for example. We have a very active military sector. You'd be surprised how many weapons are produced in Europe. It's a very active sector across Europe, including in Belgium. My concern is, well, what kind of weapons do we want? I mean, the weapons that we have already are pretty horrible. What kind of weapons will we have today if we spend our time inventing new weapons? I mean, do you want me to go back to my lab and develop weapons that can target, biological weapons that can target people by ethnicity? Do you want me to use AI to develop new chemicals that are more lethal than whatever nerve agents we have today? I don't think so. I don't want to do this. But I think at the same time, for me, the core focus is research, dual-use research, military research. Currently, there is a fund, European Defence Fund, that is for research, R&D towards new weapon technology. It exists. You can participate if you want to, depending a little bit on the regulations at your university. I fear that the reason that there is this grab on Horizon funding is, at least it's a speculation of mine, is that the European countries do not want to invest more in the European Defence Fund. And if you were able to grab 10% of Horizon funding for dual-use research, that would be a big benefit to the military industry in Europe. I'm an academic. I think that universities have a mission to share knowledge across the world for peaceful purposes. And for that reason, I don't think that we should be involved in this kind of research. So maybe what I want to project last is I'm not naive. You know, I'm not a naive pacifist who just wants to be happy in his lab and doesn't realize what's happening outside in the world. Like everybody here, I do sometimes wake up in the morning worrying about the fact that I live so close to Brussels and NATO, and there is a nuclear bomb that falls in Europe, well, the first one will be in this direction. That's the life we have to live in. So I don't think that claiming that universities are not the right place to do this research and worrying what this research could bring us, whether we really need those more advanced weapons, I don't think this is the same as saying, oh, we just want to sit back in a chair and wait for whatever happens.
Great. Is there someone else from the panel who wants to add something to this question or to what Yves was saying? Anything? Peter, I'm looking a little bit to you because you don't want a Manhattan project but a CERN project. Do you have anything to add to dual use?
Yeah, I think that the concerns of Yves are very relevant. And indeed, I think we all have the responsibility to make sure that our research is not used in contexts where we're not behind. So I think indeed this is something that we should address, and maybe already at the start when we request funding, and that it is clear where this funding will be used for, and if there is an escalation to such technologies, this should indeed be supported by the researchers that came up with these technologies. Yeah.
Okay, great. I think this is also a great bridge towards my third question. That question is, how do you deal with the traditionally perceived tension between innovation and regulation? From Yves' talk, I remember that the check we are using for Horizon 2020 programs isn't working that well, so there is no barrier at all between innovation and regulation. But I want to ask this question again to my panel. How do you deal with this traditionally perceived or even experienced tension between innovation and regulation? What are your thoughts, Milena?
I think, can you hear me? Well,
yeah.
Okay. I think generally there is a bit of a misunderstanding that the regulation stifles innovation. Outside of the AI Act and outside of the AI ecosystem, maybe just one example, DG Comp recently, they produced a report on how competition rules actually sort of contribute to the innovation on the market. So I think it's a highly good piece of work, and I would encourage you to take a look if someone is interested in this topic. But coming back on the AI Act side, I don't see that this piece of regulation stifles innovation because of a certain mechanism that are in the AI Act. Because of the high standards or higher benchmarks, I would not see here the reason. The only reason how I would see how the regulation can stifle innovation is because the business does not understand the rules. And there is uncertainty how to apply the rules. There's uncertainty how to move forward, how to detangle this spaghetti sometimes of the regulations that we do have. We are really meeting a lot of stakeholders, and we are listening to them complaining. For example, they ask for guidance. If the AI system would be considered as a high-risk system, it's not clear to them. They are concerned that the specific sectors can be over-regulated, and they feel uncertainty how the AI Act would fit into this regulatory spaghetti. They also ask for clarity on the value chain responsibilities. This is all not clear, and this may have a bit of a stifling innovation effect. And compliance industry is also not quite helpful in this case, because they can also create or identify a bit of this uncertainty. And that's why we really try to explain and have, as a commission, as the AI office, and have a bit of an initiatives to bring the regulation closer, starting from the AI Act service desk. A lot of guidelines, a lot of deliverables, a lot of also code of practice drafted by the independent experts with the support of the commission. I think generally, if we bring closer the regulation to the business, and would explain, this would not have a chilling effect, and it would not provide so much confusion and stifle innovation. And that would be my reply.
Thank you. I'm pretty sure there were other panelists who wanted to answer the apparent tension between regulation and innovation. You want to go first? Yeah, okay.
Yeah. Maybe I would like to go back a few years ago when we deployed the GDPR. There was somehow similar discussion whether it would impact the businesses. And what I witnessed is in research, it really created new fields of research. I mean, XAA did not exist really before the GDPR. I never worked with lawyers before the GDPR. And after the GDPR, well, I've refocused on XAI, published with lawyers, and I really think it wouldn't have happened before the GDPR. So I think that the new regulation may actually be a good thing for Europe, in the sense that it will bring new ideas in research, new challenges that we need to address, and it may give an advantage to EU. Because we will need to address those challenges, and we will create new ideas, new techniques. I mean, for example, differential privacy did not exist before the GDPR. There are plenty of things that did not exist before that, and I somehow believe it will be the same with the AI Act.
Great. So regulation can also create new forms of innovation and research. Good, and you can pass the mic to the left.
Okay. Yeah, let me a bit reformulate what I presented during my talk. I think if you will look in a few years, what will be the most successful AI systems, that will be the ones that will be trusted by people and will be technically safe and fair and bias-free and transparent. So I will restate my comment also, that the innovation and the trustworthiness are going hand in hand. I also would like to make the comparison with the medical devices. For instance, there you have a bit of the same discussion whether all those medical regulations are they harmful for the industry. And I know I've been there, having medically certified your system. It's really a huge pile of work and documents. But if you look at it, if you're a patient, you don't want to be in a scanner that is not certified. Same holds in fact for an AI system. I think we owe that to our systems, to our citizens and people, that we make systems that do not harm them. And yeah, so restating that these things go hand in hand. But, and that was already mentioned, at this moment, if you look at it from a business or industry point of view, there is really a lot of unclarity and uncertainty, and that really has to be cleared out. The standards are being made, but they are being delayed and so on for various reasons. But yeah, once this is going through, I do think we will find a way in which we can be both innovative and trustworthy.
We still need to untangle the spaghetti.
Yes, thank you. I would like to say, I mean, there is different way to look at this question, very, very different ways. Because one is to say, okay, because innovation is the new name for progress. But in progress, you have the idea of the goal. In innovation, not. So there you have fundamental values that can be fundamental rights that play a role, because innovation does not make any sense. So that is one layer that for me is very important, is the direction. Because innovation, I don't care about having a fork that can help me to pick better on my plate with AI inside. It's innovation maybe, but it's not necessarily progress. There is a second aspect that is, I think it's connected to competition, and there we should use rules also to protect our industry, because what we don't have is a lot of AI. I mean, on the market, we are not leading the market on AI, but we are leading the market on a lot of other copyrighted materials, for instance. And there maybe at some point it makes sense to protect the market a little bit and to protect the what we have already, for instance, by changing the directive on copyright in order to not let all this data used for training models that we do not get any benefits out of. And there is a third meaning that is more common, as the regulatory aspect of it is when you have market failure. And you need regulation when you have market failure. We know that really well. It's the problem with medical device. It's the problem with IT in general for a long time. You don't know for software. You don't know if the software is safe or not, and you do not have a lot of regulation on that. That's why you have a lot of very bad software, and I would say cybersecurity risk is the fact that we do not take care of this market failure about software. So no, with AI, this is still software, but it's taking over for decision, prediction, etc. And there I think it's really important, because otherwise it's not the problem of cybersecurity, it's the problem of democracy.
Wow, great. Then I do think we need to ask the third question. It was in some of the presentations, the US is steering a different course, diminishing all types of safeguards towards none. It impacts us because almost all of our backends are still built on American technology. If it's not American, it might also be Chinese, which is not always that much better in terms of autonomy or sovereignty, which leads me to the third question. What are we going to do? Gregory already mentioned it with the second reason why we need regulation, because we want to protect our own markets. How do we create a European market and infrastructure that becomes more independent from the US or other foreign regimes that might not be trusted with everything in their backends? Who wants to go first? You don't need to solve it entirely, but if you can offer a few interesting perspectives for the audience, that will be more than great.
All right, so I think the recent example of the fines on Meta, for example, and their clamoring European overregulation is a good example. That we really need to worry about that. I don't know how we're going to solve that problem, because cloud infrastructure, it's not just AI, it goes down to cloud infrastructure, basic software, all of that is a problem. But if we see what lack of regulation is doing and will do in the near future, because it starts from IT, but now it's also about water and every single form of regulation. So those clamoring about over-regulation, basically what they want is remove any obstacles for their businesses to make more money and not caring about long-term consequences. So I think that the regulation, to pick up on the previous question, is a way to preserve a certain worldview that we are able to project from Europe. I think we should see that the more they complain, the more it shows that it is somewhat useful. And I think that GDPR, for example, is one of the best examples of EU soft power in the last 20 years. People elsewhere in the world have asked for better privacy protection because of what the EU has done. So I think that holding our grounds on the AI Act and all the other regulations can help us project a worldview and have people elsewhere in the world also demand the same kind of rights that we will give to our citizens. But of course, if we don't have any infrastructure to support that, it's kind of silly. It's kind of silly when my university is all Microsoft based, and probably several other universities as well, where I have to go on Teams for my calls, and I don't like it, so I use Zoom, which is no better. Yeah, we are really in a terrible situation. But yeah, let's move forward. But I guess these AI centers that are being built may be part of the solution.
We can start with a small change by disabling the Teams channel now. And then we'll see from there. No. Yes, and PowerPoints. Benoit, other suggestions? Or you're just holding, okay, you're just holding the mic. Then we have Sabine.
Well, I think part of the solution may be in the way you ended your question, Rob. You don't have to solve it completely now. And I think that's also how we need to approach it in Europe. Let's take it step by step. You don't need to be immediately completely independent of others. And I do have a collaborative mindset in any way. So I do really favor collaboration, but of course you need to be with two to collaborate. And if there's no second party, you can't collaborate. But going back to the step by step, let's start by building up in Europe our competences, our infrastructures, our knowledge, so that we can become more and more resilient. So in case things happen, that we do not completely rely on others, but step by step we can do it ourselves, and at least we can faster recover in case anything happens. Start doing it step by step, and I think the AI Continent Plan with investing in infrastructure and so will certainly help. But also not only in, let's say, the large factories, gigafactories with supercomputer and power and so on, but also the more energy efficient topics are super important. And again, linking it to the other question on defense maybe, but in general, it's not unrealistic to think that at some point we will get damage to our energy infrastructure or to our data infrastructure. So building up the knowledge and the systems that are energy efficient, data efficient, are also very will come in handy at some point for sure.
Okay, thank you. Yes.
On this question, I personally, but do not quote me, personally, I am very much happy that this discussion is taking place. And before the digital infrastructure, the same discussion was happening with the energy infrastructure. That's why we had a certain acts like Critical Raw Materials Act or Net Zero Industry Act, which would help the business and to build, for example, power plant. But coming back to digital infrastructure, I have to tell you, I was very much, when I was preparing for this speech, I was very much surprised when I, for example, read how long does it take to obtain the permit to set up a data center. It's 48 months. And one more time, do not quote me, please, but this is crazy. And we're not gonna get an European infrastructure if we have so much of a burden for the investors. That's why here the Commission would try to somehow streamline this
the way we did with, for example, net zero technologies, to streamline this, for example, permit granting processes, to just create the space for I would say friendly investment in which is actually European. So that's on my side.
Okay, I do want to quote you on the 48, but I will not, I promise.
I know this you can, but the opinion that is crazy, please do not.
No, just the facts. Just the fact. Yeah, hold the mic. It means we can have some final questions from the audience. I see Tom already. Who else has a question? Tom can go first, then you can go. And if we still have time, we will definitely come to your question. Introduce yourself really shortly.
So Tom Leenaerts, ULB, VUB, FARI, and so on. And everything else. It's another question, and I would like to pick everybody's brain on this topic, open access. On the one hand, open access is very good for science. People can test what other people are doing, they can investigate this, they can actually improve this, they can add on top of this. It's all very nice. For instance, also in our research, we are more or less forced to publish everything in open way, to share our code so it's verifiable, so people can reproduce our results, which are all very good things. But if you do this with everybody else in the world, you actually are giving everything away. Because the thing I always hear is like, yeah, we are also very good in AI in Europe, but nobody can show that we were because everybody's giving everything away to companies in the US and they just take what we do and they build on it, right? And then, for instance, companies like DeepMind, they build Alphamycins, right, Eve? And they refuse to disclose the code because it could be that somebody's going to build lethal agents that can destroy the world. And they are allowed to do that, and they get published in Nature. So I really would like to have your opinion about what the standpoint of Europe should be. Should we be a bit more protective about our IP? Or should we just keep on playing the same game we've been playing all along? What is your opinion about that?
Right, whoever wants to go first to partly solve this really big question, go ahead.
You don't have to solve it now.
I will not solve it, that's for sure, but I think it's also important that we care about the values that we have. I think, personally, science without having it open and reproducible, that is not science in my opinion. So is there a way to do science and keeping it all closed up? I'm not sure. Maybe we should use also some of our leverage to motivate the same kind of behavior in other countries. Like, for example, using techniques like OpenAI, where we have no idea how they are built. Is that ethical? And can we do something to kind of force that, maybe through legal ways, for example? Yeah.
Good.
I will maybe add on that. Well, if you take the example of OpenAI or closed AI, I don't know how to call it. I mean, when they released GPT-4, they made a scientific paper about it, which clearly said we will not disclose any details about the model, the data, or anything related to it for, well, competitive reasons. And now, as researchers, we are reduced to guessing as for the environmental impact, the biases, or whatever question we might ask about these models. So at least for systems that have systemic risk, if we go back to the AI Act, I don't think it's a question. I think we need to make them open and auditable and etc.
Yeah, so Tom, I agree on the tension. I think that we should strive to be as open as possible. I think when we talk about human data, there are very complicated tensions there. When we talk about data about patients, can't solve that in 2 minutes. When we talk about publishing, I think the community should take a stand. I'm a culprit of being on papers that are not sufficiently disclosed when working with pharma industry, for example, because that's the only way we could get something published. So there is a tension there, but maybe as a reviewer, as an editor, you should stand your ground and say, well, we're not going to publish that, even if it sounds cool. I think in terms of the industry, for me, the bottlenecks are a bit different. They are in terms of having a very lively industry. They are cultural in terms of risk-taking. I mean, I'm at the university that is really quite active and where there is really quite good culture, meaning that we are the university with one of the strongest transfer in the world. Okay, so it is possible, it can be done. And the other big thing I see is the scale up. You cannot just go around and say, I need 100 million, I need 1 billion for a software company, for example. There is a big bottleneck, I think, in scale up in Europe. That is something that would need to be addressed at the European level. So I think that our industry could be stronger if we address these two levels of culture. You know, in Silicon Valley, it's okay to fail once, it's okay to fail twice. Here, it's okay to fail zero. That's part of the culture. So I think addressing the culture and addressing the scaling up could make a significant difference.
Well, I like, Tom, that you said we don't have to solve it. So I will return with another question, because I've been thinking about that for a long time also. But my reflection or my question is, why or how does AI differ with the other technologies? So for other technologies, there is a system and a market that works and so on, and not everything is open. So why would we think that for AI this would work differently? So I don't know if anybody else or you could reflect on it, but so that might help us to solve the question. If you know what is the difference, and why not just apply what holds for other technology?
You can answer during the break. Can we have 5 more minutes before the break? Because I think we should get the 2-second questions as well. Do you still want to answer this question, Gregory?
We can have.
You will do it during the coffee in FARI. Okay, then we go for this question. Yeah,
yes.
It's working.
My name is Luis. I'm a student at VUB, joined PhD. And my question is more for Peter, but everyone can answer. It's about CERN and more like what would be the first step? Because to make such an international effort, you would need to have some leverage to bring everyone else, right? What would be that leverage? That's my question. What would be the first step to make a CERN not a Manhattan?
Yes, that's a very good question. And I think maybe the first steps already taken. In a very recent interview by Demis Hassabis, he was actually calling for setting up such an institute. And I think that this might very well initiate. But I think from an academic perspective, actually many universities are in favor of such an institute for then working on very advanced AI technologies. So I think there in the AI academic community, for sure, there is this willingness to start setting something like this up.
If I may, I will not give an answer, but rather a question. My personal question is, how do we achieve that, knowing that in the case of the CERN, the goal was, well, not always the same for all research teams, but they were very similar. In IA, we all do different things. We work on different domains with different techniques, different technologies, different beliefs, whatever. How do we unite all of that? That's my question.
Yeah, that's a very good question. I think when I'm talking about CERN versus Manhattan, I think about these models that are really at the highest risk, and I think the amount of different directions are maybe less diverse. But indeed, I think for all high-risk projects, such a community would be very valuable to have. Yeah.
So I'm a physicist.
Sorry, wait.
So I'm Godwin. I'm at the VUB. So I used to be a physicist. So at CERN, it's not necessarily true that the focus of the research is unilateral. There's different focus. The whole essence of CERN is that one institute cannot pay for the infrastructure. So they came together, put money together so they could build the infrastructure. They have data and everybody does what they want with the data. So the focus can be different. So in this AI collaboration thing, like the CERN-like kind of thing, we need a GPU cluster. I think institute can come together, build such massive infrastructure that they can all use, but the focus is also different.
Yes, I agree. Also, security-wise,
also security.
this is something that I think is very difficult to organize in many different institutes or universities or companies. So having this in a centralized way could also be a valuable contribution, I think. Yeah.
Okay, good. Then we go to the final question of this panel.
Hi, can everyone hear me? Yes, okay, great. Libre, PhD candidate at UC Louvain in sociology, so bear with me, my question is a bit long, but it's important. Without being too negative, but sticking to fact, we can see there's a rise around the globe and within the European Union of the extreme right political wing. We see a lot of misinformation being spread, notably with deepfakes, and we see science being under attack. Being social sciences with the insult of being woke, or even the IPCC recommendation for climate change, I have the impression here today that there is an elephant in the room that has not been addressed, and that is we cannot continue to talk about AI developments, the technology alone in its bubble, without linking it to all the social, economical, political, and cultural spheres. The trust people have in the political institutions today and democracy in the European Union are slowly eroding, actually not slowly, actually fast, and not addressing safety, trustworthiness, and 1,000 other aspects in the AI Act in those technological advancements can push this tendency even further. My question then will be, can we think about today about achieving responsible AI or AI for common good without some sort of democratic processes that educates and makes citizens and people governed by these AI systems participate and reflect on what society really needs? Thank you.
Thank you for your elaborate, well, it's a short question with a long introduction, so thank you for that, but there is a question and a really important one at that too. Who wants to answer first? I think it's a bit related to Article 4 and AI literacy anyway, Benoit, but if you don't want to go first. Or you're still percolating, which could be a thing.
I'm always, I don't know. The problem is that on the first hand, I would agree with you that people need to have a say on what we're doing, what's going on, in what direction we're going. But on the other hand, the problem is that IA is very different in that there is a very strong technical core in IA. And if you don't have a minimum amount of technical knowledge about what IA is, well, you just talk bullshit. I mean, you tell about Terminator, killing machines or whatever, and the real danger is not that. It's not existentialism. It's having the freedom taken away, like you said. So I think first, indeed, we need to educate all the people. The first step is IA literacy. If there is not, if you don't have a minimum amount of IA literacy in Europe, well, public debate is impossible, and even more, I would say, dangerous, because you will have leading voices that are experts in IA with strong opinions that are maybe not aligned with what we can do, what we should do. But that's my view.
I personally think that some of us as scientists have to engage with society very, deeply, quite visibly, be in the newspaper, not just to report about our fantastic technical progress, but address a socially relevant question. Attack, for example, mass surveillance, sometimes be critical and sometimes be self-critical. I think there is a delicate balance to find, but for example, trying to streamline a uniform discourse does not build trust. Having a little bit of chaos in the discussion, having a bit of disagreement, and being able to project that when you take a position, you're doing from a position of good faith, and having the visibility for that can help. I mean, some of us are trying, but it needs to be a lot more. How do you get the people to believe that science is working for them? I mean, people don't want big pharma to make lots of money, but people want the latest cancer treatment when they get cancer. It's hard to bring that together into a coherent wall. it's going to take time and effort, but I think that by engaging with the public, you know, going around, I go and, you know, like many of my colleagues, talk to 60-plus-year-old all across the country. I think that's an important public service, and being engaged on social media, not spend all your whole time, but finding this balance and showing that you approach the public from a position of good faith and transparency. I think it can help.
Only a short message to share a very positive experience we had, and Rob knows because he was also there. We were collaborating with the Flanders AI Research program, the Knowledge Center Date of Society. We spent a full day in a citizen panel. So we were discussing our use cases with 8 tables of 8 people or something like that. And I was very positively surprised, and it's a bit in contrast with what you're saying. You don't need AI knowledge to have a good discussion on what AI means and what the applications are, because you talk from what people really want, and then it's of course up to then the researchers to translate it in what this technically means. But hearing what people want and what they find important, you can have that discussion. We had a very good experience on that.
I would be delighted to finish on this very happy note. Also because it mentions us. No, jokingly aside, you really need a break because you are expected back here at 4 very special quick sessions. I forgot the name, but I wanted to... Yeah, you are going to do really quick sessions and connecting for responsible AI, and that's really important because the need has been shown in this panel. I want to thank this very critical audience, but also our presenters who did a really great job for staying within time and presenting really original thoughts. Thank you.
that many of you still for the last session, Connecting for Responsible AI, showcasing project idea and research expertise. So the idea was really to foster networking among members of the Belgium 3 AI research programs, explore opportunities, but also to hear many different examples from a lot of researchers of responsible also AI development and projects. So to start, we will have Axel. This one? Yeah, all right. We will have Axel Abels to talk about wisdom from diversity bias mitigation through hybrid human LLM crowds. He's from the Université Libre de Bruxelles. So the floor is yours. Everybody has 5 minutes. Yep. And view. Oops, sorry. There you go.
Thank you. Hi. Yeah, so as said, I'm from the ULB, also from the VUB AI lab. And to introduce some of the work we've been doing on wisdom of the crowd, I'll take you to an experiment we did. First with humans, and I'll show what happens if you replace the humans with LLMs. So the experiment is this. We have a bunch of headlines, so 240, that contrast outcomes for different sensitive groups. For example, here, women prisoners more likely to assault staff than male inmates. And then within the 240 headlines, we also had the opposite headline, in a sense. So instead of women prisoners, we had men prisoners more likely to assault staff. And so if you have these headlines, you can then ask, we had headlines related to age, gender, and ethnicity. So if you have those headlines, you can then present them to human participants and ask them whether they believe these headlines to be true. And give an opinion on those. And so if I plot the accuracy of the individuals, we can see that on average, so this diamond is the average of all our human participants, they are barely better than random. There is quite a big spread, but yeah, on average, barely better than random. Second thing we can look at on top of the accuracy is what I'll call here delta accuracy, which is basically the difference in accuracy between complementary demographic groups. And so by that, I mean the difference in accuracy for example, this headline. This is a headline that reports a negative outcome for men. And delta accuracy measures whether people are more likely to believe this headline rather than headlines that would report a negative outcome for women. And the same for the other demographic dimensions. So I can plot again the accuracy against now this delta accuracy. For now, there's not much more to say about this. But to build on this, what my work mostly focuses on is wisdom of the crowd. So what happens when instead of having just one participant, I have a group of participants, then we would like to aggregate different participants to get better decisions. So typically, you might do a majority vote. Majority vote can be quite limiting because you treat everyone the same. And so instead of the majority vote here, I'll focus on this method we proposed, the expertise tree, which assigns more weight to individuals dependent on how strongly they perform in the different categories. So if I have a headline related to gender, I might assign more weight to this first individual, basically no weight to the second, and then a bit of weight to the third. Right, so we're tailoring the weights to the headline type we encounter. And so if I look at the performance of these human crowds, now I get much stronger accuracy compared to just individual humans, and also a reduction in this delta accuracy, which suggests that we have a bit of decreased bias. Now that's nice with humans. Then the next question we ask, okay, well, what happened if those humans would ask LLMs for the answer to provide to the survey? And so we can look, okay, what happens if you ask different LLMs for their opinion on these headlines? So we had the major providers, OpenAI, Gemini, and some others. And we can look first at the individual LLMs. So there's quite a spread in accuracy. The strongest model here is GPT-4o. This is Cloud Sonnet. And again, there's quite a big spread But in general, I mean, all of these models are better than the average human. So if I take a human, I would be better off just taking an LLM, asking the same question in terms of accuracy. In terms of this delta accuracy, it's not quite the case. So we found that these LLMs tend to be more biased in the sense that than the individual humans. And the hypothesis there is that by being trained on this big corpus of data, they're just reproducing the biases they observe. So that's the individual LLMs. We can again ask, okay, what happens if I take a group of LLMs and aggregate them? Do I get them better performance? The intuition here with humans, we had much increased performance. Since the LLMs are better than humans, we should get much better performance again, and this is not really the case. So the LLMs are in general not much, the LLMs are stronger, but the aggregate of LLMs is weaker than an aggregate of humans. And so to explain this, we looked at diversity. So this is essentially correlation. So this shows that there is a high correlation between LLMs, and in contrast, humans are very much less correlated. Here, similarly with the TSNE visualization, you can see that all the LLMs are clustered here in the middle, whereas all the humans are clustered around. And so this suggests that LLM lack diversity, and so there's no diversity that we can exploit when aggregating the human crowds. So then to finish, we looked at hybrid crowds. So since humans are diverse, LLMs are more accurate. Can we combine both to obtain better crowds? And the answer is yes. So by taking a crowd of LLMs and humans, we improve accuracy and we decrease this delta accuracy, so which suggests that we are less biased. That's it.
Thanks, Axel, and to also be on time. Alexandra Calvi could not be here today, so it is my pleasure to re-welcome Benoît Freinet on stage to talk about when sign languages meet AI, interplay between societal needs and fundamental research. So give me a second. Oh, it's okay.
If you don't mind.
Yeah.
It's updated.
If it's updated, then.
Sorry.
No problem.
Yep. Thank you. Yep. Okay. Perfect. So, hi again, everyone. So we'll be talking about a project which is, well, I really find interesting and impactful. So, oh, sorry. Yeah. Okay, I will stay close to the mic. So I will talk today about sign language recognition. Actually, there are two teams involved in that project. So the first part of the project is in the computer science faculty. So there is my team, human machine learning team, with teams for others like Anthony Cleve and Bruno Numa, who are experts in databases and HCI. And we currently have 4 PhD students working on the topic at UNamur, Jérôme Fink, Pierre Poitier, Ariel Basso, and Adeline Couplet. But more interestingly, there is a second team involved, a team of experts in sign language. So they are not computer scientists, they are real linguistic experts in sign language. And probably they did the most important job, which was, well, starting research on sign language and collecting data and annotating data. To give an idea, they work on for years to annotate the data, and we only have a few hours of annotated data. So it's a very long, tedious process that requires expertise. So really, we are thankful to them. So why is it interesting? First, because there is no unique sign language in the world. There are many sign languages, and usually they were born in very or in specific contexts. Like, for example, if I remember, the French-speaking sign language was born near Brussels, but it's very different from the French-speaking language spoken in France, for example, which is mixed with the American one. So we have very different sign languages. They all use hands and the face, But otherwise, they are very different. I mean, you can do the same sign in different language and have a different meaning. The data are scarce. We have among the largest data set in the world, but still we don't have enough data to learn very large model. It's multimodal. Data are heavy. We are talking about videos that are very easy to manipulate. The annotation requires high expertise, and it's very difficult to attract funding because we don't generate any money. We do it for the community, so we don't get any money out of it. That's not the goal. And, well, it's difficult to tell the Walloon region that we will generate money with it. But we have a real impact on the deaf community. It's a step towards a more inclusive society. We have real challenges in terms of IA, and it allows us to attract also brilliant researchers. So, for example, let's take the task of isolated sign recognition. We need to recognize a single occurrence of a sign in a video. This will be used, for example, to create a dictionary for people that learn sign language. First, we will not work on the raw video. We will first transform the video into a sequence of skeleton. So that's the first step, because taking the video is way too heavy and too difficult. And this raises challenges. So, for example, how do we learn sign representation? Because we have very little annotation, so we need to use, for example, contrastive learning strategies. Also, it's not so easy to find the tokens in the videos. It's like spoken language. You have transition between tokens. It's really hard to do that, and most models are not suitable to that. So we are designing new models, new architectures to enforce, for example, constraints, duration constraints. So it's not so easy to augment sign language. I mean, it's not like single image where you just change the color of the image. You have to rely on much more complex strategies. So we can publish, we can do research, but still we create tools for the community. For example, we created a sign language dictionary. You sign in front of the webcam and you get access to videos where the sign is used, a bit like Lingui, if you know it. It's the Lingui for sign language. So created that 2 or 3 years ago. We have the other way around. We have a tool to show how a specific written word is translated. And it allows us also to grow the data sets, because the data sets are very scarce and they were created in very limited conditions. So now we are able to get data from the community and to enlarge the data sets to create more tools. So I would stop. So really what I would like to focus on is that it's both challenging and rewarding. It feels good to do this kind of research, really. There is a tangible impact for the society. Still, it remains hard to fund. I'm still trying to find a way to fund in a permanent way this kind of research, and it's really not easy. So if you have ideas, please share. Still, we can publish. So we have published in top conferences and journals and etc. And we will have the first PhD defense related to IA for LSFB on June 17th. So if you're interested, reach out, or we can just discuss about LSFB. It's fascinating. Thank you.
All right. Now it is my pleasure to welcome on stage Antonios Kontaxakis for Optimization for Sustainable Development of AI Applications. All right, and you should be good to go.
Thank you. Hello everyone, my name is Antonios Kontaxakis and I will present our work with ULB, UPC and Athena. This is a collaborative work with Dimitris Zacharidis, Alberto Abello, Sergi Nadal and Alkis Simidis. So we talk a lot about responsible AI, and I think in this same bubble we also have a sustainability, sustainable development, right? We have an increasing trend, and as all of you know, AI is becoming every day is becoming more popular. Let's see some numbers. So AI, the money spent on developing AI applications started from an 80 billion money on 2021, and with ChatGPT becoming ever more popular, this number has now grown in 3 years, 3 times already, and is projected to go even higher. If we go to AI adoption, like this is a survey saying how many companies have at least one function in their stack that is using AI to function. It could be the HR, it could be any. It's growing from 56% to being 72%. So pretty much every company is going to have some type of AI application inside. And if we also look at GitHub, that the projects that you get that use AI in GitHub used to be in the top 5 most growing trends. Now, by 2023, is the fastest growing trend. That projects that are using AI, that are using AI inside. And Python is now in GitHub the most popular languages, surpassing JavaScript. So, how we are developing AI application and why that we think it's not a really sustainable way is that we have these trial and errors that you describe your application, you run it, and then you see is the result good, is the result bad, and then you make some changes into your application, you change some hyperparameters, some pre-processing of the model you are using, and then you run it again. Was that good, was that bad? And that was done mostly by humans. And humans didn't like this iteration a lot, and in terms of how many experiments they will generate until you get a good result was 10 to the 100, right? But now this process starts to get automated, so you get automation hyperparameters, you had automate generation of solutions, and that has really increased the workload. Like a machine will generate you thousands of different solutions, that all of them you have to go through this trial and error. Are they good, are they bad? And then you have a feedback loop to train a model to tell you the next set of experiments to run. And when it comes to why that is not sustainable and why it costs a lot, there was a really nice survey from Google 10 years ago why this iterative process is highly costly. It's the hidden cost of machine learning that generated the whole field of MLOps. And it talks about operational cost. It talks about maintaining all the systems that you are building, all the experiments you are running. And I will say, from what I've read in my PhD and all the new, we haven't done a lot of work on making this better. Still, we rely on this trial and error and how we manage our experiments and the information we create. It's not been better. And there is a report also for Microsoft on the same notion, that they also say about the automation part, that a lot of these processes are now automated, increasing the circle of trial and error to optimize models. So we sit down and thought, how can we actually make this better? And we drove into techniques that can minimize this cost and make it easier for development of this kind of applications. And we turn an eyes on database community optimization. And of course, we have all the goodies that we can use here, which is materialization and reuse and equivalencies, where you have to keep track of things that you are not recomputing. And we also identify another goal, which is when you are using AI to generate, or any type of traditional model or AI to generate solutions, not everything that you are generated should be executed. So your trial and error process, when it's not really controlled by an expert, it doesn't provide you any value to execute everything that you are generating. And we do that by, so our results are quite promising. This is from our paper in ICD. When we are exploiting these techniques, we can get a 20 speed up. And when we have automation, when we have, for example, genetic search here, we can reach 20x and 4x speed up. And when we are using Bayesian search to do the automation of hyperparameter tuning, we get a 10x. So thank you all. I didn't have enough time. for this, but thank you.
I will leave it a few seconds so you can maybe take a picture of the QR codes. Yeah. Thank you. So keep also your little paper to write your burning questions, and you can have time at the end to ask all the questions you wanted. All right. So Yves, the floor is yours.
Thanks. So this is more really networking because I'm looking for people in the grand scheme of things. I'm thinking a lot about how to develop a more ethical culture in technology, in particular digital technology and AI, and how we should educate our students. So there is really one big idea, that is that of course we need ethics, of course we need regulation, but this will only work if the cultural foundation, the value system that underlies it is strong enough. And honestly, I think that in digital technology, IT, and AI, we are really one of the fields that's probably the worst position. We have no culture whatsoever, no understanding of the impact that we have on other people through our work. So I think we should develop this culture, and that requires many fields. It's not just ethics and law, it's also social sciences, sociology, technology studies, political science, economics, and I don't mean business, I mean understanding, for example, how money works, for example. I think it's very enlightening. Psychology, epistemology, really building a culture. Now, you cannot write a curriculum just like that for this, I think. It would be hard. But there is a goal. Okay, if we have a program, maybe we'd have a part of the program that would cover some of these topics, not everything. We're still training engineers in my case, but we would want our students to learn to reflect critically on their technological practices and their impact on society. But every program has different needs, has different space in the program. It's very hard to find just for 3 credits. It's a battle that you have to fight to get 3 credits somewhere. Every lecturer wants to teach their own course. They don't want to get somebody's course and have to teach the course of someone else. I think, and in my experience personally, having teachers that also come from tech, from STEM, is very valuable. Of course, how do you get trained in these topics? So my idea is let's get a team of people together from all over Europe. My perspective is European, our European value system, and create a kind of super curriculum. So open access material, so that anybody can go and pick and choose to actually teach their own students. And my idea would be, in a dream world, even in engineering, 10% of the curriculum would be for non-technical topic. And again, it's not just business and IP. I mean, we're talking philosophy, sociology, and everything else. There would be also something I'm not covering. It's not at all my expertise, but of course we need to live in a sustainable world, environmentally sustainable world. That should also be a key topic, but that's not one I want to cover because that's not what I work on. It should be open, it should be the slides, it should be the text, it should be videos, and it should be good enough for tech people like me to get trained and so that they can go and teach their students, okay? Of course, you don't become a lawyer just by watching a couple of videos, but maybe you can pick and choose and create something that's your own course that you feel enabled to go and teach your students. So how would I go about that? Well, I would create a network of people both in tech backgrounds and in social science backgrounds, and ask, first of all, what would we want tech people, STEM students to know? Okay, just sit around a table for a couple of days, and what would you want someone to know about your field? What do you want to know about law, for example? For example, in law, no punishment without a law. I think that's very important, but that's probably not something that comes up on top of the list. Then identify contributors. People would be willing to do the effort, contribute the material, collect, organize, and disseminate. if you are interested, or if you know someone who's interested, if you can help me build that network, that's what I wanted to present this to you. Thank you very much.
Thank you, Yves. And now it is my pleasure, and sorry, I forgot to introduce you, to welcome Ikhtiar Nematov to talk about data attribution from conventional machine learning to LLM. And the awkward moment of waiting for me. There you go.
Hello, everybody. Hello, everybody. So I'd like to present my PhD project, which is data attribution for XAI from traditional machine learning to LLMs. My supervisor, Dimitri Saharidis, and I'm also affiliated to Aalborg University in Denmark. So first of all, what is data attribution? Imagine a normal machine learning pipeline where you have a bunch of labeled training data, and then you train a machine learning model using that data. And then you have a new point that you want to classify, and then machine learning model classifies that point. And now we want some explainability. So we ask, why? And data attribution tries to answer this question, why, by attributing this prediction to the training data, taking into account that the machine learning model is just a product of that training data. So what it does is it tries to give a score to each of the training data, which shows how much a specific training data influenced that specific prediction. So if you have, for example, in this image, you can see a dog, and machine learning classified as a dog, and now explanation would be, well, because I had this kind of dogs in my training data, you are a dog. Or a fish. Well, because I had this kind of fishes in my training data, so you're a fish. As you see, it's a very specific type of fish, which is coming with a bird or a dog in the water. However, these kind of methods are susceptible to data quality, since they are using data as their explanation. For example, this point, and by the way, the classification task was classifying dogs and fishes. When I have this kind of a point, model has to choose something because, well, that's what models does. And it chooses fish. So now the question is, why not a dog? So these kind of samples are actually class outliers, and most of the data attribution methods are susceptible to such class outliers. And in our paper, we have demonstrated the vulnerability of such methods. Another cool thing about data attribution is that they are customizable to user intent. These the scores can be negative or positive, so you can know which data points are helping the model to say it's a dog and which data points are against the model saying it's a dog. Another point is that we can use data attribution to identify bias in subgroups. Imagine this point, which was classified as a dog, but the ground truth was a fish. There's a very small fish that lady is carrying. So now the data attribution can show us in the first line, the points that are supporting the prediction that are pushing the model to say it's a dog. And then the third line are the samples that are pushing the model to say it's a fish. So we can see that model is learning some kind of a bias, and that bias is a human. In the training data, there were more samples with a human and a dog that are labeled as a dog. That's why model learned that bias. And in our paper, we have discovered this kind of multidimensional explainability using data attribution. With all being said, today we are living in the era of LLMs, which are trained in humongous text corpora from Wikipedia, blogs, and the whole internet, basically. And now, when we ask the question to ask, can we use these data attribution methods with LLMs today? And the answer is no, at least not directly. First of all, their training data is vast, which do not allow us to really track some statements from the whole text corpora. And also, the LLMs are being trained in multiple stages. They are first pre-trained to just predict the next word, then they are instruction fine-tuning, then there is preference alignment, so it's much complex than that. But today, LLMs are not being used on their own, but they are used in a pipeline called RAG, Retrieval Augmented Generation. It's when I provide an external data to give a knowledge to my model, and I ask question about that data, that specific data. That might be a medical data or some corporate data. So my model gives a response. So now I have something that resembles the previous pipeline. I have some data points that are affecting the output of the model, and I have this data. I can now use the data attribution to find which documents exactly are affecting the output of the LLM. And the questions that we can answer using data attribution in this setting is LLM using the content that I provided, or is it hallucinating, or is it using its prior knowledge? And most importantly, can we use data attribution explainability to enhance the quality of LLMs? Thank you for your attention.
Yeah, on the dot. Thank you very much. So now it is my pleasure to welcome Seduk Rashid for When Artificial Intelligence and Collective Intelligence Converge. And in the meantime, again, if you have questions, please do not hesitate to write them down. The floor is yours.
Thank you. First of all, I'm not a researcher. I'm just a citizen who's concerned about AI, and I'm here to present one topics. I'm not used of this exercise. It's really, really strange for me to be in front of you guys, all those specialists. So my concern is from the beginning of humanity, human has to share knowledge. And I think, like the French philosopher Gilles Deleuze said, we are a part of a group of a big network. And so I think that those networks are really important. And for me, there is different kind of network. By example, everybody knows about those kind of networks. Linux, it's a network. The blockchain, it's a kind of network too. Those kind of networks teach us how we can use technologies for the good of the people. Another kind of network, I think that somehow everybody knows about here. It's the power of the organization that you are all part of, European universities networks. There is also another kind of networks that I'm interested in. It's in north of Italy. They are really efficient as SMEs because they are well organized, very little SMEs. And nowadays, they implement AI to organize, to organize them in a better way. For me, European Union, it's also a network. Since theoretically, because it's in theory for the moment, subsidiarity, it's kind of an organization, and it's not think as a pyramidal institution. It could be like a living network as kind of I'm sorry. The quadruple X. I think AI for the moment it's organized around those three major environments: academia, private society, and public administration. But I think what we need for the next, for the European Union AI model, it's to bring civil society inside of it. It's how we can bring civil society inside of those AI topics. And first, what I think we need is to teach them, to bring them the skills, to bring them the skills and the knowledge to elevate the citizen debate. how can we vote for a politician who will be in the to decide? I'm sorry. How can we vote for je peux le dire, no. How can we vote for a politician who will have to decide, by example, about some topics in AI Act if citizens don't know nothing about this concern, about these topics? I'm almost finished. I think that in Europe, we already have the base of it. It's in our tradition to share knowledge. It's in our tradition since the unions, before the unions, since the communaux. We have the tradition to share and to bring goods to the people with technology. Thank you, and I'm sorry, I'm not used to it. I'm really... Wow, thank you. You're so kind. Sorry.
Thank you. Indeed, it is brave. So now it is my pleasure to welcome Apoorva to talk about artificial delegates resolve fairness issues in perpetual voting with partial turnout. So the floor is yours.
Hi, so I'm a first-year joint PhD student of ULB and BUB. I'll be talking about how we can use artificial delegates to resolve the issues in fairness in perpetual turnout with in perpetual voting with partial turnout. So let's consider an example. There is a group of friends who are trying to decide where to go for dinner. We have 3 restaurant options. Each restaurant has some kind of a feature like the cost, the ambience of the restaurant, as well as whether there are vegan options or not. And each friend has some preference over those features, based on which they create an approval set, which is basically a set of restaurants which consist of, which is basically a set of restaurants that they approve of, which then goes to perpetual voting rules, which I'll be discussing, and which leads to a collective decision. So basically, if this happens for a single time, majority voting makes sense as it satisfies most number of people. But what if we have the same scenario again and again for multiple rounds? Then the questions of representativeness and giving chance to everybody arises, for which there are a few perpetual voting rules. The first one, approval voting, is basically the option, it's majority voting, which is basically the option approved by the greatest number of voters is chosen. Then there comes perpetual quota, which basically chooses the option which ensures proportional representation. By proportional representation, I mean the voters are satisfied proportion to how much the fellow voters agree to them. Then there is perpetual fragment, in which there is the concept of load, which is related to satisfaction. The more satisfied you are, the more the load is. Then there is perpetual consensus, which is also a bit similar. It maintains a concept of weight, which determines how how influential you are in the collective decision-making process. These two are quite similar, but there is a difference in how the load is distributed. Now coming back to the problem statement, realistically speaking, it isn't possible that all are present at every time. Hence, this might be due to scheduling conflicts or limited resources, and hence there is a scenario of partial turnout or absenteeism. The question over here is, can we still make a fair and a representative collective decision? So there are a few methods that have been proposed. One is multiple imputation, where they consider the missing data, the missing absent votes as missing data, and they try to estimate a probability distribution over it. Then there is liquid democracy, where the absent voters try to find a suitable delegate to basically delegate their vote. With multiple imputation, the issue over here is it works very well when there is a large number of data, but fails when there are less number of voters. And with liquid democracy, the problem over here is that it is really hard, realistically almost hard to find suitable delegates, especially due to resource constraints. So we propose a model where we try to introduce artificial delegates, which basically learn the preferences of the agents from the previous rounds when they were present. And now I'll be discussing two evaluation metrics to see. So first is the Gini influence coefficient, which is basically it measures the degree of inequality of influence among the voters. Then there is bounded dry spell, which is basically the longest time agents' decision wasn't the collective decision. So these are the results. As we can see, on an average, partial voting is doing quite worse than a full turnout. And we can see that the orange, basically, which is the delegated scenarios, is trying to mitigate the differences in fairness over here. So we are basically in longest dry spell and in Gini influence coefficient, we are trying to minimize the values. Again, when we look at Gini influence coefficient, we can see that in approval voting, the partial turnout is doing actually better. In that, the assumption is that due to absenteeism, there is a probability that the minority vote also, the minority group also gets some influence. So, conclusion, perpetual voting is vulnerable to absenteeism. Artificial delegates mitigates effects of partial turnout on fairness and representation. We also tried a few scenarios where we tried to vary the parameters, and we can see that still artificial delegates have a better performance. There were a few limitations. First was we assumed that that there is a simple linear human decision-making process, which is based on preferences and the context. And we also considered that there is no interaction among voters, that is the preferences or the decision is purely based on the preferences of the individuals. Thank you.
All right, thank you all for being so good with time. So now it is my pleasure to welcome Manel Slocum to talk about personalized post-processing, how input data shift recommendation diversity.
Thank you. You did very well to pronounce my name. So hi everyone, thank you for staying until now. I'm going to talk about recommendation. And I am a postdoc researcher coming from Research Institute on Mathematics and Computer Science in Amsterdam, the Netherlands. And I'm bringing some diversity to the room. I'm happy about it. I'm part of the AI Meta Democracy. And the idea starts from the following. So recommender system, usually what they do, or recommendation platforms, they collect our data. Our data is what? It is preferences, which means the clicks we do on the system, and as well as other side information. The side information can be our profiles, for example, demographic information, as well as other item features, for example, if we speak about the news, the category of the news, the title, keywords, etc. So what we wanted to do, or what happens, if the recommendation platforms use our click and they optimize, this is called personalization. So they try to make us a recommendation that fits our preferences, our historical information, and then we get this recommendation, we click. The human in the loop. We click, and remember that this recommendation is generated in a personalized manner, which means based on what you watched, here we go what we recommend you. And if we do only this, what happens is that we put everyone into bubble, or the so-called over-personalization. And what happens is that we end up all in one bubble, and we don't see outside of that bubble. For example, if we take it into news, if we like sports, we only get recommendation on football, football, football. But this word is not only football, it's also election, politics, health, inflation, etc. And that's what actually we wanted to do. But first, this work is still ongoing. First thing we wanted to do, if we only take preferences, we want to see, and we give it to recommender system black box, we get recommendation and we measure accuracy, how the users are happy in an offline measures. And that's the so-called NDCG. We measure that, and then we see if instead of only giving preferences, we also give side information, the user profile plus the item features? Do we get a better recommendation? The answer is yes, and that's why you see an arrow going high for the NDCG. So, well, it means that, like how the companies are saying, always the algorithms are hungry and they want more data. But see what? This score goes high by 2%, 5%. What happens is that in addition to measuring the accuracy, we want to see the diversity. And here we use some measures that exist in literature. One of them is ILD, which is for interlist diversity. We want to see how the side information actually helps or does not help to improve the diversity as much as it does for accuracy. And we see a huge, very huge, like 10% decrease in the intralist diversity in the cost of what? Of having 2% increase of accuracy. So by the end, the platforms tend to get all our information through cookies or whatever to make us accurate recommendation that it's at the end of the day, let's say 5%, which we don't know if it will, the user will notice it, and what happens, they put us into bubbles. We do not accept this because simply we work on responsible AI and we want to diversify recommendation. We look at literature and what you can get from here besides the math, that there is lambda. Lambda is very important because it tells how much accuracy we get versus how much diversity, the balance or trade-off, let's say 50-50 or 60-40. In the platforms, what they do, they run many lambdas from 0 to 1. Until they find that cutoff point. Imagine how much harm and sustainability happens here if you take fancy deep learning algorithms and you run it and try to measure accuracy and diversity to find the threshold. And that's why we wanted to say that's not actually the right thing to do, and I'm trying to run because I don't have time. So we question the lambda and we question diversity. Because at the end, when we say diversity, we are speaking what kind of diversity? Is it diversity with respect to clicks that we make, or diversity with respect to our profile, or diversity with respect to the genre or categories of news that we consume? And for that, because we all do this in offline settings, which means we don't interact with the real users yet. So we try to run a regression model that will tell us which diversity will be for which user. So we try to find if user X needs more categories, then we try to diversify their recommendation by recommending them other categories of news. If the user needs more clicks, let's do that for them. And the lambda, actually, we ended up not having a uniform lambda that applies to all users the same, because we are not the same at the end of the day. We try to tailor lambda for each user. There are more of multi-objective optimization happening. I'm running out of time, but the nice thing, we are trying to get there. We are almost there. What happens is that when you see the ILD, you see that we bring it back high, which is something good, and with less than 0.01% decrease in accuracy if it happens. In some cases, we actually get the accuracy high and the diversity high. And this is why I would like to end up by saying we should not always say that there are trade-offs. But what we have to do is to find a way to balance and treat and maybe find the right purpose on how we want to solve the solution and not to stay the trade-off between privacy, accuracy, between privacy, fairness, etc. Yeah, thank you.
Eloquent under time constraints, so good job. All right, it is now my pleasure to welcome Thomas van Dam to talk about algorithmic confusion. And you will be with Julien Cabet. All right.
Thank you. So, usually as a law professor, I wear a tie and a suit, and here, since I'm with engineers, I don't. So I will introduce and then leave the floor to Thomas. Algorithmic confusion, and probably you already get confused about what it is about. It is about this. It's about trademarks, actually. So I'm an IP law professor in the Faculty of Law here at ULB. And actually, I study intellectual property. And one thing you have to know about trademarks, which is one type of intellectual property, it's that it can't be registered if it triggers a likelihood of confusion with a priorly registered trademark. So basically, you have to check that when you do try to apply for registering a trademark. This is by virtue of law. The likelihood of confusion test is an extremely complex test under legal standards. So here you get one case, which is a very important one from the Court of Justice, stating basically that amongst the different criteria you have to deal with in order to address the likelihood of confusion, you have to check the similarities between the signs, The similarities are going to be assessed on a visual, oral, and conceptual basis from the standpoint of the average consumer. Okay, there is a lot of case law, really a lot. So just to take one example out of millions, I ask you, do you think there is a likelihood of confusion between those two signs? Okay, probably you have different opinion. There is a likelihood of confusion according to the case I mentioned. So why I do this, why I study this, because actually the connection with AI is obvious. There are millions of trademarks that are already registered. There are millions of trademarks that are registered every year all over the world. So basically, if you want to check whether there is a likelihood of confusion when you do apply for registering a trademark, with all the millions of trademarks that are out there, it's an extremely complicated and cumbersome task. This is where artificial intelligence comes into play, in particular with figurative trademarks. What you're going to see is actually some tools functioning from different intellectual property offices. The one from the Benelux is the one you're looking at right now, and you see. So basically, you upload a trademark, and it actually provides you the different trademarks that are in the register. The functioning of these different artificial intelligence systems is the same. So you will see in the next seconds, actually, another system. Here is the one from the European Union. It's the same thing. If you are actually familiar with, and if you remember the previous results, you'll see that the results triggered are completely different. Here you see the apple. You did not see it in the previous case. Once again, here with the World Intellectual Property Office tool, still functioning the same way, you will not see the apple sign, which was considered as triggering a likelihood of confusion with the signs we upload. So there is a lot of question from a legal standpoint, how does that work? Since it is in use, it is on the market, and the question I had is that efficient? So I turned to Thomas to actually look at this from an engineering standpoint.
Okay, thank you. So, you've seen the typical use case of those systems. So we wanted to test them, right? Because of course we do not have access to the source of the models or of the applications. We cannot use the counterfactuals or any other fancy techniques. We only have access to the prompting of the systems. So we resorted to using decisions of opposition. So these are legal decisions between two trademarks. I take the pair of trademarks, I input the applicants, much like you would do if you were trying to register your own trademark. And I input it into the system, and I am looking for the opponent trademark. So this is the one that was actually used to oppose your application, say. Of course, a good system would be able to retrieve this opponent trademark very high in the results, and a bad system would not. So this is exactly the metric that we use. This is called the hit rate, and this basically is the number of times for all of our decisions that we indeed are able to retrieve the result. And these are the results of two of our experiments. In the first one, we use decisions from the European Union Intellectual Property Office, and in the bottom one, we use those from the Benelux. So these are both legally relevant. You can see the results of the hit rate. In our results, we've shown that there was actually a kind of overfitting at the UIPO because they used their own decisions to train quite badly, I would say, the models, because you're not supposed to overfit on your training data, as we all know. But still, let's disregard this result, and you can see that you can expect to find the opposing trademark, so the one that was actually in the register and opposed you, say, less than 10% of the cases. So it shows that apparently those systems are very far from functioning, which is a huge problem because, as you said, it's a necessity for legal reasons. So I will conclude on this. You have a lot of more of our findings on the page on the left, which is the page from the EPSAM project of the Juris Lab, which is situated just here. And I had the pleasure of defending my PhD thesis 1 week ago, and you can find it. It's open source. Of course, you have access on it. Please do not hesitate. Thank you very much.
Congratulations for the presentations and the PhD. So now it is my pleasure for the last presentation, Neurosymbolic AI for Social Cognition by Jos Vennekens. You're welcome on stage. No bad surprise. All right.
Thank you very much. So if you want to build AI systems that interact with people for a longer amount of time, and those AI systems should be responsible, then perhaps it makes sense for the AI systems to also be a little bit aware of the social and emotional context of conversations, for instance. And so in these 5 minutes, I want to tell you a little bit about research that we have been doing and are going to do about the topic of AI for social cognition. So first slide is just to point out that this social cognition isn't always trivial, even for people. For instance, here you see a picture, and if you would look at just the face of the woman in the picture, then perhaps based on her facial expression, you would think that this is a sad picture, that something sad is going on. However, if you don't look at just the facial expression, but you also look at the other people in the picture, the body posture, the kind of clothes that they are wearing is also a very important cue, then perhaps you would decide, no, there is actually nothing sad going on, this is actually a very happy occasion. So in order to make these kind of judgments in an accurate way, you need to take into account many different kinds of cues. It turns out that this is quite complicated. It's complicated if you want to simulate this in an AI system. It's also complicated if it happens in the human brain. And so we currently have an ongoing interdisciplinary project where some people from some neurologists are looking into how this happens in the human brain. And what we're, as computer scientists, are doing is we're trying to build artificial neural networks that model this in order to hopefully be able to match the two together to get a better understanding, not just of how you can simulate it in a computer, but also what goes on in the human brain, which also has some medical relevance because there are a number of different conditions such as autism spectrum disorder or frontotemporal dementia, which are actually characterized by things going wrong with the social cognition. So a better understanding of these phenomena is very useful also for medical practitioners. When we started to investigate this, one of the first things that we noticed is that if you want to train neural networks to do this, then you need data, and actually we couldn't find a good data set for this, so that's one of the first things that we did and that we published last year, I think, at NeurIPS, which is that we built a data set specifically for this problem. So it's a data set of slightly more than 25,000 images that have been annotated for their emotional context. And you see a graph here that you can't read, but don't worry, there's a very simple message, which is that it's a hard problem. So we just tried throwing some state-of-the-art things at it, and it turns out the state-of-the-art things don't do particularly well. So if you're interested in this kind of research, then you can download the data set for free, and perhaps if you use your own method, you will outscore these benchmarks that we had in the paper. So that is ongoing research, and we want to follow up this ongoing research by also bringing some neurosymbolic AI into the mix. Why? Well, because the eventual goal, or one of the goals that we have in building these artificial models, is that the artificial models should help us better understand what goes on inside the human brain, because that's what all of the neurologists involved in the project are interested in. And so if you just use a plain standard neural network, then you're sort of limited in what you can say about the human brain while just looking at this network. So we're hoping that by incorporating some neurosymbolic techniques, we might get a more white box model that we are able to better match to what goes on inside the human brain in order to produce some nice new insights for our medical colleagues. So that's a project that is currently starting, and we're going to be working on that for the next 4 years. So if that kind of thing piques your interest, then I would be very happy to talk to you about this further. Thank you.
All right, I think several miracles happened today. I've never seen so many sessions finishing early. So, I wanted to maybe can you re-show the names? Yes. So now is time for questions, and so, so almost there. So were there questions for some of the presentations? It was probably a lot of information all at once. Were there one question triggered at some point? Or maybe. All right. I think, yes. All right, thank you. One question here. I will give you the microphone.
Yeah, so I have a question on the optimization stuff. Yes, so if I understand, you have an AI model that is trying to suggest the next optimal hyperparameter for your model.
Yes.
And then you compare your technique to something like a Bayesian optimization.
No. What we did was there are existing techniques that use Bayesian models to recommend the next iterations, or you use genetic search to do the next iteration. If you go down, what we do, it's down. Again. Yep. There. Nope. Back. There. So if you see there, the second goal that we do is that selecting the most promising experiments. Yeah. So despite what model you are using to generate, we are using some meta learning techniques to estimate how much what you are recommending is going to cost and how much its performance is going to be. So it's going to outperform the other ones. So we don't execute them. So what you end up doing is you're using the same model, but you don't execute the costly ones. So you end up finding the best ones faster. Right?
Is that not what a Bayesian optimization does? Because it starts with some.
What will they recommend you doesn't matter about the cost. It doesn't know how much it's going to cost. So if what you are
in terms of computation. Or?
Yes, you can measure it as the energy is going to cost, the money is going to cost you to run this trial, or any type of cost you want to measure. But it doesn't know. It's gonna. For example, if you're for a maximized expected improvement, you're optimizing one metric, right?
Yeah.
And what you will recommend, you may end up in memory, overhead. You may have hit memory limit. It doesn't know the actual cost of that.
Okay. Yeah. Thank you.
All right. Any other question? Yes, Grégory.
Yes, I just have a question for Julien and Thomas. In the end, so it doesn't work, right? So what we have out there, it doesn't work. I mean, there are projects trying to develop that for years. So do you consider the reason why it's not working, because it's just similarity judgment, is because there is a flaw in the decision of the judges? Or is it because we have not found yet the right technique to do it? Because it can be really challenging to decide what is the cause.
Yeah, of course, you know that, of course, the judges can even sometimes disagree with themselves. So it's, of course, a very huge issue of data labelizations. In the end, in legal field, it's very complicated because you have so limited data. So I'm not even sure, given the complexity of the task, that it's even possible to do it. But certainly the current techniques are unable to do it, which I think is probably the major takeaway message that this was actually the main conclusion of my thesis. Should we develop AIs if they do not work? Should we put them into production? And I think that's a major point to address in this case, at least.
Maybe to add, so probably we can do better because we experienced, we identified different flaws in all fields, and one of the biggest problems is that the lawyers and the engineers don't talk together. So that's really, we've been working 5 years together, speaking a lot, exchanging information all the time. So that's how we actually could identify problems in the state of the art, beyond the flaws in the case law. But probably we can do a little bit better, but not that much. So that's the question: is it still like worth developing those things? And the second thing is that Thomas mentioned there is not enough data. In that field, there are a lot of data. In the field of trademark, there are a lot of data. They are formatted the same way. There is consistent basic test for addressing likelihood of confusion. That's not true in most of the other fields of the law. And most of the problems we could identify were related to the fact that we could develop two different data sets that were actually applying the exact same legal rules for the same jurisdictions, because it's possible in the field of IP. In most of the legal fields, it's impossible to develop those data sets because they just do not exist. So that's a very big problem related to responsible AI in the field of legal text.
All right, Leander. Who is your question?
I have a question for Benoit. So
I agree that indeed this seems like a very interesting problem, like the sign language, to work on, many challenges. You were talking about translating sign language to text, which I think is the first, which is already challenging in its own. But what about translating text to sign language? Do you think this is feasible? Are you already looking at that? What are your thoughts?
Okay. So maybe going back to translating sign language to text, what we can do right now is to translate isolated signs. So the problem is that there's no one-to-one mapping between sign language and text. Those are very different languages. For example, the face is very important in sign language, not the same in when you speak. So there is no one-to-one mapping between text and sign language. So currently, well, no one can do that. No one can do that. And it's not necessarily what is most interesting for the community. For example, right now we are more looking into ways to help people that learn sign language or how to support the community. So that's really what if I had to keep one thing from all this research is ask the users. Ask the real users what they need. For example, computer scientists who like to do, like, I don't know, avatars to replace, to automate the signing in videos. And this is not what people want. They hate that because it's not accurate. What they want is really targeted tools to help them, I think.
Maybe by 2030 when we have AGI.
Yeah, of course.
Or
well, you're welcome to try ChatGPT on sign language.
All right. Is there one last question? Okay, I will have one last question for both Yves and also for Benoit. You both were involved either at the university level or you want to propose a course that goes a bit beyond that to bring people, I think, up to the level that we need, both on ethics and AI. Can you give us, each one of you, what are the key competences that you think people desperately need or should have, for instance, for the students and for the audience that you had in mind? Let's start with you, Benoit.
It's difficult to tell. I would say for the students, they need two things. First, they need the technical basis. They don't need to be high-level experts in IA, but they need to learn what an IA is and what it's not. To really know when they're reading bullshit. So that's one thing. And second, they need to learn things from the social sciences, law, ethics, and so they really need to have they need to learn the right question to ask. So let's say I have to deploy an AI in my company. What question do I need to ask myself from a technical point of view and from an ethical, legal, blah 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 point of view?
All right, thank you, Yves.
I would say empowerment to reflect critically. In quantum mechanics, there's this saying, shut up and compute. Like, don't reflect too long about what the quantum mechanics really mean and don't get lost in the philosophy. I think in engineering you have the same. When you start talking about, okay, what does it mean for society? Well, it's easier to tell you, well, shut up and compute. Go back and do serious work. And so this ability to distance yourself a little bit from your own field and reflect on it and feeling that it's okay and that you have to start somewhere, that you're never going to be a lawyer and a sociologist and a historian at the same time. It's not going to happen, but that you still need to be a citizen. So this empowerment, this narratives, having stories to tell, and this critical reflection is like really the core. And then the material is to enable that core.
All right, thank you very much. I think this will then be the concluding words, and I want to thank quite a few people, so the program directors, Anne and Emmanuel for this year, also all the people who made this day possible, the senior fellows, Anya Garone as well, who is maybe not here somewhere, being very busy, and also thanks a lot to Dimitris Leander for this amazing program. to all the speakers, moderators, and participants, of course. So maybe the concluding words to both of you? No. No? All right. Then you're free, yeah?
So, let's... okay, so there's a reception, so there's some drinks, and I'm just here for the photos. So please, all the organizers come up.